expounding their importance in the field. So now I request Dr. C. Vishwanathan, sir, to welcome Dr. Shaman Jha, DDG, Agriculture Engineering, ICAR, with a bouquet of flowers.
A very good morning to all of you. Respected Dr. S.N. Jha, Deputy Director General, Agriculture Engineering, ICAR, Dr. Vinay Saigal, Head Agriculture Physics, Dr. R.N. Sahu, Course Director, Dr. Manjaya, NAHEP Cost Nodal Officer, IRI. So I welcome all of you on behalf of IRI as well as NAHEP Cost Project of IRI. So, sir, this we have the training program come workshop for last 10 days. The training program was on the airborne hyperspectral remote sensing for agriculture, and today the workshop is on UAV technology for agriculture. As we all know that government is promoting drone application in agriculture, this training is an important part. Besides that, for the purpose of plant phenotyping and precision agriculture, globally use of drones along with various sensor is gaining momentum globally, and this technology is expected to reach up to about 8 billion by 2030. That is, the global market is expected to be around 8 billion by 2030 with a CAGR of 21%. So this has a lot of potential in agriculture. So I welcome all the participants, and briefly I would like to about the workshop. Dr. R.N. Sahu will be explaining to you. Just I would like to introduce our chief guest for the inaugural session, as well as the chairman for the first workshop. I would like to introduce him briefly to the audience. Dr. Shyam Narayan Jha, he was born in village Koir in Bihar in April 1964. He has obtained his MTech and PhD degree from IIT Kharagpur, in 1990 and 1993 respectively. After that, he joined as a scientist at ICAR, and he served in various capacities. Before becoming the Deputy Director General ICAR, earlier he was Assistant Director General Process Engineering at Indian Council of Agriculture Research from 2015 to 2022, and currently he is the Deputy Director General Agriculture Engineering at ICAR. His research areas include agriculture process engineering, storage of fruits and vegetables, food product and agriculture machinery, development, food quality, safety, sensor technology, and he has done pioneering research on Makana processing and non-destructive evaluation of food quality in India. SAR is very innovative, and most of our scientists might have listened to his presentation in the DDG. His presentation, he has presented various innovative methodologies and technologies for way forward in agriculture engineering and agriculture in general. His enormous contribution has been duly recognized by various awards and honor. This include the JSPS Postdoctoral Fellowship, a prestigious fellowship of Japan. He was a JSPS fellow from 2000 to 2002, and he has also won the ICAR highest award of the Rafi Ahmed Kitwaid Award in 2011, long back, and he has been recognized with ICAR Chaudhary Devilal Outstanding Accredit Award, and he has been awarded the ISAE Gold Medal for Lifetime Achievement Award in 2018. And importantly, the Stanford University has analyzed the highly cited scientist globally. He is one among the top 2% highly cited scientists in the globally. And he is fellow of National Academy of Agriculture Sciences India. Sir, with this brief remark, I welcome you to this training workshop. I welcome you to IRA. Thank you, sir, for sparing your valuable time despite your busy schedule. Thank you, sir.
Thank you so much, sir, for such a warm welcome. Now I invite Dr. Rabi N. Sahu, Course Director, ICAR IERI, to present a brief note about workshop.
Very good morning to all of you. This based on the dais. Professor S.N. Jha, Deputy Director General Electrical Engineering, Dr. Vishwanathan, Joint Director Research and PI of NHEP CAST program of the IRI, Dr. Binay Sehgal, Head of the Division of Physics, Dr. Manjay Saha, Nodal Officer, CAST program of IRI, and my fellow participants, young researchers, students, and industry partners in today's workshop. Sir, we are very proud and honored for your gracious presence today and such a illustrious scientist working on, again, researchers and students. Sir works on the MIR spectroscopy and he has a number of books published on the, again, MIR spectroscopy applications for post-harvest quality and grading. And you can refer them with studying from basics to different applications. So I think this program has very relevance to you and to close to your heart with respect to imaging spectroscopy, that too in VNR range, of course, also thermal range, and that too an airborne platform. So if you see, there are many imaging spectroscopy sensors, very limited to only VNR, but it goes beyond that. And we have been, in this training program, we have been dealing with starting from the ground sensors to the airborne to the satellite and also manned aerial vehicle. What are the different sensors available in India and also abroad? And what are the possible applications? We have deliberated on that through 15 lectures and 11 practicals and live demonstrations of flying drones with such an expensive hyperspectral camera in the field and also data analytics. And we had also lectures internationally renowned scientists like Melba Crawford from Purdue University, also a very known industry, Edward Photonics, who has been developing different sensors for NASA and also different satellite programs. And we have that kind of sensors with us, and we could expose all these researchers and students, starting from the basics to the applications. So we had 10-day program, 8-day program rather. 7 days we dealt with all the theory and practicals. And last year we kept at a workshop on drone technology for agriculture to make an interaction of the young researchers, students with the industry partners who have been into drone technology since long. And sir, you know, Government of India is promoting so much on the drone technology applications to agriculture. And particularly you, sir, you are very much aware of the Kishan drone program. Very closely you are monitoring and mentoring the program. 52.5 crores has been given to ICAR to spread up that technology, bringing the awareness among ICAR research institutes, SAUs, and also the KVKs. But that has been confined to more to the applications, that is a pesticide or fertilizer applications. But unless until we look for the surveillance, mapping, crop health monitoring, using some kind of sensors, whatever are available with us, like thermal, RGB, multispectral, hyperspectral, we can't go for the application. So the precursor is the crop health monitoring, for which drone remote sensing is one of the key factors. So today's deliberations mainly confined to what are the sensors available, what are the challenges we have with respect to the drone technology, sensor technology, followed by plant phenomics to precision agriculture, how drone technology can be helpful. And also at the last, what are the policies and what are the challenges we have to propagate or to make it popular drone technology in agriculture, particularly in the Indian context. So 3 deliberations we are going to have, and each deliberations with the 15 minutes setting the background, followed by a panel discussion with students, young researchers, and also the industry partners who are participating. Almost 15 industry partners, they are going to be here, and they're already here, some of them, and they have their demonstration also with the accessories, drones, and the fire of this NRL auditorium itself. So this is what in short the program. And again, I must thank to NHEP, ICAR, and also Dr. Vishwanathan, my honorable director, for kind support to conduct this program very successfully, and also allowing and whole CAST team member supporting each and every event what's happening over here. Thank you very much.
Thank you, sir, for your guidance and support throughout the program. Now, I would like to request our chief guest, Dr. Shyam N. Jha, DDG Agricultural Engineering, ICR, for his address.
Good morning to all of you. Namaskar. Sat Sri Akal. Dr. Viswanathan, the Joint Director Research, Dr. Sagar, the HOD, and Dr. Sahu. This is, in fact, it is a great honor to me to call. And in fact, I wanted to come this department, but today I have very less time. Sometimes without informal, I want to see the department labs and other things, because this is the subject which I like and want that this should progress very, very faster rate, at very, very faster rate in the country. But that is not happening. Friends, the airborne, I do not know what is the importance of airborne hyperspectral remote sensing training. Of course, I'm very happy to see that all are, I think, either students or maybe the young scientists. So they all of you will be here by 2047. We may not be. So you have the chance to become the citizen of the developed country. And the developed country becoming, and your passports will be no restriction in the world after some maybe 20 years. So you will be the proud citizens of India. And keeping that things we have to keep in mind. I do know many of you must be knowing remote sensing. I do not know where from in India at the start. How many of you know? I'll tell you, I just being a president of Indian Society of Agricultural Engineers, I am searching some of the key achievement of agricultural engineers, particularly in India and the world. And during the course of my search, I found that remote sensing in India started in IARA. And the name of the person was the S.C. Roy. He was the head of the department in agriculture long back in the beginning of the department. And the department was opened by the government of India, remote sensing department. But somehow it went to other than the agriculture. It was not here. So the start of remote sensing and pioneering is S.E. Roy of HOD, I think he was the HOD in IARI, and sometimes in 1960. So this is the proud, IARI has a lot of things which are not known. So this is one of the things, the historical person. Similarly, the NIR spectroscopy has been started by some of the agricultural applications and basics in food in the USA during the Second World War, because of the quality of the army and other things. And then it came into existence. Friends, agriculture, I personally feel the hyperspectral, any kind of spectral science maybe from ultraviolet to hyperspectral. I personally say that it is a magic box for agriculture, whether it is a soil, whether it is a water, whether it is a plant, whether it is a grain, whether it is a food material. It can be applied, single box can be applied from soil or inside of the soil, maybe soil moisture you can say, to up to it goes to your stomach. It can be analyzed using a spectral analysis. So I personally feel that we have to be developed in we have to develop our quality in that. But what actually 99% of us are doing, we are just even application we are not doing correctly and more accurately. Not you, not me. Most of 99% people are just buying the instrument, having some spectral data. You see, it is a digital equipment, so some data it will surely give. But many times we don't go through that, whether this data is coming correct or not. So we have to calibrate. We have to calibrate our spectrometer very frequently, at least once in a year. Whether it is giving the correct absorbance, reflectance, or whatever data you are getting. So all those things have to be sent. After correction, getting the data, the most important part, which is the most important and time consuming, is the analysis. Analysis of the data, it requires patience and a special skill. Usually what I have seen, most of the paper, yesterday also I was in one of the AIC workshop, people are getting the spectra, are just telling that this is the peak and that's okay. They don't utilize the whole spectra for extracting the information. So that is one part. So chemometrics, that science is called the chemometrics. Chemical analysis of the spectral data is called the chemometry. That is different science. That is neither chemistry, neither physics. It is in between. So combination of both, you can say. Very few people are available here in the country. So I think that we have to train, and no one will, if training you, you can get trained yourself, because you are in the IARI, the epitome of agriculture, I think. And the best department of physics. Physics is the major core area of any science if you say. And here you are sitting, so you can have some kind of hungriness, or you should be thirsty of learning little bit and doing much more than what you have learned, because it requires forces from your within. If no one can force you that sit there and learn this, learn that, they can just ignite. They can give you a matches box, one stick can be burned, and then you have to burn all the matches sticks. That kind of people we are searching. If you are successfully, very good model you have developed, then 50% work is done. But after that, the 50% work, which is fabrication work. Again, here we are even, we can say the zero, because one instrument I wanted to get fabricated, Dr. Sahu knows it, since many years. My dream is that till I die, that a spectrometer should be, NIR spectrometer at least, or IR spectrometer should be manufactured in India. Once it is manufactured in India, it will be very, very easy and less costly, and anyone can attend. And I am trying for that from various sources. People may not be knowing. I have gone to up to the Prime Minister office, gone and other people, but failed. But thanks to the previous DG, that he one day told that, Dr. Shah, you are moving here and there, but Indian School of Science has refused, IIT Mumbai has refused. What is the problem? Why they are refusing? No, they are getting the money fund and then returning that we cannot do because of certain reason and this that. So now we have selected one startup. He told that how much money? I told in the beginning you give 1 crore. We'll make an instrument indigenously. I am searching a person throughout whatever I have the connections. One guy became ready, and they have fabricated first model, that model for mango. It is in IARI. I do not know how many of you know it, but that accuracy is even not 50%. Last year it was not 50% even. So the good thing is that fabricator or manufacturer is ready to change it a number of times. And he come directly to my room, discuss and all these things. Again, second version, they have probably supplied or are likely to be supplied. So I think by trial and error, we will be able to fabricate first instrument, which will be, you can say, the ICR technology based on that. And once he will be able, he told us, sir, once I will be successful, then we can develop all series of wavelength, spectrometer, other things. So friends, I would tell you that rather going through the theory knowledge, application part, go to the fabrication mode. Just like I will tell you, the Indian students are excellent in coding in IT industry, coding. The person who are coding, doing the coding in programming, they are not much more known as computer science or computer engineering. They are just expert in coding. So we want that IARI and some of the institutes should engage some of the students just for fabrication of electronics item. Because you may not be around 37, 38 thousand crores instruments are being imported in the country. Even government has not noticed this. Our government is very good. They are doing to become independent and most of the things, self-reliant. But in this side, no one has telling. So how much instrument, good instrument, we are buying 99% from outside. So we have to be our fabricator house, particularly for agriculture related instrument machinery. We should be strengthening our capability for fabrication and then testing, then of course commercial manufacturing. But again, here only new guy can do. I understand that the person who has 40 years or more than that, it is very difficult. I learned this subject when I was less than 40, and I saw somewhere and then told I leave it and I have to read it. And I should not tell about myself much, but finally I wrote a book on that. And most of the data in that book is from Indian agriculture, our work only. And books are being sold in all over world. In India, very few copies have been sold. But other countries are getting, I am getting almost 20,000 to 30,000 US dollar or sometimes euro royalty since 10 years. So uska sale abhi bhi kam nahi hua hai. So that, because that is a totally practical book and with some little things. I think Dr. Sahu and his team in this physics is doing a wonderful job. And some of you think to do differently. Don't go by conventional. You may get some problem in the future. Your boss, your employer, your guide, teacher may tell तुम कुछ नहीं कर रहा हो, कुछ नहीं हो रहा है, 6 साल हो गया, 5 साल हो गया, nothing has come. But after 6 years, 5 years, whatever will come, that will be wonderful, and everyone will appreciate you. When we started this work in 2000, people were laughing that how it happens. First laugh I had faced in NDRA in 1996-7 when the first case of adulteration in milk came. And I was a young scientist, just like a new scientist who joined. And our 220 scientists were discussing that how to detect the adulteration in the milk, which are coming here and there, only 1 or 2 news in a year. Just I read that I can do it. But how you can do it? I replied to Joint Director Research. I will not take the name, they were there. I will do it by sensor and it can be done very easily. But it required some money and some 1 year, 2 years, and the whole hall laughed on me. That how he said ये तो engineer हैं, ये सब कुछ कहते हैं, सब कुछ कर दूंगा. मैं कहा सब कुछ हो सकता है सेंसर से, but it requires time and some facility creation. But nothing happened. But that laughing was in my mind when I went after 2-3 years in Japan. Out of my project, I tested first milk, adulterating milk ourselves in Japan, and testing all the spectrometer where it is possible. And one friend from NDR, his name is Parikshit Bansal, he is not now in ICR. He gave me all the formula of artificial milk from here. And we are making I was making, because Japanese were least interested, that was not our part. It was extra job for me to prove that whether NIR can do or not. Then I wrote first paper in 2002 that what are the wavelength for all kind of adulterant which are more sensitive. And then going on reading books and other things. So I want personally, and I'm trying to train some people. And one decision last month in Assembly, Dr. Sahu, I have taken that we are going to form a National Working Committee on Spectral Science, Spectrometer, in which some of the startup will include and some of the manufacturer will include, of course, in India, from India only. मैं तो चाहता हूँ जो हर कुछ इंडिया में ही बने. And we'll meet at least twice in a year to discuss and have a very good circle of that person, so that we can speed up the manufacturing part, analysis part, experiment part we are doing. We want a manufacturing part. So that's why I have already kept in my proceeding of our monthly meeting. Maybe in 2-3 months, we'll make a committee and then we'll progress in that. But I want some of you come forward to do and read books, write those things, and come to any person. Don't hesitate to discuss. If you have something weaknesses, don't hesitate in that you don't know. Many times people say, "अरे मेरे बारे में इनको पता लगा, मुझे ये भी नहीं आता." तो शर्म की बात है, ऐसा नहीं है. वो 1 मिनट में होगा, but after all, you will be the winner after some times. So I request you all and suggest also to don't keep anything in your mind which is hunting you again and again, because it reduces your ability. It reduces your ability. It reduces your learning aptitude. So whatever is coming in your mind, tell to your advisor, tell to your teacher, even tell to your friends. There is a story, na, if something in your mind, then your stomach will फूलता है, पेट फूलता रहता है कहते बात में ना, तो उससे बीमारी भी होगा. So it is better, whatever you have the doubt, whatever you have the problem, discuss, finalize, so that your brain should be not overloaded with unwanted things. And because physics requires, of course, brain, and all are physics people here. So if your brain is occupied by something else, then efficiency will be less. So this is my advice. I will be in touch with Dr. Sahu. Already we are in touch with some project, and unofficially whenever he comes there, I discussed the issue. But I will tell you, I am not satisfied. I am not satisfied the speed we are doing. We have to do much more, and we see particularly the youngsters, and you can do that. This is what I thank you, Dr. Viswanathan, the director ARI, to invite me, Dr. Sahu particularly, and all of you. Thank you very much.
Our wholehearted gratitude for your best wishes and motivation, sir. I would now request Dr. Vinay K. Sehgal, Head Agricultural Physics, IERI, for a vote of thanks. Sir.
A very good morning to all of you. It is indeed a matter of pleasure for me to propose a vote of thanks on behalf of Division of Agricultural Physics, Indian Agriculture Research Institute, and on my personal behalf. At the outset, I would like to thank our chief guest of this today's event, Dr. S.N. Jha, DDG Agriculture Engineering, for his gracious presence, sir, for taking time out, and also setting forth the direction in which we have to work for this younger generation of people who are getting training and attending workshop, and as well as for we faculty members who have to mentor them in that direction. And sir, we are thankful to you for emphasizing that it is not only the theory, but it is the finally product and practical applications which should serve our agricultural sector, our stakeholder, the farmers. Sir, we take it in right earnest, your suggestions, and would strive to work and achieve those. Sir, at this moment, I would also like to apprise you that it is true that remote sensing started at IRI, but the first experiment, sir, happened between IRI, ISRO, NASA, and RRS Kayangulam in Kerala. And it was the Division of Agricultural Physics, where NASA given us a Hasselblad camera, which was a multispectral camera, and we had put it on an airborne platform in a helicopter and worked out whether we can use that camera to detect coconut wilt disease in the coconut trees. So, sir, that was in 1969, and 2019 we celebrated the 50 years of India's first remote sensing experiment, and 14 space agencies were invited in this campus and they participated. And of course, we have been closely working with agriculture engineering and water technology center, our environmental science, where we make use of remote sensing technology for research of our students and projects. Then I would like to thank our beloved, respected Dr. C. Viswanathan, Joint Director Research of IRI, as well as the PI of NHEP CAST, for his wholehearted support, guidance, and availability his accessibility at any time for sorting out any of our issues and given a overall guidance. Rather, this workshop and training was his insistence, which was getting delayed due to Corona and all. Then I would also like to thank Dr. Manjaiya, the nodal officer of NHEP CAST at IRI, for his unfettered support, for his follow-up on every small details and guiding us, supporting us in every way possible from administrative side as well as from the scientific side. Last but not the least, I would like to thank my colleague, Dr. Aryan Sahu, his team, co-coordinators Rajkumar, Rajiv, and other team members who have made this training possible, a very illustrious training which has been going live on YouTube also and being attended and looked up by many people across the world, and on a topic which is very, very topical, which is of very importance in the current context where the new technologies of drones, drone remote sensing or drone-based applications are coming into play. And we see across the board that most of the startups are coming in this area. And ultimately, this is going to support our Government of India's initiative on digital agriculture. So with that, I would rest my talk, and also at the last, thank all the attendees and trainings as well as industry partners who have come to join this workshop. Thank you all.
So immediately we'll resume the session 1. I would request again Dr. Jha Sahab to chair the session. The technical. So then I would request, with your kind permission, Dr. Sehgal Sahab to chair the session, and also Dr. Manjaiya Sahab to be the co-chair. Then maybe we'll just take 5 minutes break and we'll resume the session. We are delayed. I think our speaker is waiting, and we'll resume by 10:25. Yeah.
मीटिंग समझे। सकती थी नेक्स्ट ईयर करेंगे, तब नहीं रहेगा। फिर वो दिसंबर में होगा ना। तुम कब आए थे? मेरा आ गया था नवंबर में। अब तो 2 साइकिल कर दिया हम जनवरी जुलाई से। जुलाई वाला नवंबर में। नहीं लगाया है, हल्का सा। मम्मी बहुत सिंपल है। मेरा आज क्या है प्रेजेंटेशन, उसमें में साइन कराया ना। अभी तो बोल रहा था टोन एकदम हाई फाई लगता है। क्या है ये? क्या है? खाली है। कौन वाला? मैं तो बैठ गया था। इससे अंदर में फोन में आइसक्रीम नहीं होता है। कैसे देखते
बटन की तरह सा आता है लेजर बटन
किसमें?
टेबल बटन पे बन जाएगा ना आपको शुगर का इंटेक बॉडी में आ रहा है हमें क्या लेंगे
ये रीड नहीं कर रहा है। क्यों? नॉट रिकॉग्नाइज क्यों बोल रहे हैं यार? इसमें ही मेरा है। क्या होगा?
speaker for the today's session. I would request Professor Binay Sehgal to chair the session. Dr. Jha had some meeting in ministry, so he has to rush. And also, I would request Rajkumar to be the rapporteur. I would request to introduce the speaker, and Sir will moderate the whole session. Thank you.
Very good morning to all of you. I'm very extremely happy to introduce a distinguished speaker, Dr. Shefali Agrawal. She is now currently Group Director, Department of Photogrammetry and Remote Sensing, Indian Institute of Remote Sensing, Dehradun. Her field of expertise is in the remote sensing, image analysis, and satellite photogrammetry and LiDAR data processing. Basically, her education was in BS in MSc in physics, and she also completed postgraduate diploma from integrated map and geoinformation production from the ITC Netherlands. And she has been credited with many awards like ISRO Award for Best Women Scientist, Astronomical Society of India, and she has been a referee of many reputed journals like International Journal of Applied Earth Observation, Geoinformation, Journal of Geomatics. So I welcome Dr. Shefali Agrawal for today's session for your excellent presentation. Thank you so much.
Thank you so much. I would really like to, a very good morning to all the participants, and I would like to thank the organizer, especially Dr. Sahu, for inviting me to express my views on this topic. I hope my slides are visible. Hope my slides are visible.
Yes, ma'am.
Okay. So without taking time, I'd like to begin with this topic on UAV remote sensing journey till date in sensor platform and data processing. As you all know, the use of UAVs has surged in the last 2 decades, making them a very popular instrument for a wide range of applications and leading to a number of scientific contributions, scientific publications in the field of remote sensing and its application, because due to their basically flexibility and moderate costs. Now, as all of you are aware, working in the field of remote sensing, the journey of remote sensing started with aircrafts, and then subsequently satellites came into being, and which still is being used effectively for various applications. But the advantages of drones are they have a significant advantages over the satellite data. Like satellite data has an advantage that they provide a significant coverage. They have a wide range of spectral capabilities. But one of the major drawback is the spatial and the temporal resolution. Though we have high spatial resolution of 30 centimeter, but the cost of the data is extremely high. Temporal frequency, we get weekly or bi-weekly, so one doesn't get a data when, and in certain cases when he wants the data, when it is needed. And in contrast to this, the aircrafts also provide a very high spatial resolution data. They can go up to centimeter level, few centimeters, but are expensive and are susceptible to weather and other conditions. So cloud conditions, they're affected by them. So drones are somewhere between the satellite and aircrafts and ground observations. And as I said, they are flexible, they are moderate cost, and they they play a very key and complementary role in the entire process, especially in some of the applications, like if you talk about where time of the data is very, very crucial, the information is to be obtained and disseminated as quickly as possible, like in case of disasters, or if you go, they offer a very high versatility and flexibility. And they can operate, it can be operated rapidly without planned schedule. They have flexibility of operations like fly everywhere, every time. You can install any sensors, and they are unaffected by clouds. You can fly below the cloud cover, and very low altitudes where we have experimented, even in the cloud coverage where there are more medium level clouds, foggy conditions also, you can fly and get a subsequent good quality data sets. And they have in recent past, due to the contribution of different fields, robotics, computer vision, AI and all, they have helped evolve this technology of drone for various applications. So drones are can be categorized by their performance characteristics, which is including the weight, wingspan, wing load, range, maximum altitude, speed, endurance, and production cost. These are some of their design parameters that distinguish one drone from the other. Right, the horizontal range of different platforms is also limited by the power of the communication systems, which actually, because the which ensure contact with the ground station, again ranging from few meters to kilometers, which is called as a line of sight. So there are, range is one aspect, weight and size is the one where the Indian DGCA has categorized them into 5 major categories: nano, micro, mini, small, and large. Right, so further, based on the aerodynamic structure, UAVs are also classified into 2 types: rotor wing and rotor and fixed wing types. Rotor UAVs depend on multiple rotors and propellers like a helicopter, which is attached to them to generate the required amount of thrust to lift them. Similarly, the UAVs with the fixed wing types will depend on their wings to produce the aerodynamic effect for lifting like an aircraft into the air. And combining the advantages of both hybrid drones have been developed, which combines the advantages of fixed wing and the multi-rotor, because multi-rotors can be taken off and landed at any point from any location. They don't need a specific space, whereas a fixed wing requires a area to take off and land, so they require a subsequent space. So in certain undulating conditions, rotaries play a significant role, but endurance wise, for a duration, for how long it can fly, fixed wing have a longer endurance as compared to the multi-rotors. Multi-rotors can be stationary at a point and collect data set for a quite significant time, whereas fixed wings cannot stay at a point. They need to continuously fly like an aircraft. So combining the advantages of both, hybrid drones have also been evolved of late, which is becoming popular in many applications. Now, if you talk about the hybrid drones, as I said, they have also the advantages of batteries and fuel combined to maximize their power efficiencies, and they can fly longer with higher payloads in adverse weather conditions. So, for example, Amazon is also using hybrid drones for efficient parcel delivery using these hybrid drones. Drones can be equipped with various sensors and cameras. Compared to the conventional airborne systems, drones operate closer to the ground. So as compared where aircrafts fly a few kilometers, thousands of kilometers above the Earth's surface, drones fly a few 100 meters from the Earth's surface, much closer to the ground, and have constraints given the payload and the speed of the platform. So initially, these cameras, which were adapted versions of the terrestrial applications, they were compact cameras, the normal cameras which we used to do, which has been replaced now by a various new generation of dedicated sensors for various applications like multispectral thermal sensors. And one of the most limiting factor for any kind of a sensor equipment to be placed on a drone is its maximum takeoff mass and the size. For example, if I say if a drone has a maximum takeoff weight of around 25 kgs, the maximum weight it can uplift, 150 megapixels camera would be the best option and can be integrated into the drone platform. For a more standard for a lower weight drones like a 5 kilogram maximum takeoff weight, 20 to 60 megapixels. So it is all governed by the size of the drone, to what level it is flying, the speed, and all the platform stability consideration. The kind of sensors can be integrated into the drone platform. Then the cameras which are placed, since again, as I said, they fly closer to the ground, the ground sampling distance or the spatial resolution is a few centimeters. The camera should be placed, the camera which needs to be placed on any kind of a craft need to have a fast shutter to avoid the motion blur due to the absence of forward motion compensation. So initially this was an issue. Initial cameras had this problem, how to integrate and get a data which is blur free. But now subsequently with the advancement in the technologies, the cameras which are coming up with mechanical and electronic shutters, which enables them to give you a motion-free, blur-free images. So the UAV started with traditional off-the-shelf cameras, but now today many, as I said, dedicated, good, high-quality sensors have been evolved. So we have a range of sensors, which we said a simple RGB camera, multispectral cameras, ultrasonic sensors, infrared thermal sensors. So any kind of sensors based on the applications can be designed and are integrated onto a drone platforms. So earlier, it was basically the sensors mapping of the drones was used with an RGB camera, which was designed either a simple modified multispectral cameras or modified RGB cameras, which had capability. These cameras were equipped with a Bayer matrix based mosaic filters to capture the spectral data in 4 bands, so the red, green, blue, and the infrared. But now multispectral cameras are available, which can offer you the bands of from 3 to 10 spectral bands, optimized on the specific spectral regions, which is ranging from blue, green, red, red edge, and the near infrared. So initially, they were modified multispectral sensors with the filters to collect the data in the infrared. Now, currently, we have many multispectral sensors available. So these are current cameras on multispectral cameras, which are available in different weight ranges, which can be integrated onto a drone-based platform. So for different companies, which is up to a range of 10 spectral band capabilities are available. So similarly, thermal cameras are also available, which operate between 7.5 to 13.5 with a weight of around, ranging from 300 grams and above to that, and accordingly, the resolution capabilities. So similar to the hyperspectral, your drone-based hyperspectral cameras are also still predominantly in the scientific and the research purposes. There is a lot of development happening in the hyperspectral sensors for the usage in the drone platform, because they are relatively expensive, slightly heavier than the multispectral or the thermal cameras, and they capture vast volumes of data and are more challenging to operate and process than a multispectral camera. So that's why the popularity of the hyperspectral on the drone-based platform is in the evolving stage. And basically, these hyperspectral sensors which are coming in the drone for the drone platforms are classified into the category of operations as a push-broom cameras, 2D cameras using hyperspectral imaging techniques, and point spectrometers that integrate spectral signatures over a single point of the sensor, and they do not provide a continuous image. So hyperspectral sensors are operating in different spectral sensitivities from visible to near infrared. So we do not get a combined solution of in the drone platform of a hyperspectral sensor which operates in the complete range from visible to the shortwave infrared, but there are separated out in the visible near infrared from 400 to 1000, from 1000 to 1700, in the shortwave range from 1000 to 2500, and in the middle infrared from 3 to 5 microns. So the middle infrared, the middle wave infrared and the long wave infrared cameras are not very popularly used due to a large weight. So these are few hyperspectral sensors, which I said from the table here, which has been offered, which gives you data in 2D and 1D mode. Similarly, the other sensor which has become recently coming up in the field of on drone platforms are the lasers. So the lasers basically fill the gap between the traditional airborne laser scanners and the terrestrial mobile laser scanners. So compared with the airborne laser scanners, the drone allows for a denser point clouds and easier operations as compared to the aircraft, and they are low cost and very good for carrying out work or research in a small project area, and a short response time, which is not there in comparison to the aircraft. So compared with the terrestrial and the ground-based laser scanners, drone-based laser scanners provide a multi-directional perspective that frees the platform from moving from the ground. So you can collect it across the building. So you don't need to move. So it gives you the flexibility to turn the drone platform and collect the data from all directions. So the wider field of view of the drone platforms, drone-based LiDAR sensors, offer a 360-degree rotation capabilities, and that enables improved capture of the vertical features such as buildings, walls, which are basically challenges when you operate it on the ground mode. So these are few geodetic LiDARs which are available, but then again, LiDAR sensors have a challenge. Again, the volume of the data plus the weight of these sensors are also on a, if you have a good point density based LiDARs for the drones, you have the weight is again an issue, which is basically in the range of goes to 1.5 to 3 kgs of the weight. So the use of LiDARs in the drone platforms is basically helps in mapping the infrastructures, which you can see the kind of data which you are getting is used for the infrastructure projects. Now, drone-based SAR sensors are also available, but then there is a limitation with them. They are not, the weight of these are basically more than 7 to 8 kgs, sometimes even beyond that. So, and the cost is very enormous. So they are still in the development stage to get a miniaturized SAR sensors, which can be effectively used on the drone platform. Though they exist, they require a larger aircraft, the drones based systems, which is in the larger categories to install these drones and these SAR sensors. Now, basically, the drone data processing workflow, if you see, if you can categorize into 3 categories. One is the planning and uploading, planning for the data collection. Then you fly and collect the data and then process the data sets. So this is the complete hardware which is required, hardware and software. You need a drone system, the sensor, the, as I said, planning module, how to plan your flight, data collection, and then processing. You need a powerful workstation because the volume of the data is so high. It goes in terabytes. There to process, you need a good system. Now, the success of any drone campaign to a larger extent depends on the pre-flight planning which you do. So UAVs normally come with a mission planner that can help you plan your flight or plan your data collection easily. Initially, these softwares were not very robust, but of late they are a lot of flexibility and additional features have been added to these mission softwares, which enables you to plan the entire flight mission by selecting and defining very important parameters which are required for the entire successful data collection. And they also provide the flexibility to modify the flight parameters, enables both topographical map and imagery view so that the study area can be delineated, marked, and the data can be collected effectively and efficiently. So nowadays, they are also equipped with the fly along the terrain, flying with the terrain. So even as to maintain a uniform scale, the altitude of the drones vary with the terrain altitude. So following the terrain, these mission planning softwares, they provide you the basically the facilities to mark the areas over which you can collect the data. They also help you show you the battery life. The UAVs operate with batteries, so the lifespan of the battery determines how long this will stay in the sky, and it will show an indicator that the battery is running out, so you can bring back the drone. So all these parameters can be planned effectively using the mission planning parameters. Now, in order to correct the positional error in the data collected in the drones, The ground control points or the GCPs are required to collect this. GPS survey is required, but nowadays most of these drones are equipped with a DGPS or a real-time kinematic equipments, and many manufacturers are also now providing the post-precise kinematic technology solutions. So with the addition of the RTK or the PPK technology on board the drones, the requirement for collecting of GCPs on the ground is not there, but the weight of the drone increases. So the cost and the weight of the drone increases. So if one wants to use these drones, you get directly georeference data sets which can be used for further applications. Now, technological advancement, which is the key trend in gaining popularity in the drone, is in the software market. Major market players are concentrating their efforts on the implementation of the advanced software that helps in drone automating drone flying and picture data transfer and give you a survey gate result. So basically, the drone data processing or drone software market, if I talk about, is in two categories: drone management softwares, which is the mission planning and all other applications, and that is also related to the collision avoidance, obstacle detection, algorithms for fusing all signal transmissions through connected sensors, different sensors which are on board the drones. And the second market, which is on the drone data processing or drone data analytics. So initially, the current approaches which is available in most of the softwares which is there is on, as I said, flight planning is there, image acquisition, image triangulation, georeferencing, auto image generation, and feature extraction. But the main challenge lies in direct georeferencing with the GNSS data if you are collecting it with ground, or how precisely it is being georeferenced with the PPK or the RTK technology. Data fusion with different data sources. That means how this data can be integrated with the data collected from satellite or other platforms or from ground-based data sets. That is, the accuracy, the spatial resolution of all of them are different. So data fusion categories. Image corrections, because sometimes large-scale differences, illumination changes, occlusions, convergent images are there. And another area where a lot of work is going on automated and real-time data processing, and so that you get real data. So drone analytics for real-time data processing, like agriculture, where farmers can benefit, help track water, crop health, heat signatures, soil analysis. So these are there where many companies, even startups, have started. Investing heavily in this sector. Then cloud-based softwares, efficient database, big data, because this data lies in the category of big data. So cloud-based data, the softwares which are there. So these are the areas where still, and specifically with hyperspectral data analysis, with, again, there are a lot of challenges in processing the hyperspectral drone data sets, correcting those data sets and analyzing those data sets. Then another, I think we'll come to this later on. The applications of the drone are many. They have a range of potential depending on the type of sensors which can be fitted. So you can provide an information at a very fine scale can be captured and extracted. Subtle slope variations are captured, which are very difficult to map from a satellite-based platforms. The UAV remote sensing, with the strength of the high spatial temporal resolutions, have potential in various applications, ranging from infrastructure, urban planning, pipeline, construction areas, and agriculture areas. So this is a small survey which was done where the utility of the drones in the different sectors was assessed and or being used, where it was observed that besides the agriculture, the drones where are effectively used are in the construction areas. So where land survey, building inspections, monitoring of construction projects, security control, creating a building information models for monitoring infrastructure projects. So these are the two critical areas. Mining, of course, is there, communication is there. And now it is finding inroad. And another area which is it is coming up is in the disaster management. So drones have a very significant role in the disaster management sectors. In many disasters, they have assessed, helped. Even in the pandemic, COVID has played a very significant role. So drones, in collaboration with the IoT and the artificial intelligence, plays a very vital role, specifically in the smart city development. Smartness, what we call about, is the relates to the quality of life, health care, public safety, disaster, energy efficiency. So in all the sectors, drones are coupled with IoT and the AI can play a vital role. Specifically, as I said, in agriculture, where a lot of emphasis is given by the government of India, and this is one of the major sectors across the world where drone is effectively used in all aspects of the agricultural applications, like crop monitoring, soil assessment, crop protection and fertility, insurance, irrigation and drainage. So they have a very significant role and is being widely used in this sector. So these are some of these commercial UAV data processing softwares which are available and effectively used. And still the major players in the software market is the Airware, 3D Robotics, your S3 drone, Pix4D. These are commercial, but there are open source open softwares are also available in this efficiently enables you to process the drones up to drone data to a certain level. Now, there are certain technological trends which are there in the drone technology, which is happening is the integration towards a larger drone sizes and powers, drone integration with artificial intelligence, machine learning, predictive analytics and the cloud. So drones integrated with advanced camera, sensors, and AI technology can have a better understanding of their surroundings and can navigate map areas more efficiently and accurately. They can track and monitor the movement of specific objects or life forms and offer a precise feedback which can be stored in the cloud platform. And you can do, once the data is available in the cloud, one can do a real-time data collected do a real-time processing and decision making. So it will ensure a rapid capture and processing. The drones, which are AI powered, they can collaborate and access, they can do a predictive learning models can be developed. They are there in the phases. Many companies and many startups are working towards integrating AI with the drone data for the real-time data processing. And besides classical use of the drones for mapping applications, new and more challenging operational scenarios are emerging, where we're towards the development or the use of collaborative drones, which is also known as swarms, and integration with other systems such as unmanned ground vehicles. So these are also small areas where a lot of work is going on. So as the collective drones, the major advantage being that these drone platforms have a limited payload capacity, and therefore one or maximum two sensors can be placed, and they have a limited flying time. So if we use two or more unmanned platforms in synergy mode to perform a cooperative or combined exploration and mapping for the mapping aspects, such as executing complementary tasks for data collection, information sharing, path planning, or in these areas. So these multi-drone collaborative operations, they will offer a higher scalability of operations, and there'll be reduction in the risk due to redundancy. So these are some areas that they're also useful in the search and rescue operations. Then what we are also observing is drones are going to increase with a larger, will become bigger, stronger, and will have an increased flight time. They will become smarter. And the main areas where the more focus is there to offer drone as a service. So drones will get very powerful engines. They will be fuel efficient, better endurance. They will become bigger and stronger with advanced sensor, miniaturized sensors in different areas. Drones, as I said, will become smarter with AI. And one area where a lot of focus is happening is drones will emerge as a service model. They will be service provider. Drones as a service will be one key aspect. The integration, basically the integration of the 5G technology and cloud computing technology will make drones as a service. Will come as a service sector. So that challenges are there in working with drone areas in terms of regulations, the processing because of the data volume, but the benefit of drone technology is much higher as compared to the challenge. In India also, India is moving towards achieving, as per the government, India would be a drone hub by 2030. So India's drone market is being capitalizing at a faster pace, and there are many startups which have come up, which is now working with innovations in both in terms of manufacturing as well as to make it fuel efficient drones. So there are many companies which have come forward, and in terms of data processing aspect also. So the major innovation is in terms of drone as a service, which is one of the biggest innovation in the days to come. Then in terms of government is also promoting, like during the budget in 2023, the government announced Drone Shakti for the expansion of emerging technologies and drone to stimuli in the area of agriculture and farming sector, in which they promoted or announced the Kisan drones will be promoted for digitization of land records, crop assessment, spraying nutrients and insecticides. And last year in February, there was this Kisan Drone Yatra, which was an initiative by one of the private company, Garuda Aerospace, where they flagged off around 100 Kisan drones in various cities and towns across the nation to spray the pesticides across the state of India. So these 100 Kisan drones were spread across 100 villages in 16 states across India, which includes UP, Punjab, and Goa. So if we see, drones have a significant, future in, and there'll be innumerable applications which are unthinkable at the moment. New areas, new application areas will emerge, and the technological trends to make drone fuel efficient, use of hydrogen fuel cell technology, the collective drones or swarm drones, AI deployment of 5G, use of AI, making the drone smarter, and offering drone as a services will be the influence of the market in the future. So with this, I would like to conclude. Thank you.
Thank you, Dr. Shefali, for an illustrious presentation covering all the aspects of sensors, platforms, and image processing, data processing from them. I'm thankful to you for taking time out and setting forth the agenda for this discussion session. Now coming to our discussion, actually, originally it was planned as a panel discussion, but I would like to say that it is a discussion session, which is where every participant, whether he is sitting physically or is online, can raise their hand, and we can start and put up their views, their concern, or whatever they think is important related to these three aspects of UAV technologies. So we would give them an opportunity for a brief period of time and ask some of the industry partners, our own faculty members, and some of you may even provide the response to some of the questions or discussion points. So with that, shall we start with the discussion? Coming to the important aspect of sensors, as has been clearly pointed out by Dr. Shefali, that of late, numerous sensors coming from different agencies, industry partners are coming into the market. But what is important is we are looking forward to, one is how many number of bands sensitivity they are providing at a lower weight and lower cost. And most important for us, like we scientists who deal with the physical quantities, we are looking forward to such kind of sensors which are having high fidelity, which provide data with high radiometry. So Dr. Shefali has mentioned how from multispectral to thermal to middle infrared to hyperspectral sensors are coming into the market. So I would request some of our industry partners, like I think we have partners from Headwall, Electrotech, and others. If they can give a view of what current status is briefly, and what we are looking down the line another 2 to 5 years period of time in terms of sensors, especially the type of bands, sensitivity, and their weights, and of course the cost. Thank you. Yeah, we have a representative from Electrotech.
Good morning, sir. Thank you very much for all of you. We have been dealing with some scientific instruments for the past 35 years, and we have been in this field for more than 30 years for supplying scientific research instruments. And one of the important things, as Dr. Shegal and Dr. Shefali said, is when it comes to the hyperspectral remote sensing, and particularly for a drone-based application, the technology is very important. And what we associated with Edwal Photonics do is the push broom scanner, which is something like a line scanner, and which is one of the preferred technology for drone or any airborne applications. And another thing is we also have the required swap, size, weight, and power, which is required for a small drone applications. And the one which we have is nano hyperspec, which is of 400 to 1000 nanometer, roughly with 800 grams and less than 1 kg. So that is a size, weight, and power we have for the small drone applications. And also one of the big advantage we have is we also have the full range sensor, which is called the co-aligned. We have 2 sensors in one enclosure, 400 to 1000 and 1000 to 2500, so that you can fly and simultaneously you can capture the full data set. And also another big advantage Edwal has is we can also integrate a LiDAR to this hyperspectral imager, so that you can acquire the LiDAR data also simultaneously. And the LiDAR data can be used for your DEM creations. Because most of the DEM we use is SRTMs, which is of something like 90-meter resolution. But once you have the LiDAR also with hyperspectral, then you can create your own DEMs, which is much more accurate, so that you can do a better art rectification. So Edwal and we are associated with them, and we are working towards this to provide you more scientific data and with a very cost-effective solution. Thank you, sir.
Yeah, thank you. Do we have some other industry partners who are working in providing sensors?
So hi, good morning, everybody, online and offline. So basically, My name is Anup Kumar Upadhyay and I represent IoTech World Navigation Private Limited. So India's first DGCA approved drone company in India. And so our drone that we have got approved from DGCA, as Shefali Madam also said. So our drone is a multi-purpose drone. So when I say multi-purpose drone is, it mounts all sorts of camera, whether it is RGB, multispectral, LiDAR, hyperspectral, and all the bands, whatever is required for research and development purpose. So our drone is able to carry those sensors. And since this drone is a multi-purpose, so it also sprays, so as Shefali Madam was saying, that a lot of research is going for adaptive spraying. So, we have developed a drone that, carries camera, and it also, by using the NVIDIA processor mounted on the drone, we try to do real-time processing, and we are doing a lot of research on adaptive spraying. So right now what happens is, in the mission planner, you go and do a mission planner using Google Map, and then your drone goes and spray accordingly, depending upon the swath and all those things, right? Whatever parameters we set. So but when you mount a camera, multispectral camera on that, and then if you have a AI ML feature implemented in the NVIDIA processor, then it collects the data from the field and then processes, and then it gives command to the spraying unit mounted on the drone to go and do spray, So that is like adaptive. So no need to blindly go and spray the whole acre, but you identify the spots where the infestation has happened. And then because these all are geo-logged, so drone can go and spray at that particular location online also and offline also. So both facilities are there. Apart from that, the drone that we are having, it also does a broadcasting of seeds of granular areas and all those things, So we always try to build the drone on tractor model, so that a person who purchases a drone, he not only does the precision, agriculture, but he also goes and implement, many others. So it's something like a multi-purpose, so that a person can use that drone, good amount of days in a particular calendar year. So that is the motivation. And since, as DGG SN Jha sir also said in the morning session, that we have to focus more on indigenization rather than, depending upon the outside, and we have a motive. So we are working very closely with Sahu sir. He's, tremendous. He has given a lot of guidance to us, to the industry, to shape the drone technology that suits to the benefit of Indian farmers. We have to design so that the drone technology proliferates up to the farmer level and provide them the benefit. So under the guidance of Sahu sir and the various other eminent scientists from IRI, we have a focus or ambition to double the farmer income by using the aerial robots. So thank you, and to take up any question. Thank you, sir.
Okay. One question. Drone platform is your indigenous, but what about the imaging sensors?
Sir, on imaging sensor, we need to work. So we have taken up some project with some of the scientists, but it is still in a very initial phase. But we have to develop some indigenous, highly accurate and low cost, so that it becomes affordable for our farmer friends and agri entrepreneurs. So we have been working with scientists on that.
So already work has been initiated,
Yes,
research
yes,
has been
yes,
initiated.
yes. Under some of the NAHID project or some DST project, we have been getting involved.
Okay, okay. Thank you very much.
Thank you, sir.
Do we have any other industry partner in terms of providing what platform and sensors they are providing? So it will give us an idea where the current industry stands.
Good morning, everyone. This is Fahimul Islam. I'm from. Thank you, everyone, for being both online, offline. So I'm from Dronix Technologies. We are based in Chennai. We are also making drones and also working on drone as a solution. So like what we have been discussing so far, drone itself is not complete. The payload that it carries makes the difference for the drone. So we are closely working on how to improve the whole technology. We are taking feedback from the market, from the clients, to understand how we can improve the whole system as a whole. So like it was discussed in this workshop regarding big data, transferring the data to the cloud. So our team is working rigorously on those aspects, so that, like, for example, let it be from multispectral camera and hyperspectral camera, definitely the data is quite big. So we still are working on that direction. So let us assume we have a data from multispectral camera, so we can just upload it to the cloud, so that we do not have to have a fuss of taking that SD card or something like that. So we are just working to make it more autonomous, more efficient, and in the process maybe contribute to the community. So we have various categories of drones as well. Right now we are working on heavy payload category drones as well. So we are working with various industrial partners in India to see how we can step by step improve the indigenization of our drones. So initially, like how, since drones is a very on the dawn of the technological development in India, so we have slowly started manufacturing drones in India right now. And as for the payload part, we are working with various partners and seeing the possibility how we can make it in India itself. So since this is a very dawn age for the technology for drones, so definitely I believe in some years we should be able to see payloads being manufactured in India itself. There are some more startups coming out on the payload categories as well. So we are working closely on them, and so that we can provide drones not as a drone as a product, but as a complete solution, so that you would be able to use it as a complete product and get the output at the best way possible. Yes,
okay, thank you, Mr. Islam. You have pointed out an important technological development which you are working on, that is on the fly downloading the data,
yes, sir,
to the cloud,
right, yes,
and
sir,
then doing the processing.
right, yes, sir,
But like I have been involved in satellite remote sensing for past 30 years,
right, sir,
and we have marvelous sensors which have been put on the satellites. But one of the major constraint which is coming, the bandwidth of transmitting a very large amount of data in real time.
right.
So you have already cracked the problem, or there are solutions which you have been working on your team?
Yes, sir. So we are working on that technology. And since right now 5G has come also into the picture, initially we were doing activities like sending photographic images through from the drone to the cloud itself. So let us, and even there are softwares that help on complete processing of the data without any human input. So those things can definitely be done. And we are further working with possibilities of using 5G or better connectivity as well, so that we can transfer as much data as possible from the drone directly to the cloud system, and then get the process data as fast as possible. And maybe I think going ahead, we can see some real-time processings happen as well, so that we can get faster informations and then react to that as fast as possible. So that is something we are driving towards, and maybe hopefully we can crack it as soon as possible. Yeah.
Other solution what IoTech has presented, that
right,
you put an onboard processor itself,
right,
and process and take the decision.
Yes, yes, sir.
That could be the other way around.
Right.
Thank you.
So there are some limitations on that as well. We are also definitely
of
looking
course.
on that, but definitely I believe since the whole industry is working on further improvement on this aspect, I believe we should be able to, as a whole drone industry in India itself, we should be able to crack it as soon as possible. Right.
Yeah, thank you.
Thank you.
Do we have any other industry partner today? Okay. Yes, from IoTech.
So one of the thing that I would like to just mention here, when we work with the farmer friends, right? So one of the things that we have faced is we have very good processing techniques to find out what are the problem that is happening at the crop level, right? But we have to really think about how to take this to farmer level. So as a scientific community, as an engineer, as a manufacturer, drone industry, we have various algorithm, and we are able to find out what is the stress level, what is the moisture level, what is the thermal profile of the crop. But we have to take out from the lab to the field, so that is one of the challenges that actually we are facing. We have very eminent scientists in India, like IRI and ICR is a very great example. And but we have to also think how all the research work, the good work that we have done, how it goes up to the grassroots level farmer, maybe by using mobile app, maybe by using some cloud computing or, developing some platform where we share this data for the benefit of farmers. So, sir, that also can be taken one of the input so that we develop how to take this technology to the benefit of the farmer so that ultimate goal is achieved. That is the only
Thank you. You said rightly. Actually, from the discussion from industry partners, two things are becoming very clear. One is India has made a lot of progress in developing indigenous drone technologies at a very low cost with high endurance, with different weight categories and all. And I think that has reached to a level of certain maturity. But there is a big gap in developing our own indigenous sensors, which still we are importing. So that is one area which I flagged among the participants online, that if you start your research or modify your research in the area to develop our indigenous sensors, maybe few bands, few wavelengths only, but of high fidelity at a low cost and low weight. So that is one area, and our chief guest today was also referring to that only, that spectrometry, indigenous NIR spectrometers, still we have to develop. And I think we have a very good mass of engineers, students who have the capability to develop such kind of things. So from capability point of view, I don't see any constraint, but what the issue is that we are not yet prioritizing it. The other thing which is coming into the discussion and the lacuna is coming, that from whatever data we are generating from these sensors, how to convert into an actual application which is beneficial to the farmer, reduces his cost, reduces his risk, and increases his profits. So not only profit in terms of monetary profit, but also environmental profit, what we say ecosystem services, more sustainable practices. And I feel that is where institutions like us have to play a big role. Similar kind of thing we have been doing for so long from satellites, and we have a level of maturity of deriving what is the chlorophyll content, what is the leaf area index, and then converting into what could be the yield, what is the level of stress is going to come. Like currently we are also working from satellite on sun-induced fluorescence, which can give a very early detection of stress when it is not even available from any other sensors or even from eye. So I feel there is we need to develop a synergy. I don't know what mechanism has to be built up. It could be a PPP or a partnership of IRI with the companies, so that this data could be converted into application. And I want to tell our friends that we have a level of maturity and capability and understanding. What is happening across the world, same kind of capabilities we do have, especially related to agriculture, crops, soil, stresses, yield, biotic stresses, and a lot of models we have earlier over the past 50 years have developed. So those learnings, those skills could be converted into a product. And we are also looking, because as researchers, we sitting here are always not having a bent of mind to convert into a product, because there are so many other things are needed, and I think our industry partner. So one recommendation could be that we should be looking forward to a mechanism where the research institutions could partner with these private agencies and make possible a service. Dr. Shefali was telling, drone as a service. So make possible a service model to the farmers, where the responsibility of research institution is not only to provide the data, but they should have to own whatever analysis come out of that. So, and of course, if profits or losses has to be also borne by the two. Now I have spoken a lot. I would request if any of our participants have any
sir, if I may,
suggestion, any comments to make.
Sir, I just raised the hand. I'm from the industry. Can I speak, sir?
Yeah, please, please.
Yeah, thank you very much. And thanks to IARA and all the eminent scientists, ladies and gentlemen. My name is Kannan. I'm speaking from Chennai location from our Daksha unmanned system. We also have a type certified drone, and it's the first time in the country to have a petrol engine operated type certified drone, which is primarily used for spraying. So it takes away the hassle of frequent charging of the spray. We didn't go with a multi-purpose camera and other payload for this particular drone because we felt it is energy inefficient to use a spraying drone for capturing the images. We do have another set of drone, which is likely to get type certificate in a week's time. And that would have a multiple payload capacity with the all-up weight of around 6 kgs. Sometime back, Ms. Agarwal, she was talking about the using of SWAM drone for crop monitoring. I'm proud to say that Daksha unmanned system won the award from IAF competition, that is Meher Baba competition. We won the SWAM drone award prize way back in 2021. So we have a capability, and last time when I met Dr. Sahu, he thrown the idea, why don't we use those SWAM drones for agricultural purpose? Very soon we will come and explore that possibility because there is a technology on air. These drones can communicate with each other, and this can have a profound impact, especially on a large scale of crop monitoring, and then integrating the data for the spraying drone. So something as a mother spraying drone keeps spraying, and the SWAM drones keep feeding the real-time information. So this is something we have the capability, and we need to work along closely with the IARA. We will work very soon with Dr. Sahu sir and his team, and then see how this technology can be used for the agricultural purpose. So that's from my side, and thank you for the opportunity.
Yeah, thank you, sir, from Daksha Aggregator. Yeah, this is another dimension where a mother drone with a swarm of smaller drones could be used to make an application. But of course, once we think of a farmer level applications, we also have to consider the cost. So ultimately, it should not that the technology cost should be so high that finally the outputs of the technology are lower than the cost of the technology. So of course, currently we are in a phase where we have to demonstrate, we have to prove as a service, and once the things are proven, models are finalized, then we have to think of how to cut the cost. Thank you very much for your suggestions, and good to know that Daksha is also working in this direction and achieved laurels in doing crop monitoring kind of applications. But crop monitoring to finally coming to an action, that is where again I emphasize that we researchers have to come into the play. Thank you. Yes, Dr.
Thank you.
Yeah, if any, that is what I was saying. If among the participants, online, offline. Yes, please. I think, yeah, please.
Yeah, thank you. So it is a very good question. How we are going to double the farmer's income when the cost of the camera is in lakhs or somewhere around touching crore also. So as sir said, right, definitely as a scientific community, we do a lot of data analytics. We develop models, AI ML models, and then definitely our farmer friends cannot afford these very costly cameras and sensors and all those things, right? So what we have to do is we have to develop some AI ML based algorithms and try to develop some app so that even they don't spend too much money, purchasing these, very efficient cameras, but they should have some tool. Maybe, maybe South sir is more expert than me, so he can explain you, but I'll just try to throw some light on that. So if you have a mobile based, some imagery application where, you just take a picture and then, we send data to the cloud and run some AI/ML and then give him some advisory. What best, insecticide he has to spray. Then he may use a drone, technology to do uniform spray. So when I meant is, developing this whole ecosystem where he, all our scientist community, they have centralized database where they have done all the analytics. They have developed the model, put it there, and by using the mobile app, any farmer, he just go in his field, click the photo, send the data to the cloud, and then advisory is generated. So it's all, maybe within a half an hour or 1 hour of time, I don't know. And then after that, since these all data is geotagged, then he can easily go and program those coordinates in drone. And drone can go and precisely and spray there, right? So when we do spraying using drone, so there are a lot of benefits, so like, proper utilization of agri inputs, whether it is water, whether it is pesticide, then uniform is spray, because drone is a technology where you are going to use, Google Map, GPS technology in spraying, so when you do efficiently, then you need only 10 liters of water, and then there is no issue to the, health, because there is no exposure to the harmful chemical directly, right? So putting all these figures 4 and 5 benefits that farmer is going to get, if you put a monetary term, calculation, so it is almost, we are going to increase 32% is 32% of his profit per acre. So for example, a farmer is there who earns 20,000 rupees from 1 acre of, growing wheat. I'm just giving an example, right? So just he adopts to the drone technology, the data, the research that as a manufacturer we have done is he can increase his profitability by 32% just by reducing all his expenses. So this is how, if he adopts to the technology, AI/ML, robotics, he's going to increase his profitability. Otherwise, there is no magic wand by which we can increase the, double the farmer's income. He has to adapt to the technology, because you see urbanization is happening, population is increasing. So day by day, our area is shrinking. So he has to adapt to the technology to double the farmer income. That is what we normally think. I hope I answered your question.
Yeah.
As a service, they can afford, no need to purchase. So you see, like tractor, what happens? If you try to see 25 years back, there's not every house in the village was not having tractor. Only one rich farmer used to have a tractor, and he used to give services. So same way, drone technology is also going to move. So one guy, maybe to start in a village, he will have a drone and he will provide services to all his nearby farmers. Drone as a service.
And as a service, it could be given to farmer producers organization. Yes. They can afford it, and different crop specific, especially commercial crop specific associations are there. So those are economic models to be found. And one of the area which most of the drone researchers companies are forgetting, actually nobody talks of a synergetic use of satellite and drones. You can actually reduce your cost a lot, because in this year itself, you are going to get kind of satellites from private sector, which we have never thought of in my previous 30 years of service. Every 1 to 3 meter multispectral up to thermal, and every 1 hour. That is the kind of data which is going to come from satellite this year. So a synergetic use of satellite data, because that is quite cheap. Mostly it is free. What cost is your processing, and then using them to reduce the cost. Thank you.
Thank you.
Bioefficacy studies of crop protection chemicals has been taken in field when it is compared with the normal spraying.
I think Dr. Sahu can respond to it.
I just want to know from the company representatives who has come over here.
I think companies are demonstrating mostly on doing a cost benefit analysis. I don't know if some of them have done online
No, sir, some of them may have some collaborations with some universities or something like that, and they might have conducted experimental studies, sir. I just wanted to know that.
Dr. Sahu, please.
Dr. Vinay?
I think
Hello?
it's a very pertinent question. We'll going to talk that in the next session again. As you see, we have evaluated number of companies. IoTech also is the company who have been here in IRE campus doing all those experimental exercises. So what we see is, pesticide application, there are 3 parameters. One is the compatibility, one is the bioefficacy, one is the, efficiency. So these are the 3 things which one has to care for that. So, and coming back to the drone-based applications, and per acre, if you look at the economics, is going to be something around 300 to 400. And when you go for the manual spraying or something else, that's also cost is something around that. But most beneficial is efficacy. The way you spray with the droplet size and the 200 liter to 5 liter is a lot of water saving, one thing. And you take a whole day and you spray the same area in the 5 minutes. And then efficiency with respect to, if at all you talk of, with respect to variable rate applicator, again, you can go down to from 200 to 400 to 200, even if 100. So this is what the economics, which has been calculated roughly, but there are a number of challenges what we have. If you see outside right now, and yesterday also we have been trying to do some spraying experiment, we couldn't do because of windy. And country like India, always the weather is not that conducive for the poor guys, for us. So how to develop that mechanism to avoid that drift, avoid that wind speed in terms of knots, all those SOPs has been developed and soon is going to be published in the ministry website. Again, IRI and many the industry partners have done that exercise in collaboration with the universities. And SOPs has just last week only it was presented before secretary during lunchtime, and it is almost approved. That is what initial stage exercise what we have been done. But still we need to go a long way because many experiments has not been done so scientifically proper way. But we got a lot of inputs from the industries like IoTech, like General Aeronautics. They have been working with many companies like Bayes and also did in number of crops, and also Angara University, many universities they have been working. So we compiled all those experiences together into the document, and we have put into the website and also asked for the input from all the industries. So that's what the status right now. But there are many questions which is yet to be answered. So we have to go a long way.
Yeah, I think still your question is unanswered. He has told what are the issues, but you specifically asked any studies which have shown the efficacy.
No, sir, the same thing we discussed with sir. I'm from IRA only, sir.
But it means if you are from IRA, you please take up such a study and show. Really, many times we think without going into the field and without venturing into the system that this is the way things will work. Like we do crop biomass burning issue. We thought that giving equipments of nearly on subsidy to the farmer, this problem would be solved. But this has not been solved because we are sitting in labs, we are sitting in offices and thinking that the system would work. That is not. Actually in field, when we see, then we realize what are the issues which Dr. Sahu has pointed out. Thank you, Dr. Sahu. Anybody else?
There is Mr. Kishore Swain who is going to ask some questions. Yes, raise a hand.
Yes,
okay.
please.
Thank you for this opportunity. Actually, I'm attending from Vishwabharati Santiniketan. Okay, I don't have question because I'm working on this field. So I just want to add some my experience or my suggestions. Like when we talk about drone, when we talk about the direction of benefits, whether we get benefits or not, we have to think in a long way that, okay, when it will give benefits. If you start from the beginning, we talk about cost even, then it may be difficult to adopt this technology. And one thing we can think of is like instead of blanket spraying, that where we put all over the same level of pesticides, if you look for variable rate pesticide somehow with same sprayer, and image system together, then that could be somewhat come as benefit to the farmers, like saying the pesticide cost. And another point maybe I want to bring your attention, as it is a group, that if we can spray fertilizer, if liquid fertilizer, that could be added work for the drone. So, and that is one of the suggestion. And one more is like, if IRA take initiative for a group, precision agriculture group, or remote sensing people applying in agriculture, then we can get updates anytime. We can some updates of works, what's going on and other things. So we'll stay update around the India. That could be my suggestion. Thank you so much.
Yeah, thank you, Mr. Kishore Swain, for your intervention and suggestions. Of course, as you say, on the first day, you are not going to recover the cost of drone and sensors. Ultimately, as a service provider, once he take a gestation period, and then only he'll able to break even and then make up the profit. But I think there is no denying in the fact that this is going to be the technology, this is going to be how we are going to do agriculture in next coming 10 to 20 years. Thank you for all your suggestions. Anybody else? If there is no one from online and offline, I would request my co-chair if he has some comments.
I have one question, if permitted. I'm Dr. Ravinder from
Yes,
Quantum
please.
Technology Center. I have a question for the industry partners who are seated here and also who are existing online. I just want to know, are there any existing collaborations of the industry with the agri sector in various drone applications in agriculture? Anybody whosoever feels can answer.
Oh, can I answer that, sir? From Daksha Unmanned System.
Yes, sir. Please.
Yes, ma'am. We do have tie-ups with various government as well as the private companies. Some of the input companies have reached us to get some of our customers for spraying their chemicals. So we do have a tie-up. We
So
also
how do these collaborations work? Like, what are the components which you render as a part of collaboration free of charge in return of what are your expectations from your collaborators?
Yeah, I would just briefly tell ma'am in the of time. For example, there is a company which aggregates the demand for spraying for their farmers who use their chemicals. So they would be using industry partner, whether it is Daksha or any other drone manufacturer. They want to tie up with them and then get their drones for providing services. It is possible that the drone manufacturer directly engage in the spraying services, or the drone manufacturer can give their drones to a service provider who himself or herself would be an entrepreneur. They engage with the company and then ensure the aggregated demand is taken care. The spraying is done in those farmers what the companies give. That's a model which already exists.
So that's a service-based collaboration where you must be charging your client, isn't it? If I have understood correctly.
Yes, that's right.
My question was more in the R&D section. For example, if today IARU wants to collaborate with you to find viable, feasible, on-ground, real-time solutions for the farmers in various agri, categories, it can be soil health card mapping or irrigation mapping or application, pesticide application, and so on and so forth. Then is there any modus operandi existing with your company to enter into such a collaboration?
Yes, ma'am, we are open from our side. I would leave the other industry partner also to respond. We already discussed with a couple of universities where we want to get into an MOU exclusively for research purposes. And that would eventually help the farmers and commercialization at a later phase. We are open to that, but right now we haven't signed with anybody. Okay. I would just leave it to the other industry partners to respond. Thank you.
Thank you, sir. Thank you for your time.
Thanks, Karan. Yes, madam. So this is again from IoTech. So your question is very right. looking at the scenario. So definitely industry has to work very closely with all the scientists, right? So we have been working very closely with IRI, Parbani, Rahuri, PAU, the whole scientific community, because we are like engineers. So we develop drone, right? So we are like an industry, but we have to work very closely with all the scientists because they are the expert in their area, right? And then we jointly work together to develop the SOP, as Sahu sir rightly mentioned. There a lot of feedback has come from industry. There a lot of feedback that has come from the scientific society to develop the SOP. And definitely, since this is a very emerging technology, so there are a lot of work still have to be done. So that is one thing. Second thing is regarding, if you look at the farmer demography in India, right? So we have almost
I understand your expression. What I was more interested in is some good case studies which you can quote here. Like, yes, your company has collaborated with X institution for developing such and such application. Have you reached that milestone so far, or you are still in the process?
Yes. So, madam, this on drone technology, we have been working for last 5 years. So basically on the paddy, right? Paddy and sugarcane. We have done many trials and we have developed the SOP, right? We have tried with some chemicals. I cannot take the name of the chemical because like PAU is one of the partner, okay, for paddy. With IRI, we have done on horticulture and on sugarcane, okay. With Rahuri, we are doing on soya bean. Okay, so there are many experiments that is going on, even on the quinoa. Some challenges we have faced on grapes, to be very frank. So
crop health monitoring you're doing?
Sorry?
You're doing basically crop health monitoring using drones?
Spraying. Yeah, crop health monitoring we have done one with PAU for carbon, finding out the carbon emission from the paddy field. When there is a water logging, water not logging. So we have done some crop health monitoring using multispectral camera as well.
Thank you. Thank you.
Dr. Kaur, actually the issue is that the problem is from our side. Problem is not from industry. Our ecosystem in research institution does not allow us to incorporate a company, to collaborate and jointly set up a new startup.
Correct.
Unless we partner where our student also participate and take this in a long way, this is not going to happen. Giving as a contract research or a consultancy is not a sustainable way in a long term. Thank you. Thank you for your intervention.
Thank you very much.
Yeah, do we have anybody else?
Sir, if I may just...
Dr. Rajkumar to has last word and then we can close the session.
Thank you, sir. From the whole discussion, I want to summarize some few points that emerged from the discussion. So first good point, it is come that we have some level of maturity in developing the drones, but there is big gap in developing the indigenous sensors for drone applications. So there is a need to collaborate academia and industry for future development, so that it should be a cost-effective solutions can be provided to the farmer. So we have to develop a whole ecosystem, either in real-time processing of data on the drone itself, and then taking applications for particular purpose, and or either then transferring the data from drone to cloud and applying the AI ML algorithm, and then provide the solutions to farm in terms of advisory. So this is one kind of recommendations should emerge from this discussion. And another is we have to concentrate on bioefficacy study of spraying the chemicals through drones, and many concerns has been. The good news is that in preliminary SOP has been developed, and the further refinement is required with the inputs of from everybody which is working in this area. And third thing is that a very good ecosystem has to be developed from the policymakers, that a scientist can or a student can incubate a company and collaborate with the startups so that a innovative solutions can come from both the sides. Thank you very much.
So with that, we come to the end of this session. We are already running late and we have taken up more time, but it was an interesting session. I thank everyone, my industry partners, our participants online, offline, and the experts who have participated in this session. Thank you.
Thank you, sir. Such a wonderful interactive session. You could moderate so nicely and came out with some kind of conclusions and also recommendations. And thanks to the industry partner who have been very much interactive and looking forward to go a long way with the different institutes and also these young researchers. There are a number of questions again we have also with us. Maybe next 2 sessions is going to answer some of them, or we'll deliberate on that. And I would request all the industry partners to stay back because we have again important 2 sessions we have starting from the precision agriculture, phenomics, and also policy imperative. So with this, before I conclude this session, I take this opportunity to felicitate our chair, Professor Vinay Sehgal, with a token of appreciation on behalf of NHP CAST. I will say. So, also, I take this opportunity to my left hand. So we break for tea, and we have next session starting at 12:30. Again, we have Deputy Director General NRM, Dr. Chaudhary, is going to join with us. So we have a tea break, and also we have drones from the different industry partners, from IoTech, from Daksha Unmanned Aerial System, UAV systems, and also General Aeronautics, just on the foyer of NRL building. You can interact with them, ask all those questions, and that's the purpose why this session is here. So we resume here again by 12:25. Thank you very much. I request all online may resume again at 12:25. Thank you.
done the ARIA
print. As the chair of this panel session 2, and I would request Dr. Bina Sehgal, head of the Division of Physics, to welcome sir with a bouquet of flowers. Sir, this is the last day of the training cum workshop on airborne hyperspectral remote sensing. And today's date is on a workshop on drone technology for agriculture. And we have many industry partners and also young researchers, almost 73 in person, they're attending the meeting here. And almost 164 online, they have participated on this program. And today, last session is on, since it is on airborne hyperspectral remote sensing, so we want to take care of the airborne, the industry partners who are onto and drone technology. They are here on the NRL foyer. There are some of those drones, and also the companies, they have showcasing the drone technology with the different sensors and different applications. And we have amongst us those industry partners also here with us, so that we have a close interaction with these young researchers and students, and they understand that. So with this, sir, I would request you to kindly start the session, please, as a chair. And co-chair Dr. Vishwanathan will be joining us in the meanwhile. Thank you.
Thank you very much, Ravi. Thank you all your colleagues. Thank you very much for when we talk of a beat or any new innovation. So without industry, if we talk of all these things, therefore, the moment of industry is important. This session, how many presenters will be there?
So only one session I'll do, then we'll discussion.
Okay. So first, I would request for the presentation.
Jarut nahi hai. Thank you.
Okay, please. Intro इसको set कर. उसको सब लोग जानते हो ना? कोई ऐसा है जो नहीं जानता इसको? ठीक है. नहीं जानते तो बता दो इसका रवि नारायण साहू नाम है. ठीक है? बस okay. Please.
Thank you, sir. Thank you. So, sir, I'll just would like to set the platform of this technical session, UAV technology from phenomics to precision agriculture. So we'll have a quick overview. What is that technology, where we stand, and what are the challenges we have? So coming back to the enhancing the production in the country itself, there are two approaches. One is you should have a smart crop, which can be done with respect to different technologies. One of the technologies is phenomics. There are many, like genomics, genome editing, fast breeding. One is the phenomics, where we try to see how the technology related particularly to the sensors can be used for the plant phenomics to make it a smart crop to resilient different climatic conditions and the stress conditions and enhance the input user efficiency. That is the one part. Second part is when you go to the field, again, enhancing the input user efficiency, you have to capture the variability in terms of soil, crop, and weather. And accordingly, we can go for the management. That is the site-specific input management of precision agriculture. So they are all related to each other. When you do something on the plant phenomics, we are developing the varieties or defining the traits with respect to different ecosystem. And again, which is a part of a precision agriculture. So to do that, how drone technology is going to be helpful? That's what the session is going to be, and what are the challenges we have. So we thought maybe drone remote sensing is a CAT scan of crop health monitoring and also precision agriculture. If we divide drone technology in terms of applications, broadly, one is the drone for the crop health monitoring or surveillance. Second part is as an input applicator, like any platform you have for the applications. So drone as a variable rate technology for input applications in terms of pesticides, herbicides, liquid fertilizer, seeding like bomber and broadcasters, and many more applications, of course, you have in many sectors, but we are talking defined to the agriculture. So both are connected to each other. The drone as an applicator will be available or will be success provided we have a diagnosis done, provided we have a variable map captured or the health monitoring is done, where what the stress, what kind of severity level, then only we can go for the applicator. So they are all well connected to each other. I think previous session, we talked about the platform, sensors, and data analytics, where we stand in country with respect to drone technology. So this session is going to talk on how to capture those variabilities and how to manage those variabilities. Coming back to the sensor, these are the series of sensors. I think I don't need to repeat this. Starting from RGB to microwave radiometer also started available on the airborne platform to capture all possible traits to see with respect to plant phenomics and also precision agriculture. And when you talk of drone technology, it is the bridge between the ground and also the satellite. It can't replace either the ground or the satellite. You know the limitations, you know the challenges what we have. And drone technologies, the drone is such a tool, a technology which is very much user-friendly and subjective to the user as you like to. So that's what the beneficial of what you can have. But a large scale to do, like a state level or country level, it's next to difficult. We have to go to the satellite level. So it is the technology which can be used in a limited scale opportunities to identify the anomalies, what you are not able to see from the satellite. So I think, so these are what the strength we have over the time we have built up from 2016 till now. So different birds with the different sensors and different platforms or different pipelines and methodology we have developed over the years with the support from the ICER, from the NIHP, from the Department of Science and Technology through different support. So let me come back to the platforms. So this is what the drone technology lies in between. You can see the ground, you have a single pixel. When you look at the satellite, you have a larger area. So drone bridges between them. So you have a challenges when you look at the ground, you a single pixel. When you look at the whole ecosystem, is a larger satellite level. It has, so you can look in a ecosystem level. But when you want to do something relations developing, so you need to take some kind of a ground truth or develop a modeling which can be moderate from the satellite and also to ground. So the UAV, unmanned aerial vehicle or manned aerial vehicle, bridges that gap and try to allow you to develop that kind of predictive model which you can finally make it operational. So that's what the UAV technology platform. Coming back to the sensor. So if you look at the sensors, this training program was on the hyperspectral remote sensing. So if you see the spectra starting from 400 to 2500, the basic life process photosynthesis, each part of that is captured by the sensor. You look at the carbon dioxide, look at the water, look at the carbohydrate, and also the oxygen. So that means the sensor is able to understand each part of the life process. One example I have given, photosynthesis, same also for many purposes. Like so today you are talking about the carbon sequestration, talk of the emissions. So there are sensors which can be used for that purpose, provided sensor looks around the whole spectrum to capture those sensitive bands for particular the chemical compositions or atmospheric compositions or the gas emitted from the field. So this is what the success story we had with respect to manned aerial vehicle in collaboration with NASA, ISRO, and IARA and many ICER research institutes were involved to develop some kind of prototype how, if at all we use imaging spectrometer, what are the success stories we have, what are the challenges, then we can look forward to have the satellite where different hyperspectral sensors are going to come up. So in our work in the training program itself, we had Dr. Bimal Bhattacharya who told all about the airborne campaign and also satellite future, what we are going to work with. So this is what the kind of signal what you receive from the ground platforms to the airborne platforms. And if you see with respect to the soil health, this is what the intersensor evaluations we try to do. So these are the ground sensors in the lab conditions we could do, starting from VNR spectrum to MR spectroscopy. And when you look at the airborne level, you can see the average NG, the predictive model. So what I mean to say is you could see there is a very optimistic results. What you could get is, if at all we have this kind of sensor, for example, MR spectroscopy, VNR spectroscopy, there is a possibility we can complement to the soil health card, what we are doing in the wet chemistry, at least lab conditions, we can give the soil parameter, what we are looking for 12 soil parameter. Same thing also we try to do in the satellite level. These are the platform evaluations starting from the ground to the air, to the outside, and also to the satellite. So this is what, again, the new concept of digital soil mapping. We try to do using, again, a hyperspectral remote sensing. If we can get a digital soil map, which can be dynamically updated over the time, over the space as you like, which can really save a lot of time and effort what we do. This is what the new concept which is coming up, and we are taking in a big way. Again, how airborne remote sensing can help us to derive all this information with respect to the resolutions, with respect to accuracy, with the predictive model, what we can have. For example, something around 19 soil parameters of IRE farm, we could see digital soil mapping. Only 282 soils were taken, a predictive model was done, and spatial variability map we could see with respect to soil health. So whole IRE, if I take a village of around 323 hectares where the crops are grown, you can see the kind of variability what we could capture. then you can go for accordingly the management options. So this is an example. Once you capture that variability, then you know what is the target yield of the crops you want to grow in a canal district. Then you can customize for the fertilizer what is required. That's what the precision agriculture. So how you can bring down from canal to a future farm or to a farm of a 5 acre or 5 hectare using the drone technology. That's what the science we should look for. This is a regional scale what has been done again through the satellite using something around 10,000 soil samples and mapping with a homogeneous unit, capturing that variability and site-specific, cross-specific recommendations which has been done for. So with respect to soil health, precision agriculture, these are some of those challenges what we need to have, how we can generate those libraries, how we can, irrespective of the sensor, how we can develop the SOPs or generic methodology so that we can come out with the reliable predictive models for the soil fertility. And also low-cost sensor, that's what the challenge is. And since morning, we have been discussing most of the sensors which are on the technology, the drone, they're all borrowed from outside. But how we can have low-cost indigenous technology. So from hyperspectral, we can come down to the low-cost sensor. We dealt with how we go for the data mining using a whole range to low-cost sensor. And again, to be part of the global soil information system, if at all we can develop a spectral library for whole pan-India. Coming back to the phenomics, so this is what the facility what we have with us, having decorated with all kind of sensors starting from RGB to hyperspectral, and same time also where the sensor plant is fixed, sensors are fixed, plant is moving, and we are able to capture all those data, try to seize different traits, for example, nitrogen, water use efficiency, many parameters using different sensors. Same time also we try to see how mobile platform can be used. For example, we have given a automatic moving mobile platform, and also we have a frame where the camera can move across. Again, the drone technology is a boon to us right now, how we can fly with a similar kind of sensor, something around height of 20 to 30 meters, and capture all those data, what otherwise is impossible. So coming back to, for example, this is what the data has been captured in the field, and go for the mosaicing, and this is what the IRI farm wrapped over with the Google Earth engine. And you can see the kind of the field what you have with the differential treatment of nitrogen and water. D stands for drought, I stands for irrigated, N0, N120, you understand. And in each field, you can see the kind of genotypes what we have grown with. So you could see the variability visibly. You are able to capture not only from the plot to plot variability, within the plot also how that genotype is behaving. That's what the capture. So this is what non-invasive rapid throughput you are able to generate for the plant phenomics research, provided we have a sensor of which is something around, this is a multispectral sensor flown something around 19 to 23 meter height in the field. So this is what same thing we could do dynamically also. You know, sir, when you do the plant phenotyping conventionally, if you want to replace it, the wonderful thing is the same plant stays from sowing to harvest, and you are capturing the dynamics what you have in the time scale and using the either in the phenomics facility itself or in the field using the drone with the different sensors. So this is what the mapping you can do within no time. That's what the methodology we developed. So once field data has been captured, you can rank them with respect to genotype, which is good for water use efficiency or which is good for the nitrogen use efficiency. So these are some of those examples. I just skipping through because of the time constraint, just to put the platform. What I mean to say is there are some initiations which has been done with respect to drone technology, possibility for soil and crop health monitoring, and also the plant phenotyping. But there are many gray areas what we are supposed to address. For example, look at the biomass predictions of the rice field using again the drone technology, simply RGB camera. Again, the crop water stress index based, you can go for the irrigation scheduling in a limited field of around 5 hectare. And again, genotypic response with respect to temperature variability from one end of the field to other end. So that's kind of a water stress variability you are able to capture, not necessarily because there is no irrigation given, but there is a treatment given, and also the genotypic response you are able to capture with respect to the water use efficiency and the response. And that's what the variability with the color tells you the temperature variations. So again, coming back to the latest technology, for example, AI technology or deep learning programs. So if I have a plant to capture the image, you are able to count the number of panicles it has. Same thing also can be done in the drone technology. When you fly through, you can within no time count all those panicles using some of those technologies. For example, number of tassels in a maize crop field, you can count using CNN models of yellow approach. So these are some of those success stories which you could do. And coming back to some of those biochemical parameters, so we could see the variability with respect to nitrogen. This is what the precision farming experiment. And we did also intersensor evaluation starting from RGB to multispectral to hyperspectral. You can see starting from 3 bands to 5 bands to around 270 channels, and the kind of predictive model we try to develop. You can see the kind of data, what hyperspectral data we receive. The challenge remains here is that the data are in GBs. Again, flying the hyperspectral camera itself is a challenge. All of you know how it was difficult with respect to maintaining the attitude, roll, pitch, orthomosaicing, and also the huge data what you get. Again, huge information is always sometimes also noise. Redundancy is there. So how to use them, come out with different techniques with respect to the variability with respect to nitrogen or Li. You can see some of those success stories here. For example, in the field, you are able to do predictive model based on indices or the whole range of the spectra, and predictive model for the nitrogen and predictive model for Li. So these are all the regressive model or the machine learning programs what we run through. And this is what the spectral response we were able to see. And you can see the raw image to a thematic map of nitrogen variability you are seeing in the field. Next should be the management map. And that management maps based on the decision support or crop simulation model, what we have expertise in the IRI, then management map can be enforced to the drone applicator, drone BRT technology. Then you can go to the field-to-field variations and go for the spraying. Not only the off and on, also the variable spraying it can do. That's what the BRT technology we try to use. If at all, we can use liquid urea, nano urea. So again, coming back to different other nutrients also, we have some success stories with respect to nitrogen, phosphorus, and also sulfur. From hyperspectral, how we can come out with a low-cost sensor, there are specific bands. This is what the basic research has been done, again, in physics in collaboration with many other divisions to detect the phosphorus and sulfur and also potash. So these are some sensitive bands which you can do it. So hyperspectral, it can be used to come down with a narrow band, which can be a low-cost sensor, can be developed later with. So these are all regressive model. Then coming back to the processes model, which can be used almost a real time. And again, you don't need to change any equations or model, and that model is going to be generic irrespective of the time and space. This is what the ready-to transfer model we try to do it. And again, we try to capture the data in different directions. These are some of those studies. You can see wonderfully, if the sensor is in different directions, same target, you have the response is altogether different. Same soil, same crop. So with respect to sun, altogether, that's going to be different. Same thing also we can do with the drone, because drone you can fly around the crop, see in different zenith and azimuth, and generate that kind of data, and go for ready to transfer modeling using this kind of concept. So if you know the biochemical parameters, understanding the chemometry, or like today morning the Kuja was talking of, you can simulate the spectra based on the set of biophysical, biochemical parameters what you have, having basic understanding of the physics and electromagnetic interaction with the plant. So this is what the model output finally you can get with respect to the response, with respect to different parameters you are able to see on the down. And this is what the predictive model using that ready to transfer model. The purpose of using that is, if at all that can make more of a usable, reliable, then once you generate a data from the remote sense, from the drone, you can generate a product directly, provided you have a mostly real-time processing for that purpose. So this is again another story where you have 10,000 land races grown in IRI farm. Honorable Directors has a very ambitious experiment of a DBT, where you can think of going to the field and having 10,000 plants, monitoring them with respect to time and capturing their heat map. So you have a drone image, and you can, within no time, you can capture that and simulate in 3D, can see across how much is the height. If at all this is what RGB, we try to generate a stereo image and also 3D image. I'm not playing that because of the heavy space, but you can see, you can simulate through and can go across, fly across to see which plant is behaving how much. And this is the kind of ranking you can do with respect to response. Coming back to the phenomics, again, using the hyperspectral. So you don't need to go for all those biochemical parameter measurement in the ground and go for the matching. That's what happening in the conventional way. My thumb rule is, if my spectral response is the altogether aggregate effect of all those traits, what I'm looking as a plant breeder or plant scientist, my spectral matching itself with the parent, with the genotypes, or with the parents, like two parents are here, down there. If at all I have inbreds like real 270 childs, I can compare the spectral response, like signature to signature comparison I can do. And if there is a genotype which matches the real, which is matching with the two parents, that is the best with respect to all the traits. And that's what the first, without doing weight chemistry, this is what you can do for the phenotyping and going for the selecting that genotype, which is really good with respect to the traits, what we look for those two parents. One may be high nitrogen efficiency with low yield. So we can capture that high nitrogen efficiency, one variety. Then other variety is high yielding, but very low nitrogen efficiency. So we can develop a genotype, which is be high yielding with no nitrogen efficiency. Again, that can be used for the precision agriculture. So this is what from phenomics to precision agriculture and where the sensor is going to work for. So this is what that example of similarity approach. Then coming back to some of those pests and disease, this is what the summarizations, some of those success stories, what we have in the ground we did, but in the hyperspectral, in the airborne, we have not done yet. This is what the rice blast we could do. And this is what the yellow rust, what we could do in the ground. Again, from the mango malformations, you could do from the spectra. And again, from the airborne campaign, what we had, some of the area you could see the yellow rust mapping. So, and this is again grapevine areas where you could see different diseases, for example, powder mildew and down mildew and different deficit with respect to ferrous and boron. So these are some of those success stories what we have with us. And what we want is, if at all you have a drone for mapping, you have a drone for input applications, this should be connected to each other. Like you have the tractor, like for example, you look at the Yara sensor of John Deere, where you have a Yara sensor on the front, back you have a VRT applicator and the tractor itself. So it moves, it gives you the NDVI based, the mapping of the nitrogen requirement, and behind you have a variable rate applicator of liquid nitrogen or whatever. Same also for pesticides. So it's a kind of a vision technology, which can be used also for the drone. Same time you could map here. So this is what the applicator you have, and down you have a hyperspectral sensor moving through, looking at different fields with respect to what is the requirement with respect to pest or disease or the nutrient stress or the waterlogging. Because always you have a composite stress, and hyperspectral sensor can discern those composite stresses and also stress levels. So this is what the kind of connections what we need to look forward. Again, looking at the beyond the crop field, for example, look at the water, something around 100 fields we could capture somewhere in the CIFA Bhubaneswar, try to see how the brewgreen algae or the turbidity or the water quality, water ecosystem itself with the fish production, again from the drone we could see. This is again a drone technology which has been developed by CIFRI in collaboration with the UAV systems. We try to develop a proto drone with a water sampler. You can go to a remote area, capture the data. And also we are in the process of developing a drone which can go underwater, look at the plant phenotype, the fish phenotyping, different fish cluster, fish classifications, and also dissolved oxygen and different parameters. So this is what I wanted to summarize together. So if at all you are able to capture the data, you can look at the data analytics, what is required for that, starting from the greenhouse to field data to the open field and precision farming. And key deliverables are advanced data analytics, visualizations, and of course, the decision and hypothesis, which you can make it applicator data. So this is what the applications. So you start with the phenomics at the cellular level, end up with the precision farming in the ecosystem level. This is what the technology requirement and drone technology work for that purpose. If you look at some of those challenges, what we have, I have listed some of those, the low-cost sensing technology, low-cost platform, integration, and also data analytics. And that can be more of a real time. Again, keeping the kind of encouragement what the government has given with respect to drone technology. Look at 2016 and 2023. It is really exponential growth with respect to the startups in the drone technology and also the science what we are trying to do. And unless until we work together, I don't think we will be able to address some of those questions. Then another challenge, what Professor Sehgal was telling today morning, there is a company called Pixel. There is another company who is very soon is going to launch high resolution hyperspectral camera on the drone on the satellite platform they are launching. So if at all we have many Planet Labs and many companies are there, we have a high resolution satellite data. How far we are going to use that? How far we have used that? Why at all we look for the drone technology? If at all, so as I told at the beginning, drone is going to meet the bridge between the down to the satellite. We can't replace each other. So unless until we develop a prototype, a method of predictability, we can't go up to the satellite level. And you know, satellite has its own limitation with respect to sensor, with the repeativity and the requirement with respect to the data acquisitions at a particular time. But whereas drone is very flexible with that purpose. So keeping all those things, we need to look at and need to work together to answer and leverage the technology for benefit of the farming. So thank you very much giving this opportunity and giving the setting the platform for the further discussion, sir. Thank you.
Thank you, Ravi. Thank you very much. Starting from economics to precision agriculture and all. Now, we have to get into discussion part. So, who are the partners present today on the industry?
Can you introduce it?
Yeah, please.
You can give the mic.
Please keep your points focused.
So my name is Anup Paul. I am from Biotech World Education Private Limited. So my first company is so we have been working very closely with Southside to implement this some of the camera imaging, thermal imaging, and develop the model and try to educate the farmers. So how can they use drone technology? And as Sir said, right, so our drone is also like multi-purpose drone. So we do crop health monitoring, and also based upon the geodata, we also try to spray and try to showcase means how can they cannot just blindly go and spray, but how can they use the analytics and then go and spray on only the impacted or infested spots in a particular field, and they can reduce the cost. So they're working very closely with IRI to proliferate this technology into the farmer hands.
Specific application or any point would you like to bring to the notice of participants?
So one of the thing that we have noticed while working at the ground level, even I told in the first session also, this technology is very good, sir. Okay, but we have to find out some means to proliferate up to the farmer level. So we have to take this technology from lab to the field. Then only the proper utilization or benefit will go to the farmer friends. So that is where I think we have to develop some cloud-based computing or some app-based application. So that is where, and one more thing, sir, these sensors are currently imported, right? They're very costly. So we have to work with experts like Sao sir and his team and other scientists to develop some indigenous solutions. Maybe as sir rightly said, not complete bad, maybe few bad, which is very particular for our Indian crop, maybe for wheat or maybe for paddy, low cost sensors, so that people start using at the mass level.
Okay, thank you. Any additional point you have made? Then?
Hello, sir. This is Fahimul Islam. I am from Dronix Technologies. We are based in Chennai. So we also make drones, but we have been working on the defense sector extensively. But we are open to customizations of our drones, because we believe since it's the dawn of this technology in India, there are various feedbacks that we are getting from the end customers or the requirements from the market. So what we believe is, since this has a scope of lot of smart technology that can be integrated with the drone, so we are trying to get feedback and then accordingly work on that direction. So like you said, sir, there will be some lot of data that would be generated. So how we can use that data to real-time process it and give a feedback to the the person who is looking into that. And again, from the farmer's perspective, definitely we cannot give them the data that we are collecting right now. They would exactly need to know how what are the things needed, like what are the pesticides or fertilizers required for their field. So how do we bridge that knowledge of the science that we are working on, and to give them the exact point of what are the things they need to do so that they can get the maximum yield from their land. So that is
anybody else? Yeah, thank you.
Thank you, sir. My name is Purushottam from Electrotech International, Chennai.
we have been associated with many foreign companies manufacturing high-level spectral tests, both imaging as well as non-imaging, who work on hyperspectral remote sensing. So first, they need to do some sort of a ground truthing. So with a non-imaging spectrodiometer, so that they know how the spectrum looks like, what is their target, and what is their interest on this. Then they can go for hyperspectral images, which can capture the image over a scene, so that they can take the data very quickly on any moving platform, either in the lab or in the or in a drone, and so that it can open up a lot of new applications, because it is far better than your multispectral data, where you will get a lot of information about your material of your interest. Thank you.
Thank you, Purushottam. Thank you very much. Anybody who had joined online, any our private partner, if anybody is interested to make a point here, you are welcome.
Yeah, sir. Hello, good afternoon to all. This is Kannan from Daksha Unmanned System from Chennai. The other industrial partners have already shared how we all can be collaborating with esteemed institutions like IRA and with Dr. Sahu. I would just dwell upon how this can be scaled to the farmer level, because end of the day, all this technology has to reach the intended beneficiary, that is a farmer. So I see that these are all, like currently a farmer has some problem in his crop, he goes to the fertilizer shop or pesticide shop, from where he buys the inputs. In a similar way, I think the multiple stakeholders have to come together, then only it will reach the farmer. Definitely farmer is not going to buy this technology, but he will definitely consult. Just like X-ray is being taken for a health or some ortho issues, in a similar way, he will go to a particular shop. So I think we all have to work with an ecosystem where the service provider would be built with this necessary technology. And I think that's where we will be able to really take the technology to the farmer. Otherwise, it would remain with the manufacturer and with the universities. It would never reach the farmer. So that's my suggestion.
Thank you, Mr. Kannan.
Yeah, thank you.
Thanks a lot. Thanks. One more partner we can accommodate here for making his point. Anybody in virtual mode? If not, then we'll further proceed. I think before winding this up, since Vishwanathan is not there, Raju, you have to make any point? Yeah, please.
Thank you. With this session, there are 3-4 main challenges. The first challenge is the development of low-cost sensor, what we came through, and the other is the how this technology, as we know that this technology very useful and very new, but how this technology will reach to the farmer, we have to think about this. And this technology with integration of AI technology, it will helpful for the crop growth monitoring, and our main aim is to estimation of the yield prediction. And the other things from the Dr. Sahu presentation, we came to know that the index-based prediction model for different nutrient, like especially the nitrogen and other nutrient, generation of the variable level of nitrogen map, and accordingly variable rate of application of the nutrient will save the our fertilizer, and it will be, if the input will be less, then the input output ratio will be high, and ultimately the farmer will be more benefited. So these are the two, three points I have to go through. Thank you, sir.
Thank you, Raju. I'm able to see Madam Ravinder Kaur. Do you have any point to make? Yeah, please.
I have a comment, and I have already asked this question in the previous session also, but perhaps I was not very clear in my questioning in the last session. I personally feel that this technology has got enormous potential, as everybody is saying, but we are as an institution and also as industry, we are far away from its applications. We're talking about drones, we're talking about AI, we're talking about ML, but we do not have that kind of a data which is required for generating AI and ML based algorithms. So I think it is high time that we collaborate with these industry sector people. They are skilled at making drones of different types to suit different environmental conditions, and we are good at doing a good science. So I think they will get a platform to get data generated from us, and we will get the technology backup support from them. Without this collaboration, I personally feel that we'll not be able to go very long distance. And I think ICR should come out with some standard operating procedures to allow the institutions for such joint ventures. And these joint ventures, I feel they will not only help us in good science for the social benefit, but would also help in generating internal resources and also inspiring our UG PG students to have experiential learning with the very productive academia industry collaborations. So this is what, sir, it's not a question, it's just a humble suggestion.
Thank you.
Because you are there, so I think the message can be conveyed faster. Thank you for the opportunity.
Thank you so much to listen to your views. Thank you very much. Still, we have a couple of minutes. So we can invite comments from our students if they have any point. Our students, any young colleagues, if you have any point to make at this point of time. Anybody? Yeah, please. Be brief.
Good afternoon, sir. So like we are over the period of time during the training. I'm Sharatjit. I'm from Kerala. I'm working as scientist in the Center for Water Resources Development and Management based in Calicut. So what I understood is like drone application for spraying, that is really, it works. But if you look at the variable rate application, where we want to capture the variability in the field, where we stand, like because all fields are different, the crop is different, the agroecological units are different. So how do we go with that? That's my question.
Thank you. Thank you very much. Anybody else? इनको एक चांस दे दो. फिर आपको बोलना चाहते हो?
My name is Dr. Dilip Kumar Kushwaha. I am scientist in Division of Agriculture Engineering, IRI. My suggestion is actually here to develop the nozzles, especially nozzles for variable rate application, because that is not happening. And the nozzles which are available, they are very costly. So I think the industry, in drone industry as well as the spraying industry should come together with the academia so that this type of technology can come up. And another thing is the placing of the nozzles with the drone is also important for variable applications, because the same type of nozzle placing cannot work in field crop or in horticulture crop. So there is variation in placing and application. So that should be taken care.
Thank you very much. Okay. Yeah, please.
Sir, I'm Subhi. I'm from Indian Institute of Maize Research, and I wanted to add one point. IAMR maize, sir. Yeah. Sir, actually regarding the variable rate of application, I'm working on fall armyworm, and we have some of our IAMR hybrids are in the field in the seed production. So the fall armyworm, how it attacks, it almost 100% of the field will be damaged, and the insect will hide in the wall. And when the plant go up to the flowering, again that sprayer application using the handheld sprayer will be a difficult thing, sir. But according to feedback from one of the seed growers, from the Telangana cooperative, so dairy cooperative society, they have a demo spraying in the pre-flowering stage maize with the handheld sprayer, also the drone. So what they found is that the handheld sprayer is much effective than drone because of the hiding habit of the pest. So this variable application has a big role because to go into the plant world, there has to be a high volume. We recommend high volume sprayer. It has to go into force into the world. It has to be directed straight. But it is for a crop like maize. But in the case of raw crop, I was discussing with some of my friends, it can work very well in the case of fungicide application. Also in the case of crop like rice, which is having a closed canopy. So the action of the drone, which will open up the canopy and it will can have a uniform spraying. So we have to standardize the technology based on our crop. Thank you.
Okay, good feedback. Now, you want to make point? Okay. This is last for this.
Good afternoon, sir.
Closing.
So my question is to Sahu, sir. Yesterday he was mentioning about, sorry, sir. Myself, Rajat, I'm a PhD scholar from US, Bangalore, sir. So yesterday he was talking about the development of sensors with sub-nanometer level spectral resolution. So do you really think we can extract more information from that data? And I feel that we are not able to exploit full potential of even the hyperspectral data. So do you really think the need of sensors with sub-nanometer level spectral resolution?
Thank you. Thank you very much. Now I'll have to wind up the session. Thank you very much for the very, very important and comprehensive presentation, Dr. Ravi Narayan Sahu. Training come workshop, what we call, is very, very important. And I'm very happy that many students in virtual mode, many participants in virtual mode, not only students, but our colleagues from private companies, and also the startups, maybe some from startups, maybe from some young entrepreneurs, from privately practitioners, they might have joined. And total presence, I'm highly encouraged, and I'm very happy to learn about that the total participation was huge here. And the subject which was dealt here for last 10 days is very, very important subject. Although previously also some trainings were conducted, but under the umbrella of NAHEP, this is one initiative, what we call CAST. Within CAST, we are conducting some training programs, some workshops. And when we call workshops are always focused on some of the theme areas wherein you try to give hands-on training, also have a discussion, come up with some points which can further help us to refine the technology. It's not only drone, it's not only the airborne hyperspectral remote sensing. You might have attended many lectures wherein other subjects were also directly or indirectly touched. I have gone through the total schedule which was prepared for your training program, day-to-day schedule, and came to know that the variety of subjects were dealt here. When we call any new technology, when new technology is there, always teething troubles are there. Remote sensing, for that matter, is quite matured in this country. Within the spectrum, the hyperspectral, near or mid or infra, all these things we were researching for quite a long time since now. And during last four decades, at least last 40 years experience with all these things, and Indian scientists engaged in this kind of research, we found that this area has taken Indian agricultural research to a long way. Where we started initially and where we are at present, we really feel very happy in this area. Now, yet another dimension, that's unmanned aerial vehicles, or what we call today drones. This is yet another addition to that. Meanwhile, the phenomics and also precision agriculture, whether it was sensor based or whether it was rate based and whether it was transmission based, variety of devices emerged in this country. And everything was linked with the precise input application, whether it was nutrition, nutrients or pesticides or chemicals or water or for every application, we tried to take advantage of this technology and we were successful in different pockets. Although we have failure stories, try to understand, we have failure stories and we are very lucky that we had some failure stories. With those failure stories only, we learned the lessons, and by learning lessons, we refined our technology over a period of time. This is the story of last 4-5 decades. It is not that things have happened overnight. And here, after this also, when we are trying to link everything together, we will come across several difficulties. Like our colleague from IIMR, she was telling, when you are applying using a drone, you are able to open the canopy of rice, but not the canopy of other crops. Then when you are not able to open the canopy, then application and it's is receiving on the surface of the leaves or on the canopy will be different than the closed canopy. So these things are there. These are practical difficulties. Our private partners were trying to come up with some good quality devices by scaling and lowering the cost. For them, the problem is much difficult. Actually, we are the researchers. We'll try to come up with some technology, we'll have some solutions, and we'll tell our private partner these are the solutions. But for them, the first question comes is the linking things so that we can emerge, we can really develop some mega picture. So for that, you require something for the linkage at the cloud level, or some broad kind of platform is required to link all these things. Otherwise, collecting this information or going for input application or real-time information, somewhere some platform is required, which is missing at present. Secondly, when they are producing something, they are in business, they are not incurring the losses. Always any businessman, any business partner will look for the benefits of the company or benefits of the firm. So they are not working in the same kind of system where we are working, but they are working in a capital positive environment. For us as a scientist, we may not be having capital positive, but we also do not work in socio-politically neutral or socio-politically vacuum environment. Therefore, the social matrix is very important and scale is very important. And for this technology, scale is very important, because unless you come at this scale, you will not be able to make benefits. Our private partners will always be looking at scale. And looking at scale means upscaling of the technology. When big state is there, big district is there, and for them, if they are going for, then it will be profitable for them. Otherwise, we have successes. Means in phenomics also we have successes. Whether it was the monitoring and it was the application of nutrients, we had successes. Nutrient sensors, limitations are there, but successes are also there. In the make 100% utilization of this very, very important area. And we want to really take up at the national level. That's why ICR is very, very serious. We have one precision agriculture project through which we are trying to come up with good scientific tools, techniques, and models. Also, the prediction models, some of the models Dr. Sahu tried to explain here, and some of our very successful areas, whether it was in engineering, it was in fisheries, or it was in nutrient application, it was pesticide application, or the moisture sensing, all we have successes. But now these successes are to be spread all across the country. Therefore, identifying the ecosystems and hotspots and enabling them with the doable policies will be the way forward. Unless we go in that mode, we will not be able to do justice with this subject. But considering the importance of topic, training come workshop, this training come workshop is for the mostly for young entrepreneurs, young students, and young professionals who are interested to adopt this as their future career. So for them, my request would be, this is very, very important training program. All the lectures delivered here, I believe they were par excellence, and you'd have taken full advantage of that. Please take the message, go to the field, and try to inculcate all these things, add this to your kind of research you are doing and kind of developments which are happening in the country. You are the ambassadors, and if you take this message down below, then there is no time. Certainly, investment is required, but definitely together, if we join hand, government institutions, non-government institution, private institution, probably then we will be able to take the message to a broader scenario and broader canvas. So all the very best to you for this important, completing this important training workshop, and my best wishes and best compliments to the organizers, particularly to Rabi Narayan Sahu and Dr. Vinay Sehgal for conducting this training program. And I'm also conveying my sincere compliments to Dr. R.C. Agrawal, who is heading NAHEP, who thought that this is one area wherein it is necessary to train more and more young people so that the country's future would be bright and better. All the very best to you. Thank you very much. छोटा सा vote of thanks, huh?
Thank you all very much. And now I request our course coordinator, Dr. R.N. Sahu sir, to present a bio-air purifier to our chief guest, our chair of the session, and a memento. Thank you, sir. Now the next session will start at 2:30. This is the break for lunch, and now we will meet at 2:30. We will start at 2:40. Sir, thank you.
आवाज आ रही है मेरी? Yeah. So today is the last day, sir, and that to last panel session. And UAV technology and its applications, policy imperative. And so this session, we have with us Professor Indramani, Vice Chancellor Parvani as the chair, and also Dr. Anil Rai, Assistant Director General ICT as the co-chair. And Dr. Indramani sir will join online from the Parvani. And Anil sir is here, sir, and we have a speaker, Sunili Grantiwar from Rahuri. They're all expert on drone technology in different applications. I think Rahuri is very famous for that purpose. And Professor Indramani is our very senior colleague and long association with IRI. Sir, we are missing you very much. And particularly at this moment. And you have been involved in the drone technology in agriculture and also for developing a policy document. And we have with us Anil Rai sir, who have been involved with us, different data analytics, subcomputing, and also national level program on precision agriculture, where drone technology is a core issue. He is coordinating the whole program with 16 centers, IIRI being the lead. And I would request Dr. Anil Rai sir, sir, I would request to be on the dais as the co-chair. And before we start the session and give the mic to Chair Professor Indramani, I would like to welcome you, sir, virtually with a bouquet of flower. I can't give, but whenever sir, you will be here, we'll send you this flower. And I would request Dr. sir to receive on behalf of and also virtually again, I welcome our very illustrious speaker, Dr. Sunil Gwarantigar, our senior colleague and friend, sir, with a bouquet of flower again. It is due for you. So with this, and also my colleague, my friend, Dr. Jaideep Mukherjee, Principal Scientist, Secretary of Physics, co-pay of NEPA program. He is going to be recording the whole program as a rapporteur. He will, and with this, I would request Indramani sir to take up the session. Sir, before that, again, I would like to say we had 8 days marathon rush on the hyperspectral remote sensing, that to an airborne platform. Starting from the ground to air to manned aerial vehicle to satellite, we covered all the aspects of drone remote sensing application in different fields, starting from precision agriculture to the plant phenomics. And we had wonderful speakers nationally, also internationally, from Purdue University, Melba Crawford, from University of Valencia, Professor Joachim, and also we had participants, something around 73 in person and 164 online, and the whole program was live streamed. And today we have an industry partner with their products showcased in the NRL audit for itself. We thought of we take this opportunity to make an effective interaction of these students and young researchers to interact with the drone industry partners and understand more and start collaborating and working together. So that's the purpose. If you remember, sir, you have been telling all the time, public-private partnership, and that's what we want to take forward. So with this, I again welcome you and please take over. Thank you so much.
Thank you very much, Dr. Sahu. It's a great opportunity for me to be with you, your team, although virtually, but you know, by heart I'm there with you in the institute. Very important activity, and I know your caliber, and I know the caliber of your team, although I could not attend the sessions, but I am sure that it would have been very much, educating, very much beneficial to the partners who attended the program. I welcome my friend Dr. Rai, Anil Rai, and the speakers, Sunil Gorantiwar. Madam Ravinder Kaur is there. Welcome, Madam, in this program, and all the participants, ladies and gentlemen. We all know that cutting edge technology is the concern not of only the scientists, but the government also, and industry also. And the particular session on aligning science and policy for UAB in agriculture is very, very important. And this is, I'm happy that some of my friends, particularly Dr. Gorantiwar, who is there on the committee from the very beginning, Dr. Rabi Sahu, who has been on the board, and some young scientist, Dr. Rauf is there. He has been working with us from the division. And this policy, drone-related policy started in 2018-19. There was an interface between ICAR and ministry, and there was serious concern. Mr. Ashwani Kumar was joint secretary, MNT at the time, and the job was entrusted to him. And then there was a committee under the chairmanship of Dr. Alagu Sundaram, T. Alagu Sundaram, and I was the convener. And that was, as Dr. Sahu is mentioning, that we decided that it is not only, scientists and officers should be there, but we got permission from the ministry to co-opt industry people also with us, whether it is pesticide industry and our drone industry. And in a time-bound manner, we gave the recommendation, which was accepted by DGCA and the ministry, in a very, very accelerated manner. And then those policy documents were ready. There was a number of interaction, discussion, and presentation even before the industry people. After taking input from all, policy document was prepared. Later on, you know that ministry decided that there should be not only, SOPs should be there, not only for insecticide and pesticide application, but nutrient application also. And there was a committee under Plant Protection Commissioner, Rabi ji and Ravi Prakash, and another committee. The job was entrusted to me to develop SOP for nutrient application. So all guidelines and possibilities, and so we submitted. And after that, thanks to government that they acted very promptly, and in a very short time, this drone application in agriculture was adopted by Government of India. Later on, you know that after that there was a concern in the ministry that crop-based SOPs as required, and again the job was entrusted to the same committee. I chaired the committee, and we did a very good exercise. And last week only I presented the final report before the Secretary Agriculture, Government of India, and my friend Dr. Gorantiwar and Dr. Rabi Sahu and all, they were in the team. And you remember the kind of satisfaction and appreciation was there from ministry side, and that is what your title is, aligning science and policy for EOB in agriculture. So without scientific input, and I'm sure that Dr. Gorantiwar will include some of those steps which we followed. Yesterday I was in Baramati, our ICR Institute, and I was sharing with the trainees, and they were very happy. I was telling them that tomorrow, if you get the opportunity to formulate policy, how to put science in that, in a perfect science, practical science, so that there should be, perfect way we can implement the policy. And not only that, after that, ministry has again formed a committee and again have given responsibility to the same team. I've been asked to develop a SOP for different kind of nutrient also, different form of nutrient, and we have started working on that. So I really thank the Secretary Agriculture, Government of India, and the whole team for expressing so much confidence in us, in ICR, in NARS system. Not only ICR, but we have taken, that Dr. Gorantiwar will discuss that we have, representative from in the committee from different universities who are working this. So whole NARS system is working and giving science base to the policy. And I'm very happy that you have selected Sunil Gorantiwar. He is Director Research at in Rahuri University. And above all, we have our Anil Raji, who is the fulcrum of all this digital policy on digital agriculture. So I think this is the best combination, and it is all being monitored, and the whole program is by Dr. Rabi Sahu. So I'm sure that this will be a very good discussion. Dr. Gorantiwar will make presentation. I would like that there should be more discussion if possible. So with this, I request my friend Dr. Anil Rai to make a brief introductory remark at this moment before I request Dr. Sunil Gorantiwar to go for presentation. Dr. Anil Rai ji.
So thank you very much. Actually, I thought that I'm going to meet you over here. My colleague and my friend, now his VC, Dr. Indramani ji, and my colleague, Dr. Ravi Sahu and John Mukherjee, and Professor Sunil, who is at the helm of affairs related to the drone technology. So thank you very much. And Honorable Vice Chancellor already told many things about this area, and the topic is very much important in today's context, like aligning science and policy for UAE in agriculture. And you know that Agri Drone program has been initiated, and we have already released the fund to the different universities and ICR institutes for around 300 drones, including KVKs. And there are some issues related to application and use of those drones because of this policy and other factors. So it's very important to align the science and policy along with this particular technology, and it is a future technology basically going to come. And we call it disruptive technology, like WhatsApp. WhatsApp is a disruptive technology, means all of a sudden the life of telecommunication and video communications change because of it, certain technology. It's not incremental technology, it is disruptive. So drone is also one of the disruptive technologies, which is going to change the way how do we cultivate and produce agricultural products in future. Like it is going to change the cultivation practices. It is going to change the management practices of crop production. It is also going to change the input application. You see that now people are talking about different kinds of fertilizers which can be used and applied by the drone technology. So the whole production system is likely to change from this technology. So this is very important. And fortunately, I met Professor Sunil, and I was very impressed while he gave a presentation in Palampur. So I happened to be there, and whole galaxy of politicians and governors were also there. So And it is very timely, this particular session we are organizing, and there is a lot of things has to be done, including the SOPs also. The SOPs has to be developed for different applications of the drone in field of agriculture. So with this brief remarks, sir, thank you very much for giving me this opportunity, and I thank Dr. Ravi and my colleague sitting beside me, Dr. Joy, for giving me this opportunity to interact. And I think we should, sir, we should go for the lecture, sir. Thank you.
Thank you very much. Thank you, Dr. Rai. Now, Dr. Sunil Gorantiwar, you are invited for presentation.
Thank you very much, sir. I hope I am audible to all.
Yeah.
Yes. Yeah. I would like to share my presentation as well. Yes. Okay, sorry for this. I hope my presentation is visible. Yep. Hello.
Go ahead.
Yes, thank you. Chairman of today's session and Honorable Vice Chancellor of Vasantrao Naik Marathwada Krishi Vidyapith Parbhani, respected Dr. Indramani. All of us know that Dr. Indramani, in fact, has either conveyed or chaired 4 committees of application of drones in agriculture. So I would like to say whatever the committees at the government levels have been formulated, Dr. Indramani led those committee. So first committee was in fact chaired by the then DDG, Dr. Alak Sundaramji, and our respected Indramani was convener of this. And then after that, subsequent 3 committees were formulated by Ministry of Agriculture and Farmers Welfare. And Dr. Indramani is chairman of all those committees. And I'm happy and very pleased to note that Dr. Indramani is chairman of this very important session. Though I will be presenting few things and there will be more discussion, but I think many of these things have been drawn in consultation and with discussion from our esteemed chairman, Dr. Indramani. And I'm happy to note that Dr. Anil Rai is co-chairman. Yes, we met in Solan, and in fact, we had some important discussion. And then he is instrumental in fact, drafting and preparing the policies for dissemination of the drone technology, application of the drone technology through KVKs. And really, he has adopted very good policy, and subsequently, this has already been accepted by the Ministry of Agriculture and Farmers Welfare. And as a result of this, KVKs are receiving the funds for this purpose. Though all the KVKs, they could not start, but the process is going on. Then Dr. Ravindra Kaur Madam, and at the same time, the convener of this particular workshop, Dr. R.N. Sahu Saab, actually. In fact, Dr. Sahu Saab, today only the Honorable Director of IRI, Dr. A.K. Singh Saab, visited our drone facility. And at the same time, he also visited the application of drones, spraying of the pesticide in field. And then he has provided a lot of suggestions and guidance, which will also be useful for the today's lecture. But I would like to mention particularly here that he mentioned that Dr. R.N. Sahu is really doing excellent work in IRI as far as the advanced and required application of drones in agriculture is concerned. And he ask us whether you are in contact with us, with Dr. R.N. Sahu or not. But then I could mention him that when we organized the first workshop on drone in Pune before COVID, we invited Dr. R.N. Sahu, and he is continuously the part of the discussion on application of drones in agriculture. All other esteemed delegates, experts, and the participants, and I hope there are certain drone manufacturers and service providers also in this meeting or in this workshop. Very good afternoon to all. In fact, today's topic of the workshop, UAV technology for agriculture and aligning science and policies for UAV/drone in agriculture. Though UAV, unmanned aerial vehicle, is the proper name, but then the general name is drone. So I'll be using drone vis-a-vis UAV as far as my presentation is concerned. This aligning science and policy for drone in agriculture is quite a travel, and I should acknowledge the organizer for arranging the workshop. In fact, thinking on this actually. So before I start my presentation on this, I would like to give two examples wherein these science and policies, if they are not aligned properly, what will happen to the technology. And both these are from my area because I know that. One is related to drip irrigation. When early in the beginning of 80th century of at the decade of the last century, or I will say that in early 80s, we didn't have the proper diplomatic relationship with the Israel, but when they opened in, I think, 1984 or 85, then many of our policymakers, ministers and secretaries, they started visiting Israel actually. And all of them were quite impressed by the adoption of drip irrigation technology for agriculture in terms of saving in water, nutrients, and also enhancing the crop yield. And upon their return, they started to think how drip irrigation technology can be applied in India, and they released certain policy, and that policy, of course, consisted of providing the 50% financial assistance those who adopt the drip irrigation technology, because whenever the technology is new, then it is also expensive. The farmers, they are quite apprehensive about the adoption of this technology, result and all those things, and we have to provide the financial assistance to any of the new technology that come into the market. And in the state like Maharashtra, in addition to this 50% financial assistance, 40% of the financial assistance either was provided by the state government or the sugar industry. So as such, 90% of the financial assistance means almost the drip irrigation system was free to the farmers. But the result was that the farmers, they have adopted, I would say adopted, purchased the drip irrigation system in large scale, and there were so many drip irrigation sets installed on the farmers' field. But when we look back towards the adoption, just after 5 years, we found that many of the drip laterals, they were lying wound on the farmer's shed. The PVC pipes, they were to be used for lifting of water or lift irrigation scheme, and virtually nobody was adopting the drip irrigation system actually. When we made survey, then we found that we were told that drip irrigation system saves water and at the same time enhance yield, but we did not find any of these benefits. But anyway, we got drip irrigation system free of cost, and we purchased, but then this is the result. Then, of course, the evaluation indicated that.
Sorry to interfere. Your slide is not changing, sir.
Yeah, I'm coming to that actually.
Okay, okay.
Yeah, this is not the portion of the slide actually. Then it was found that though the government encouraged the policy, okay, but there were no technology and science available for the adoption of the drip irrigation. Okay, so that's why when policies and science, they don't align with each other, then the technology that we intend to adopt on the farmers field fail miserably. And then of course, then many universities and organizations, they develop the science for the adoption and also technology for the adoption of drip irrigation technology, and you know the result actually. So this will also happen for any other technology. But as far as the drones are concerned, I would like to mention here that the governments and policymakers, they are aggressively following the use of drones in agriculture. And at the same time, the scientists and the organization like yours and other organizations, okay, they are also developing the science-based technology for the adoptions of drones in agriculture. But at the same time, the governments, they have actively or I will say proactively included the scientists in this mechanism. The result is that there are so many committees which are chaired by our honorable vice chancellors, and also having the members as industries and scientists. So this aligning is very important, and as far as application of drones is in agriculture is concerned, in fact, that is happening actually. I will, to start with my core presentation, I would like to provide certain things wherein the government has taken the initiative, and at the same time, science is also being developed, and how those are being aligned, and this disruptive technology, as already been pointed out by Dr. Anil Rai, will change the agriculture. Our honorable Prime Minister also said that drone is the game changer in agriculture. Okay. So now this is second slide, Dr. Sahu Sahab. I hope that my slide.
Yeah, all right, go ahead.
Okay.
Go ahead.
So focus of my presentation is government's encouragement for use of agriculture in drones, government's initiatives for application of agriculture drones, opportunity and challenges for application of drones in agriculture, wherein our scientists, they have a lot of intervention, future perspective, and then fifth one is aligning science and policies for drone in agriculture. Okay. So all of us know that on the occasion of beating the retreat ceremony at Vijay Chowk that marked the end of country's 73rd Republic Day celebration, that was in fact witnessed by none other than the then President Honorable Ramnath Kovindji and our Honorable Prime Minister Honorable Prime Minister Shriman Narendra Modi ji. So that was a mega drone event actually, and 1,000 drones at a time dazzled in the sky, of course, to commemorate the 75 years of the independence. But at the same time, government wanted to give signal that we are using drone, we are advocating drone in all the sectors of our development, and that was probably the beginning. And government also wanted to show wanted to indicate that yes, we are going to promote and the application of the drones, and this is now it will be the duty of the industries, scientists, and all other personnel involved that we should develop the proper science-based technology. Okay, then that was the drones in general. But then at the same time, this application of drones in agriculture. So to promote the application of drones in agriculture, all of us know that the Kisan drone concept has been launched by our Ministry of Agriculture and Farmers Welfare. And Honorable Prime Minister himself flagged off 100 Kisan drones in different parts of the country for spraying pesticides and other farm material as a part of Drone Kisan Yatra on 19th February 2022. So from 26th January 2022, so there was mega drone event, and just within a span of 1 month, then Kisan drone was also launched. Our Honorable Prime Minister not only indicated the India's rising capability of the drone, but he also narrated us that the drone should provide the employment to the rural youth, and it should also act as the instrument for generation of the employment opportunities for the rural youth. Then extending the Kisan drone further, there was one workshop. I think many of us, we have attended this, and this was inaugurated in ICR New Delhi on 2nd May 2022, and it was inaugurated by Honorable Agriculture Minister Narendra Singh Ji Tomar. And this title of the conference was Promoting Kisan Drones, Issues, Challenges, and the Way Ahead. So there were 3 technical sessions, and many of us, I think probably participated in this particular conference in some or other way. And this was the conference which in fact kicked off all the technical issues, policy issues, which were related to the adoption of drones in agriculture. Then another is the Bharat Drone Mahotsav. So again, which was inaugurated by our Honorable Prime Minister. And while inaugurating that particular Drone Mahotsav, our Honorable Prime Minister called drones as the great game changer in agriculture. And he further said, drone technology is going to play a major role in empowering farmers and modernize their lives. And he also said on that occasion that this drone technology in agriculture is going to show, or India is going to be the leader, and India is going to show the direction to the other countries how we should apply the drones for agriculture. So such was the confidence. But not only our Honorable Prime Minister and Agriculture Minister, they are promoting the drones, but our other ministers as well, Honorable Nitinji Gadkari, he is also advocating aggressively the use of drones in agriculture. And he is also advocating us to start the research wherein we find the gaps in adoption of drones in agriculture, such as batteries, the issue. Then he asked us, why not you start the research wherein we can use the petrol engine or ethanol based engine for flying the drones. And he connected us to some of the industries wherein we have now started the research studies to apply to operate or to fly the drones by using the petrol or ethanol kind of the things. In fact, the purpose of telling all this fact is that we are trying to align policies and science, but as far as the policies are concerned, and as far as the government's promotion is concerned, I think we are very much on the positive side. There is all kinds of the encouragement as far as the policymakers are concerned. But at the same time, there should be the certain initiatives are also needed for applications of agriculture drones. And I will say that for this particular purpose, policymakers and scientists, in fact, they have hand in hand, and together we have formulated certain rules and policies which are now making application of drones in agriculture very easy and with ease and without any problem as far as the ground level is concerned. The first initiative was Drone Rules 2021, and as all of us know, and our Joint Secretary DGC has already been advocating us that. So there were so many rules earlier before 2021 that those rules were like such that don't use the drone rather than using the drones. But when Honorable Prime Minister came to know, then he formulated the committee and the drone rule 2021 and subsequent modification 2022 came into existence. Those who are interested, they can go through this document and you will find all what we need to do to use the drones, not only for agriculture, but for other sectors as well. When we go through all these rules and regulation, we see that, in fact, government has formulated the entire drone policy or crafted the entire drone policy in such a way that we would really be encouraged to adopt the drone. And whatever our Honorable Prime Minister told that India will be the leader and drone will be the game changer. So that will surely be going to happen. Such is our liberal drone policy. But at the same time, it is not only liberal, but also it is taking care of all safety measures and all security measures of the country. So we should really acknowledge the concerned scientists and the policymakers who were involved in that. The first, the tools that government came with the Digital Sky platform. So this is one of the government very good initiative. So maybe you can, many of you can access or might have access, or maybe in this training program you have been told about the Digital Sky platform. So this is the instrument by which we can do several of the things as far as the drone is related online actually. And certain time limits and all those things have been prescribed for obtaining permissions and all those things. And when we discuss with the stakeholders, we found that so this is in fact happening with these time limits. And if there are certain difficulties, then we can report those difficulties, and accordingly the solutions have also been found out. So Digital Sky platform is the platform through which we can register our drone, we can register our model, we can register for the drone training organization, we can register for the drone pilots. Okay, and there is ample other information as well. It also tells us that which are the zones wherein we can fly drones without permission, with permission, or we can't fly the drone. So this one of the initiatives which is really very handy for all of us. Then after this drone rule 2021, government also released the interactive airspace map, wherein the green zone, yellow zone, and red zones have been specified. I won't tell you the details of that. I hope that you already know or might have been told. Green zone is the zone wherein we can fly the drone up to 400 feet height, and as far as the agriculture drone is concerned, that is sufficient. In yellow zone, we need certain kind of the permission, and in red zone, we cannot fly drone. Of course, there are certain options for this. But this is the interactive one. That is, if you want to find that whether your farm comes in green zone, yellow zone, or red zone, I think you will know if you access to this particular interactive space map, and you need not to inquire or approach to any district authority for this purpose. So this is that interactive map. And the most important thing for agriculture drone was SOP for agriculture drone, because drone 2021 policy was released, but as far as agriculture was concerned, there were no guidelines, there were no rules, there were no regulations. And many of the farmers and drone service providers were approaching the government for this purpose. And this is the point wherein government formulated the committee. And this was chaired by the chairman of today's session, Dr. Indramani. And I was fortunately the member of this particular committee, I think along with Dr. Sahu Sahab as well. Then when I received the document that I'm on the committee, then I thought how we can provide the guidelines and rules and regulation for SOP for drone application. In fact, at that time, though we had started drone research in MPK Rahuri and also established the drone lab, but as far as the standard operating procedures are concerned, I was a bit clueless. But I know that my friend Dr. Indramani was the chairman, and he will find or he will come out with certain solutions. Then for formulating these SOPs, then we consulted so many, means it was like that. It was thoughtful approach by our chairman. He involved the policymakers, he involved the drone industries, he involved the drone service providers, he involved the farmers, and he involved the scientists across all over India. There were so many online consultations. There were so much our in-house consultation. And I think the number of meetings that we conducted for this was 30 plus. And some of the meetings we used to conduct from 10 p.m. to 12 a.m. as well, because the time was the constraint. And in that case, we prepared the exhaustive questionnaire, though it was exhaustive, but it was very friendly. And we obtained so much data. And on the basis of this data, we developed the drone operating policy for operation of the drones in agriculture in general. And at the same time, we also provided certain rules and regulation. So all these rules and regulations, they are available this in SOP document, and which is available on website of Government of India as well. And I would like also to narrate here proudly that we didn't conduct the single in-person or offline meeting for this purpose. Everything happened online and so efficiently. So this was the result of including all the stakeholders, right, from policymakers to scientists. And this was very much acknowledged at the government level. And this is the release of this particular document, though none of our member was present because that was also held in online. And this was some receding COVID period. But our Honorable Chairman presented this drone policy, and subsequently this was released by the Honorable Agriculture Minister Narendra Singh Ji Tomar, and in presence of our State Minister and all those secretaries who were involved in that. I would like to appeal all those who are present, if you haven't gone through this particular SOP document, I think this is very good document, and you must refer to this document. And then when at the ministry level the discussion was being conducted, then they also realized the need that the crop specific drone SOP is required. And then accordingly, considering the success and the time frame during which the first SOP has been drafted by Dr. Indramani's committee, this task was also been assigned to Dr. Indramani committee. And again, myself was member, Dr. R.S. Sahu Sahab is also member along with others. Then as far as developing the SOPs in general was a difficult task, but we fulfilled. But then crop specific was really the matter of concern. But again, we had solutions. Then the scientists from the different universities were consulted. They were asked to conduct certain experimentation. They were asked to provide us the data of the experiments that were already been conducted. So accordingly, Tamil Nadu Agriculture University, Andhra University, Telangana University, Mahatma Phule Krishi Vidyapith Rauri, Parbhani University, IRI, and I think Punjab Agriculture University, Ludhiana, they have really supported us, and we got the 70 sets of the data. And when we got those 70 sets of the data, then we are really comfortable. We are a bit relieved as well. Then after that, again, we consulted policymakers and industries, and we had a lot of feedback from the industries, and we prepared the second, this SOP, which was extension to the first SOP, that is the crop specific. And Dr. Indramani presented that last week only, and it was greatly acknowledged by the secretary, and probably this will be available on website maybe in next week. And after that, we were asked to provide the SOP documents for the chemical and nutrient specific as well. Again, this is very challenging, but I know Dr. Indramani has solution for this, and we already conducted first meeting, and other meetings and other consultations will be conducted as well. The purpose of telling this is that policymakers and science, if they go hand in hand, then in fact we find the solution on quick basis. Otherwise, if say policy has already been released, and then if there is no guidelines, then I have already given you the example of drip irrigation system, the technology will miserably fail. And here at the same time, the governments encourage scientists as well, and we conducted experiments, certain studies and surveys, and we found the solution. Then as far as again policy and scientists are concerned, then another very good thing happened. Ministry of Agriculture and Farmer Welfare released an interim list of approved pesticides to be used for spraying by drone. We know that as far as the pesticide is concerned, this is chemical and there are stringent rules. So the information was available for the pesticides which was SCAB approved and which is to be used. But then whether it is to be used by drone, so there was no guidelines. But I think in first committee report wherein Dr. Indramani was convener, so it was mentioned that something should be done, and then government released one memorandum on 18th April 2022 that whatever the chemicals, fungicides, insecticides, except the herbicides, which can be which are being permitted to use by the conventional sprayer can also be used by the drone. And then maybe now, once we submit our third report, probably there will be specific guidelines for the different kinds of the nutrients and chemicals. Then government also has this PLI scheme. I won't say much about this, but many of us know PLI scheme, but this is also applicable for drones as well. Financial support is required for any new technology. So 2 days ago, we had one demonstration in Solapur. So wherein farmers told that, yes, this drone technology is very formidable, but it is very expensive. We want to purchase the drones along with all the accessories for spraying. So it costs us 8 to 10 lakhs rupees, and it is they worked out the economics, and it is not really affordable what they said that. But then such type of the financial assistance scheme, if it exists in the beginning, then it really encourage the users and service providers as well. And so this is the financial assistance scheme which is available under submission of agricultural mechanization. So all of us can take benefit of this, and this has also really encouraged the use of drone. And part of this is also being drafted by our co-chairman Dr. Anil Rai, so through which we are able to make all kinds of the demonstration. So this was as far as concerned the government initiatives concerned. Then together government and scientists, how hand in hand we are promoting the use of drone in agriculture. But at the same time, scientists also did a few of, sorry, before that, sorry, it is we need the different permissions required for the use of agricultural drones actually, because this is the aerial vehicles. And again, farmers were quite skeptical about this, but then these green, yellow, and red zones have already been declared. So where to fly the drone, that issue has been solved. Then this unique identification number is required. So that issue is also solved. Turning up the drones and permission required for the drones. I already told about green, yellow, and red zone. Then another thing is that the typecast certificate is required. So for example, any vehicle coming into the market, so that vehicle is permitted to bring on road. Similarly, when any kind of the drone, if we are to fly in air, so that model need to be certified. So that is called as the typecast certificate. And this typecast certificate drone, they are being manufactured as well. And there is particular procedure to obtain this typecast by using the Digital Sky platform. The purpose of telling is that so many manufacturers, they are coming, but they have to obtain typecast certificate, and there is easy means for making this typecast certificate available. Now I think there are 2 small drones and 3 medium kinds of the drone for which the typecast certificate have been issued, and many on queue. At the same time, if any user has to buy the drone, just like car. So car is the approved model, but if I want to buy a car, I need to get the registration number. Similarly, for drone also, we need to get the registration number. That is called the UIN, and that also can be obtained online. So wherein you have to match the specification of drone with the typecast, and by paying certain fees and filling certain form online, you can get the UIN. So this is what available on Digital Sky, and all these things have been made very easy. After that, we need the drone pilot certificate as well. Okay, so for that there is a scheme, Remote Pilot Training Organization, and for that also we can apply through Digital Sky. And once the Remote Pilot Training Organization certificate is available to the concerned authority or organization, then that particular organization is empowered to offer that kind of the training and apply on behalf of the participant for issuing the drone pilot to the concerned person. So I can proudly tell you that Mahatma Phule Krishi Vidyapeeth Rauri has already been permitted with this RPTO. We have already completed 2 RPTO training and issued the drone pilot certificate to the participant. But at the same time, another 2 universities, they have also obtained this RPTO. I think one in Telangana and one in Andhra Pradesh, and many other universities, they are in line for this purpose. In Mahatma Phule Krishi Vidyapeeth, what we did, and also appeal to other universities who are applying for this, we have coupled this RPTO with 2 days additional training for the drone spraying as well, because our customers, they are mainly farmers. So this is not just issuing them the drone pilot, but at the same time, we need to also train them appropriately for the spraying of the nutrients. So this is the 7 days training. Okay. And of course, this is a few things related to qualifications and how to obtain the drone pilot training. So up to this is fine. And as far as the application is concerned, all of us know that what are the different potentials of using drones in agriculture, what are the different benefits of using drones in agriculture, especially for spraying. Then what are the different issues and challenges for using drones in agriculture? That I know that this must have been covered in this workshop or the training. Then it comes to the cost economics actually. Then again, in our first committee, Dr. Indramani has advised us to estimate the cost economics of drone spraying, and then we worked out this by conducting certain operations and observations as well. And then we found that cost of spraying with profit of 30% by drone is 400 or maybe 425 rupees per acre. And when we compare with the cost of other drone spraying equipment, it is quite compatible. Actually, for other drone spraying equipment, including manual to machine, it ranges from 350 to 450 rupees per acre. And as far as the drones are concerned, it is said 420 rupees per acre. But when this drone technology spreads and the price of drone and batteries, they reduce, I think probably this cost may go down to 200 rupees per acre, and 200 rupees per acre. And along with the added advantage of the drone spraying, I think this drone technology, at least for the spraying, will come up like anything in India, and it is really the future of Indian agriculture. And as far as the drone spraying is concerned, our second committee came up with certain guidelines. I'm just briefly telling about these guidelines, the drone operating parameters which are required. So what should be the nozzle of drones, anti-drift flat pan, what should be nozzle discharge, 0.3 to 0.6 liter per minute, nozzle angle 60 to 120, pressure should be 2 to 3 kg per cm square. Then where should be nozzles placement? It should be either on boom or below the propeller. Number of nozzles for particular hexacopter type of the drone should be in the range of 4 to 6, swatch should be 3 to 6, and droplet size should be 150 to 250 micron. Then drone should be, as far as possible, flown at the speed of 4.5 to 5.0 meter per second. It should be in general above the canopy 1.5 to 2.5 meter. For varieties lodging to sensitive, it should be a bit higher, 2.2 to 2.5 meter. And while doing all those things, we should ensure that proper uniformity is maintained, control efficiency is obtained, and also field capacity should not also be compromise. As far as the application of nutrient and pesticide is concerned, as on today, the dose should be 1x. That is, the dose or concentration that we adopt, the dose that we adopt for the conventional spraying, the same dose we can adopt for the drone spraying as well. So this is as far as possible, as far as today. But whenever we progress with the research, I think maybe we may come out with the different kinds of the proportion. Then as far as the water volume is concerned, our committee specified based on the observation all over India that for early stage and for sparse canopy, it should be 20 liters per hectare, and for full development stage and dense canopy, it could be a little higher, 25 to 30 liters per hectare. And in any case, phytotoxicity should not be observed because of the increased concentration. We ensure that if we do this, that phytotoxicity is not observed. At the same time, proper bioefficacy is also achieved. Then as far as environmental parameters are concerned, we also specified the time during summer season, time during winter season, when to fly drones, when not to fly drones. So there is all detailed documentation reported in the our SOP documents. What should be temperature range, humidity range, wind speed? Because you know that this is the area spraying, it is very sensitive to the environmental parameters. All those need to be specified. Then there is a lot of future perspective. I won't go into detail, but then we can have the automatic drone spraying operation that also we specified in our SOP document. We can have the intelligent spraying drone kind of the system, wherein we can observe the pest disease, then intensity, and accordingly we can have the variable rate drone spraying as well. So that is also we indicated in our SOP document, and we also started research on that, whether we can do both the things by one drone. So that is also a possibility. So whether we can attach the drone decision support system to the tractor-based variable rate applicator. So that also we are exploring, and we have also started certain research on that. Whether we can identify the pest and disease and also its intensity with the help of drone. Those systems also we have started the research. So there are many such phenomena or activity. If our scientists and policymakers, if come together, I think we can make really not only spraying, but other operations possible with the application of drones. But as far as me is concerned, I think it is very much possible, because drone spraying is the example. So within a span of say 2 to 3 years, drone spraying is possible. The farmers have started spraying with drone as far as the nutrients are concerned, as far as the chemical are concerned. I think we can use the drone for almost all the agricultural operations and make the entire system, agriculture system, intelligent. And in that process, maybe we can make our villages attractive, and instead of having migration from rural to urban, if we make our farming attractive, then there could be reverse migration as well. I think with this, I would like to remain because as our chairman, sir, advised, we need to have more discussion, but I'm hopeful that I have created the base for this discussion. Thank you very much, and thanks for organizer for giving me this opportunity. Thanks a lot, and back to our chairman, sir, Indramani sir.
Thank you very much, Dr. Gorantiwar, for a wonderful presentation. You have covered all the points, and I would like to request Dr. Sahu, will it be possible to have some questions, or this panel discussion session is separate? Dr. Sahu, Rabi?
Anybody from IRI?
We have
Because time is 3:33. So, and by 4 we have to wind up. So
Right,
what
sir.
is the time, as per the time, what should be the strategy?
Maybe we can maximum up to 4 o'clock, we can go ahead. So we have industry participants also here with respect to sensors and also drones. We can take their input with respect to policy, what the requirement and how they are satisfied. And maybe then we can go further concluding, and also we can ask our students and researchers what the requirement for them. And so we can start with the industries first, sir. Then you can go ahead one by one.
Great. So we request, because my dear friends, when we were interested the task first time, this was in DTG engineering office, we proposed that participation of industry is must, because if you are formulating the guidelines and rule for for any system, the stakeholders participation is must, because this facilitates faster adoption, and this we have realized in case of drone policy. So I request industry friends to come forward and say a few words.
Good afternoon, sir. This is Anup Kumar Upadhyay from IoTech World Navigation Private Limited, Gurgaon. And we are DGCA, India's first DGCA approved agriculture drone company. So our drone is a multi-purpose drone because it supports spraying, seed broadcasting, and multispectral camera mounting, crop health monitoring. So in the regulation part, under the chairmanship of Sri Indumani sir, and Sahu sir, Gurantiwar sir, and many eminent scientists from IRI, SEUs, we have formulated the drone policy, agriculture drone policy for India. So it was a privilege for IoTech to work under the supervision of eminent scientists. Now one work is done, and I will take this opportunity and this platform to congratulate Indumani sir, Gurantiwar sir, Sahu sir, even Kushwaha sir, and many other people whose name I don't remember, and they have played an important role to ask government to lift ban from agriculture drone or drone policy. So I want everybody to give a big clap. Without their hard work, we would not have come so far. Agriculture drone adoption was a really very difficult task, because it was blocked by CIB and RC, because they have their own reasons, safety, security. I'm not blaming them, but we went on the field, we satisfied, we showed them the drift, we developed the SOP, and we took their confidence and requested them to remove the ban and allow agriculture drone in India. So they have done that work. Thank you, sir. But still, there are some more work to be done, like per crops SOP that we have to develop. We have to proliferate crop health monitoring up to the farmer level. So we also have to develop multispectral camera. That is what, under the supervision of Sahu sir, I'm sure we'll be able to do, because he has some very good idea where industry and academia can work together. So there are a lot more work, sir, we have to do. We require your guidance, and I'm sure India will lead the drone revolution as the vision is set by our Honorable Prime Minister. Thank you, sir.
Thank you, Anup. Any other present there, either from drone industry or from pesticide or nutrient industry?
Hello, sir. This is Fahimul Islam from Dronix Technologies, Chennai. So we are also a manufacturer of drones based in Chennai. And like our fellow industrial partners have already said, We have already seen the drastic change in the drone policy and how it has welcomed drones in the Indian market. And we have also been privileged by the facilities that the government has provided. And I think like how they have already said, we are looking forward. This was just a stepping stone. It was the first step of incorporating drones and using the applications of drones. And taking ahead, I think like how we are mutually working together. So this will help us to further improve the drone technology and help us serve the country better together. And definitely the feedback that comes from your side will help us to further improve the technology so that we can help you in the research purposes and provide you the facilities so that we can all together cater for the development for the country. That would be from my side. Thank you.
Actually, I was expecting. Hello. Yes, already left.
Hello. Yeah.
So what I'm expecting, my dear friends, please, raise some concern, not only just thanking the committee and thanking the process, because it's still a lot need to be done, because you know that as Dr. Anil Rai said, we have given provision to purchase, to give 300 drones, and recently I was attending a meeting and there was serious concern for the ministry. Even 30 drones have not been purchased, something like that. That was concern few days back. So how to resolve those things? You try to, at least every industry should give some points to facilitate the things in a better way so that we can communicate to the government. You are in touch with the even end users, you are in touch with farmers, you are in touch with some policymakers also. So we don't want just your introduction. We want that it is a panel discussion. So come out with some points which can help us and the system to implement drone in agriculture. Please go ahead.
Hi, my name is Arab Khan. I'm the founder and CEO of UAV Systems Private Limited. And it has been a privilege working very closely with Dr. Anand Rao sir. And I really thank you for inviting me in this stage to share my opinion. We have been working very closely on the drone ecospace for the last couple of years, and the way the policy has changed and the way the government has taken initiative to actually promote and really build this drone ecosystem in India is really amazing, which is really welcomed by the industry and the government. I would like to just add that our fellow partners, IoT, Dronix, there are a lot of companies who are really doing well in this space, trying to address to the the technological based solution in the advanced agriculture industry. Following the same, I think we have been working closely with some international partners, and as some of the people have mentioned in this whole the event that there is a need for multispectral sensors in India. So we are proud to announce that we are MikaSense's dealer and distributor and partner for India, and we are looking forward to manufacture the sensors in India. At the same time, we are also working very closely with a thermal camera manufacturer, because I think that is one area which is really lacking in terms of acquiring some field data. And today we have display one of our system, that is a fixed wing drone which we have developed in house, which is when it comes to the drones, I think the endurance is one of the major factor we need to take care of. So I think we all are putting our efforts, bits and pieces. What do you want policy to become? See, yeah, I think there have been a lot of efforts from the system. I think what is required in terms of is having a more the processes are bit lengthy and stringent. I think if we can rework around the policies and try to make much more simpler in terms of bringing this technology on the ground and make it useful to the farmers. I think we need to just rework around the process and make sure you are addressing to some of the loopholes which are there in the system. So thank you so much.
Thank you. Anybody from fertilizer industry?
Yeah. Good afternoon, sir. My name is Purushothaman from Electrotech International, Chennai, and we are the official representative for Edwal Photonics, US-based company, manufacturing hyperspectral images, right from visible region to the sphere region. And as you know, that hyperspectral imager is the upcoming emerging technology, and of course, it is costly. The payload cost something like 1 crore to 3 crore, 4 crore. So we need to have a very good drone with a good endurance, with a good flight plan controller, with a good flight planning mission software, so that you can get a good scientific data for your research application. But when we had a issue with this new policy, we are not able to import the drone, which has been tested, co-aligned, bore-sighted at our factory with our hyperspectral sensor. Now we need to work with Indian drone companies, and we need to know that whether we have such a highly sophisticated scientific drone. Maybe I can name it like DJI drones in India. Because you know that hyperspectral imager, it is on push-prone technology. It's on a framing technique, line scanner. So you need to acquire the data on a very stable platform. Maybe the spraying drones or other drones may be useful for application side, but for the scientific side, do we have a actually good scientific drone? Or whether a user can import a drone. Suppose if we don't, hyperspectral imager is also not made in India. So a lot of customers, they import. So same thing should be allowed to do with this drone also. So is it possible? Thank you, sir.
Okay, next.
Sir, my name is Dr. Dilip Kumar Kushwaha. I'm scientist in Division of Agriculture Engineering, IRI. And I was deeply involved in the development of the SOPs for application of drone in agriculture, as well as the crop specific SOPs. And a new thing is coming for soil nutrients also. That is actually crop nutrients application. So for that also a committee has been formed, and in that also I am the part. So for what we have seen during development of the SOPs, the technical things, the data is not properly available. So because we have to form the SOPs based on that. So the recommendations, or we can say the suggestions for the institutes, agriculture institute, is that we need more database from the agriculture universities, from the industry side, so that we can compile it. So that is the basic problem for specific SOPs development. Another point is that the technology, especially the drone, is now being sent to the farmers for basically spraying purpose only. But there is a technical problem in the sprayers are not available, the suitable sprayers for the drones. So I think there is a need to research in that area, and there is a very much requirement to collaboration of the drone industry, as well as the spraying industry and the academia. So this is the another thing. The third thing is that as in drone spraying, the drift is the problem. So we have to think of an out of the box, that how we can avoid the drift during the operation, so that we can apply the pesticide or nutrients in odd situations also. So these are my suggestions. Thank you. Thank you.
Thank you, Dr. Dilip. You have been really,
strategy in the organization. So I will specifically talk about the policy intervention which is required in this space, so that the drone proliferation can take place. So, in one hand, government has announced the huge subsidies, right? 40% subsidy, 50% subsidy to the farmer, 100% subsidy to the ICR Institute, KVKs and state agriculture universities. On the other hand, government is charging GSTs. So if it is possible for the government to eradicate the GST in case of drones, so it will be a good policy intervention. Apart from that, these sensors, multispectral camera, hyperspectral camera, all these sensors are used in the research work. And there is a good amount of import duty, which is there in importing these cameras and importing these sensors. So if these cameras are being importing for the research purpose, so the import duty exemption will be a good welcomed move, so that the cost of cost of these cameras can go down. And further, I believe, in proliferation of this ecosystem, having pilot certification is mandatory. And for getting the pilot certification, one needs to have passport, right? So if a villager or if a farmer want to have a, he does not have a passport, he has a ration card, he has a Aadhaar card. So since this product falls under Ministry of Civil Aviation, so that is why I think the government has introduced having passport in the pilot certification. But if this can be eradicated, the drone proliferation will definitely go up. Moreover, would like to inform to Indramani sir and all the respected professor scientists that we have already sold more than 100 agriculture drones to ICR, KVKs and State Agriculture University. Thank you.
Thank you. Dr. Sahu, anybody else? Okay. So participants, if you have some question to the speaker or to the chair or to co-chair, you are free to ask. 1 or 2 questions we can take up.
Sir, by your kind permission, if I can speak something about what the requirement. As you see, with respect to the Kishan drone and the procurement, Professor Gwarantiwar was talking about the 10 lakhs. That is the limit what we have kept. There are a lot of challenges with respect to, if you ask to, Kishan drone doesn't mean only spraying. And it, as I told at the morning and before launch the session itself, the precursor is the surveillance and the health monitoring. Then efficiency will be much better. Blanket spray is never is recommended. That's one thing. So for that purpose, if you want to have a drone with the sensor, it will go beyond 10 lakhs. So that is what, again, as you was talking, GST was 5% for academic institutes like ICR many, but it is now 18%. So huge amount money is required. And initially we had only IoTech World, as Dr. Anup, Mr. Anup was talking, but now we have 6 companies who are on DGCS certified and drones they can give for this program. And many are beyond 10 lakhs, the cost is. So we need to see how it can be changed. And recently I made a presentation with the joint director in the ministry, decided about how the express of interest would be. I think those parties taken care now. I think it is circulated by the commissioner, how to procurement has to be done that. But cap is the most important. The 10 lakh cap is one. So second part is, there are many sensor companies, they're playing monopoly. For example, if you see as a remote sensing experience or export, I'm working on the drone remote sensing. So I see multispectral MechaSense is gone out of function production now. Now they have come out with MechaSense P, which is costing more than around 10 lakhs. And then with time, again, they will do little modifications and that will be something around 19 to 20 lakhs, like for example, Altum P. So unless until we, with the industry, work on the developing some of those sensor technology, low sensor cost technology,
and compete with, it's going to be very difficult because you can't see the common poor man. He can't buy this kind of expensive sensor to go for high-level spraying for the health monitoring and the spraying. This is what the third point is, as Dr. Dilip was talking, we need to do a lot of research with respect to nozzles. I think CI Bhopal and IRA also has been working on with respect to droplet size and also different SOPs for the different pesticides, particularly insoluble pesticides. That's the biggest challenge remains with respect to phytotoxicity and also bioefficacy. So these are some observations, and we need to take care and look at the policy level if at all we can be more leverage those policies for buying some drones. For example, I have a very expensive hyperspectral camera. Hardly there is any company who can tell your camera can fly on my drone. So that's still R&D is going on. Many of us here, and we are interacting with them, but never it is tested. So, but it has been tested in US and Europe by DJI, but DJI is no more we are allowed here to take. Of course, that is a good thing, so that we should start thinking ourselves to build up in-house capability. Same time also we need to develop our infrastructure and also support to see our industries are working together with the academia, technology partner, so that we are able to compete with something like that, DJI or anybody. So they have been working with the institutes, but we don't have that kind of ecosystem. We need to encourage that kind of ecosystem here. Thank you very much.
Thank you very much, Dr. Sahu, for your concerns. Now, as we want to, we have to wind up now. First, I would like to request Dr. Gorantiwar to make a very brief response to the, points raised by the industry friends and our own friend, Dr. Kushwaha and Dr. Sahu.
Yeah,
very brief, very brief.
Yes, thank you very much, sir. As far as the industry personnel are concerned, their points are right in their own perspective. One is GST as well, but I think when we discuss on different platform, probably it is very difficult to exempt the purchase of drone from GST. But at the same time, the financial assistance or subsidy can be increased from 50%, and maybe we need to give proposal for this. Second thing is that as far as the loopholes are concerned, yes, there are. This is the beginning, and there are certain loopholes that we also observe. I would like to appeal the industry personnel to provide us the feedback on those committee and whatever loopholes you feel to us. Maybe Dr. Indramani is our chairman, so you can provide to him or maybe to our member secretary of the committee. The third thing is that the development of the different SOPs and all those things. In fact, we would also like to appeal you that let us work collaboratively together, because this is very important as far as the drones and all those are concerned. Various models and all those things are coming into market, and as university and research organizations, we may not compete with the speed in case of the procurement with you. And maybe if we do collaboratively, I think we will find the solution to this. One example is that we have MOU with IoTech. Means Dr. Indramani has already has signed the MOU with IoTech with his university, and the 2 days later we also signed, and then we may start certain collaborative project. Maybe I will appeal other organizations to also go into that mode. And another point, Dr. Kushwaha, who is very important member of our committee, has pointed out that you need to provide us certain data sets as well and help us in obtaining certain data to refine our drone SOPs. Some of the companies they already provided, but others can also supply to this. And as far as this the sensors and all those things are concerned, echo the feeling of Dr. Sahu Saab. Yes, the subsidy is given to the drone sprayer. Actually, when we raise this point to the government level that for mapping and sensor, so it is not available. But then they ask us that maybe you can go with RGB kind of the sensors in the beginning that will fit. But as far as our research organizations are concerned, hyperspectral imaging and all those kinds of the sensors they are expensive. And in order to promote the research, in this particular domain, we also need to have certain support from the government. Thank you very much, Chairman Sir, for allowing me to have brief comments. Thanks a lot.
Thank you very much. Dr. Anil Rai, a very brief comment, please. As a response, if you would like to add to Dr. Sunil Gorantiwar.
No, sir, nothing much to say because everybody has already raised the points which was there in my mind. So definitely there is a need of policy intervention related to the spraying drone, basically which agri-drone project the government has started. And the problems are being faced in procurement and also in application also. And as without mapping, it will be uniform spraying over the crops. So mapping and spraying should go together. And of course, the cost is one issue. So that has already been raised. And other point is to maintenance, because suppose somebody buy a drone and there's no service center and there will be problems. So how it is going to be maintained? So that also needs to be looked into this policy. What is the guarantee that if drone is purchased by someone and the service center is very far away, so the costing will be very high. So of course, in due course of time, it will be like a repair shop, drone repair shop will be there. And before it goes to that extent, we need to look into this matter. So thank you very much.
Thank you. Thank you, Dr. Anil Rai and Dr. Gorantiwar. Now, friends, it has been a very educating session, even for us, because we are being asked a number of questions by even the government when we are in the doing work of the committee. So before giving my comments, I want to acknowledge the contributions from the ministry side. Mr. Ashwani Kumar, who was Joint Secretary at the time when we started, then Somita Biswas Madam. At a point of time, we used to call her Drone Lady. And then the present Joint Secretary, Madam Srivastava, the Additional Secretary, Mr. Lekhi, and two Secretaries of Agriculture, Mr. Agrawal and Present Secretary. So a great contribution, a great interest by all. Two of my young friends are here, Dr. Dilip Kushwaha and Dr. Rao from Division of Agriculture Engineering. From day one, they have been, supporting and working with us, and I acknowledge their contribution. Regarding, the session, you all understand that this is very important, and Dr. Gorantiwar had presented very in a lucid manner that how science base was given to development of policy. In fact, in first, committee, Dr. Gorantiwar was not there, but all other my friends were there. And we, in fact, experimented, Dr. Anil Rai, we went to Haryana, Tadauri area, and with the help of the industry, drone industry and pesticide industry, and we worked on the farmers' field on different crops, including paddy, the sugarcane, and even fruit crop. And we did experimentation even in IRI field in which all different persons were there. And that basically, clarified some of the, points, inertia points which were in our mind. And then as Dr. Gorantiwar mentioned, there was a very serious concern from CIBRC. And they used to quote always the case of Indosulfan case and application by aeroplane, and that caused havoc. And it took a lot of time to convince them. And these secretaries and other, they were very important to convince them that this is not aeroplane, this is unmanned aerial vehicle, and it is going to operate just 1 or 2 meters above the crop. And we will be having control on drift, we will be having control of uniformity and all those points. Dr. Our Rabi Sahu raised very important points that this 10 lakh is not sufficient, and drone is not only for pesticide application. Basically, it is real-time application should be there, variable rate application should be there, all sensor and different capability camera, etc. should be used, artificial intelligence should be incorporated. All those points are there in our second committee in which I was chairing, and my all friends were there, including Dr. Sahu. We made very clear to the government of India that please open center of excellence, 4 or 5 in the country, where those centers should generate data, because we all know that we are struggling for getting data related to application science. Scientific team cannot believe on other than experimental data, and that's why Dr. Gorantiwal not very vividly mentioned that presented that part where we have said that for this aspect we have data, for other aspect we don't have data, and that we have written in the committee report that we have not received data, and we other day I told to Secretary Agriculture that this is not the complete report, this is a dynamic one. So far we are giving only for 10 crops, and there are number of crops, so we will be working on it, and every 3 months or 6 months we will update that report. But as in our report, earlier report, we had given that ICR should give money. So 2 aspects are there. One, that application of pesticide are nutrient at uniform rate, but there is need of research, and the person like Dr. Sahu, and not only at IRI but all other different universities, etc. Because we will need, my dear friends, even if we see that how we are going to deal with the crop health monitoring and all other issues, even then we will need a big library, and we need a lot of data coming from different parts of the country, because we have different ecological situation, we have different cropping system, we have different seasons, climatic situation, all different things are there. That's why we want a plethora of data, and we will be working on it, and we are trying to convince the government that please open 4 or 5 center of excellence in the different parts of the country, so that they can coordinate with the institutions, north, south, east, west, center, like that, and they can coordinate with the institution. Even on 2nd May, who is Dr. Gorantiwal, he mentioned both Director General ICR, then Director General ICR, and Secretary Agriculture both mentioned that we do not have data. So this is very important concern, since Dr. Anil Rai is there at the Home of Affairs at ICR, and he is in a close door with the Joint Secretary, Additional Secretary, and Secretary. You remember Dr. Gorantiwal, when we mentioned that we need this much money, then they said we give lot of money to ICR, ICR should do it. We have to tell them that that lot of money is for other purpose, but for drone purpose there should be special allotment of fund should be there, so that sufficient data, appropriate data could be generated, and then basically we can give the actual SOPs. And I'm sure that with the thoughts and enthusiasm, the government is working, and we have dynamic Director General Dr. Pathak, Himanshu ji, and our friend Dr. Anil Rai, and all gamut of galaxy of research managers. We have very good bonhomie with the ministry now. Let me tell you, Dr. Rai, this is the this kind of arrangement. The ministry has inculcated a lot of confidence in us. The other day there was plethora of appreciation for ICR and SAUs from the ministry side, and from the none other than the Secretary Agriculture. So this is right time to convince them that if you want more science in policy, there is a need of more money to ICR, particularly for this purpose, so that we can assign the job and do the work. And another thing which we have requested from the ministry, that to ICR Institute and KBKs, to whom we are going to give 300 drone, Dr. Rai, we have prepared one pro forma, and through ministry we want to circulate that pro forma, and through you and the ICR, that they should also generate data based on that pro forma, so that it can help us help the science and policy both, and we can come out with the more robust, more implementable guidelines, SOPs, etc. With this, I enjoyed the session, not only because it was very scientific, but also because we have good friends here for discussion, Dr. Anil Rai, and all feeling like I'm present in the same hall where Dr. Rai and others are sitting in my IRI. Thank you very much.
Thank you very much.
Dr. Sahu.
Yes. Sir, great thanks to you, such a wonderfully conducting the session, starting with illustrious Professor Sunil Gorantiwar. How genesis of the drone policy till the success stories what we have, facilitating all the drone industries and also young researchers to work on the drone technology. I can't think of 2016 when we were showcasing to Prime Minister. It was really great difficult to fly in the campus, and now anybody can fly anywhere. Such a policy leveraging is there, and because of our interventions and under your leadership and also the industry's push. Thank you very much. And I don't have words to express the way you contributed to this technology. And since beginning you have been involved. So who else can be the chair of this session to talk about the science and policy for the drone technology for agriculture? Thank you very much, sir, for sparing such a valuable time, being Honorable Vice Chancellor and Chair having such a great responsibility. And I must thank to Dr. Anil Rai, sir, the co-chair of the session, who is leading the digital agriculture activities in the council. And he's also the coordinating the network program on precision agriculture from the ministry side. So sir has been always supportive for proactive, with respect to the technology, what we can take up. Always you look for whatever the technology you bring out, how we can transmit, how we can translate to such a way that KVKs and also the service centers can be benefited, FPOs can be benefited. We have a Kisan Sarathi program through which he wants to popularize it. So always we try to, we'll see, we meet your expectations, and I understand how important your value of time right now. He has been called by secretary in between. He went down outside the campus and came back again, joined with us. Now the Secretary of Agriculture is going to take a meeting on digital agriculture, what council is working in the ISRI. He has to rush to that meeting. Thank you very much for your benign presence over here and conducting the session. I must thank to Professor Sunil Gorantiwar, a very senior colleague and friend to us, and since long we have been working together for NHB program. And you could see the kind of policy presentation what he has done. And maybe sometime if you see the drone technology for different applications, it maybe whole day it will be taken, that will not be sufficient. The kind of work he has been doing with his team at the Rahuri. And thanks to you, I know many dignitaries are in your campus, being the Joint Director of Research, you have many responsible to take up some of those activities. Still, you could scoop out your time and give us. And thank you very much, Sunil sir. And I must thank to my colleague, Dr. Jaideep, who is the rapporteur of the session, to conclude to record all the proceedings for the purpose further to make a recording of that. And thanks to all the participants and industry partners who have been there throughout since morning till now. And this was the last session. And sir, with again token of appreciation, virtually, I can give you a biopurifier. But I will keep with me, sir, because Parvani, you don't need a biopurifier. So it's only for Delhi people. Same also, Sunil sir. And also a moment from our side, sir, when you will be here in campus, or we'll send you over courier. And now I would like to same also Sunil Gorantiwar sir.
Thank you very much. Thank you.
Thank you.
Sir, I have many plans, but anyway, finally, I would like to give this to our co-chair, Dr. Anil sir, and also a token of appreciation. Sir, I would request Honorable Sir, on behalf of Chair, if you can give a token of appreciations to some of the industry partners who are here. Mr. Anup. Mr. Arab Khan. From UAV Systems. Mr. Islam from Dronix. Mr. Purushothaman from Electrotech and Headwall Photonics, who is selling all hyperspectral sensor from ground to airborne. We have also other industry partners, but they're in the foyer, maybe later we'll keep. So thank you very much. And we'll get connected with you and try to see if we address some of those challenging areas. Thank you again.
Thank you very much. Thank you. Thank you all.
Thanks a lot.
So nice of
Oh, okay. So 4:15, we are going to start our valedictory function. In between, I will ask my fellow participants to be here. We are going to give you the certificates right now because 73 certificate giving physical is going to be difficult. We have only 1 hour tight session. So Dr. Rajiv is going to coordinate that. And 4:15 dot, we are starting. Already guests are arriving. Okay, just wait for 5-10 minutes. Thank you very much. Thank you, sir.
it gives me pleasure in welcoming today's chief guest amongst us, Dr. R.C. Agarwal, DDG Education, sir. We welcome you in the Division of Agricultural Physics and also welcome you to the campus of IRI and to the valedictory program of this particular training on hyperspectral remote sensing for agriculture, as well as the workshop on UAV for agriculture. I also welcome our respected Joint Director Research, Dr. C. Viswanathan, to the valedictory function of this program. I welcome our Dean and Joint Director Education, Dr. Anupma, to this valedictory program and also to the division, because ma'am, you are visiting first time in the capacity of Dean and Joint Director to our division. I also invite Dr. Anuradha and welcome her to the Division of Agricultural Physics, who is the National Coordinator for NEHEP program, sitting in the ICR headquarters. Sir, you may recall that Division of Agricultural Physics has been an amalgamation of different subjects and has been a focus with a focus to provide solutions to the agriculture by linking up different aspects of agriculture, right from soil to plant to atmosphere, and using different type of technological innovations since 1950s, and that is either using modelings or using data analytics or using remote sensing. And in this series only, when we have a well-established leadership in the field of remote sensing, whether we are doing from satellites or from drones, it is this particular workshop as well as the training program has been another milestone in our long journey in this field. Sir, you may recall that in 2005, you have been part of a training program in this department. And I very well remember because I was the course co-coordinator. And you please recall that since that time, even in 2005, we had been very much dedicated to taking this science to different, by building the capacity of different stakeholders and also providing some real-time solutions. So, sir, over the time, the technology has advanced, whether it is related to sensors, to analytics, to platforms, whether from satellites or from aerial platforms or ground sensors. So the things have become really exciting for our department. And I will say, sir, that our department is now in the limelight for providing solutions to various stakeholders. And sir, through your good office, still we have a big lacuna that this Department of Agricultural Physics, which has completed nearly 60 years of existence in IRI, has not been replicated across any of the other agricultural university in India. Only one place where it exists is in Poland. So in India and Poland, these are the two places where agricultural physics as a subject exists. And besides, but of course, I had a lot of interaction with senior US scientists. And when I told them about agricultural physics, they said it is really a marvelous concept, bringing such different kind of diverse specialities together to provide solutions. And they were wondering why they never had this kind of agricultural physics. So through your good office, I again want to urge that whatever support is needed from our side at the ground, if your blessings are there, we should be able to replicate this important subject, which is very important for bringing the digital agricultural revolution in India to be taken to different agriculture universities also. With this, I also want to say that, sir, we have developed over time state-of-the-art facilities. You please, 2005 versus current, we have very different facilities available. And you please find time. Whenever you provide us time, we want to give you a detailed presentation and visit to our labs and what we have been doing. it would be very heartening that where we have come over time, of course, with a great support from ICR, NHEP, and other programs, whether internal or external. To our Joint Director and Dean, I would say that, Madam, this is also the time, though we don't have agricultural remote sensing as a separate teaching discipline, but many of the universities, engineering colleges, which started teaching this subject in late 90s, now their students are in demand, and our students of agricultural physics are not able to compete with them, though we started teaching way back in 1984. We were among the first in this country to teach this subject at postgraduate level. So we also have to think how to fill up this gap, to start out a discipline or a small center where whatever research of this technology use in agriculture is to be more focused, supported, and nurtured. So with this, I stop my address, and thank you all for taking time out and visiting and coming to us for your guidance. Book is there? Okay. Sorry. So I was not told so I formally welcome again with a bouquet of flower to our chief guest of today's function, Dr. R.C. Agarwal, sir. Yeah, I also welcome our Dean and Joint Director Research, Dr. Vishwanathan, with a bouquet of flowers. I also take this opportunity to formally welcome our Dean and Joint Director Education, Dr. Anupma. And of course, this is also an opportunity to welcome Dr. Anuradha to our department. Thank you all.
Thank you, sir. I would like to call Dr. Ravi and Sahu to brief about the program and commence the introduction of participants. Sir.
Respected Chief Guest, Dr. R.C. Agarwal, Deputy Director General Education and National Coordinator NHEP, ICR, Dr. Anuradha Agarwal, ma'am, National Coordinator NHEP CAST, Dr. Anupama Singh, Joint Director Education and Dean, Dr. Vishwanathan, Joint Director Research, Dr. Sehgal, Head of the Division, my young students, young researchers, industry partners, colleagues from Agriculture Physics and also from IRI. Very warm welcome to all of you to this concluding session of the 8-day program on airborne hyperspectral remote sensing in agriculture. Sir, we started this program with an announcement around 2 months back. We got a huge response. It was very difficult to select. So we tried to select because the criteria is only to get 20 students for whom we have the support for the travel and stay. So we got 20 students selected. So out of them, 18 only could join and 2 couldn't, 11th hour they couldn't come up because of their regions, some other regions. Then I wanted, again with a request to the PI, Dr. Vishwanathan, I said, if since so much energy we are taking to do this program, if at all we can have young researchers, young scientists, assistant, associate professor, anybody who wants to join, if they can join on their own expenses, and that was agreed. And that's the reason it has gone from 20 to something around 50 plus now. So we have many who have joined physically, traveling all the way, starting from Kerala to Kanyakumari to Kashmir here, and taking care of their own expenses, staying and all the logistics. They are attending this program. And also we could see many universities, they couldn't come up, they couldn't participate also, and since limited seats, we thought if at all we can do live streaming and make it online. And that's the reason from the day one, we have been live streaming and putting all on the Zoom platform. Institute has around 1,000 participant capacity. So we are live streaming on the Zoom platform. Same time also we are recording and directly casting over the YouTube. So we could see around 600 plus response was there on the registration with respect to the training, and also for the workshop around 400 plus. But we could see regular attendance. Every day we used to take the regular attendance from online also. We could see there are around 164. So whom we are able to give the certificate, rest we are not able to give, though they are participating, but they're very irregular in the participation. And in physical, we have around 73 participation here, 20 students from outside Delhi, and many are from IIT campus and nearby sister institutes, and also many researchers around NCT and other states of the country. So with this, around 73 participants physically who could attend here. And if you see the program, almost around 14 lectures has been taken over the last 7 days, and 11 practicals has been conducted. And starting from hyperspectral remote sensing from the ground, in the control lab conditions, whatever the facility, what we have, Professor Sehgal has told over the years with the kind support of the ICR, DST, ISRO, and also NHEP, we built up our capacity, strengthened to the labs with respect to advanced technologies. You talk of sensors, talk of the drone. I must thank to Asya Agrawal Sahab and also Dr. Vishwanathan and Ma'am Anuradha for kind support, generous to have this facility with us. We have a drone remote sensing lab under NHEP, and also big data analytics lab under NHEP. So huge data what we collect from the field phenomics, and also the phenomics center, we are able to analyze that, and also we are able to give training of such kind, and also exposure to many young researchers who are coming over here. So on 7 days deliberations ended with a 1-day workshop, inviting the industry partners, and they could attend here because we wanted to see, though we are talking of the drone technology and hyperspectral remote sensing, they don't know how to collaborate, work with them. Maybe they can be partner with them, they can go for intern with them to strengthen their own exposure and capacity, and also develop a business partnership, a startup ladder once they graduate from this. So with this, we try to see, we invited something around 30 plus industries, but today itself, there is a program going in Kota on the liquid urea nano fertilizer demonstrations. Well, ministry is there. So 75,000 farmers mela is going on. So many of drone companies are there. So, but still we could see 5 drone companies who could be here and interact. And today we had 3 panel sessions, started with the platform, sensor and data analytics, with an invited speaker from ISRO, Dr. Shefali Agrawal, and chaired by Dr. Eshan Jha, our Deputy Director General of English Engineering, and Dr. Sehgal as a co-chair. Again, followed by, we had drone remote sensing joining from plant phenomics to precision agriculture. Again, Dr. Suresh Kumar Chaudhary, Deputy Director General NRM, and Dr. Vishwanathan, they could conduct the session. There I could deliberate. Then third session was the science and policy for the drone technology in agriculture, was a talk given by Sunil Gorantika, and also chaired by Professor Indramani, Honorable Vice Chancellor from Basantrao Naik Krishi Vidyapeeth, and also co-chaired by Dr. Onlai, ADG ICT. So, and it was very interactive sessions. And I would, before I end up, so I should ask a few participants to give their feedback. And before that, we have also taken, before taken a training, we have taken a quiz to see where they stand by. Like physically, we have done Alpha 73, and also online Google form we have developed and taken the record of that. And also yesterday we conducted again the same quiz here and also online. We'll try to evaluate them and come out with the results and share with you. And now I would request one or two participants to give their feedback. How did they feel, and critical feedback, what you wanted to, could have been better if at all, to improve further in near future. Anybody from you? Yes. You can come here. Okay, okay, you can do from there.
I'm Dr. Kriti from Dr. Krishna College of Engineering. I'm associate professor in AI and Analytics Department. And I'm very glad that I'm attending this workshop, and it is very informative. And I get so much information from this workshop. I'm working on the maybe using machine learning models. But some still are missing from my side. But during this workshop, it will start from the basic and goes to the next level. And we want that from the remote sensing, airborne all these things we completely in that in theoretical as well as in the practical. And it is very informative for me, and I think all the participation and in the hybrid mode too, we can use that thing in future if we forgot some point at there. So we can use the YouTube link and revise that things also. And I want to say that all quiz are taken as the assessment for us, but in next time I would like that some practical sessions provided to us and some practical modules given to us. We will complete that and submit to you if we are doing right and wrong. You can evaluate that, sir. And thank you so much to the Mr. Sahu and team, and thank you so much to all, sir.
Good afternoon to dignitaries on dais and all here. Sir, it gives me immense pleasure to share my experiences. I am Dr. Alasin, working as scientist in Indian Institute of Maize Research. And sir, the training has been very well balanced. And to me, who was never aware about these things, it has given me a very good primer. And so it is very inspiring to see that while we joined at 9:45 or 9:30, the whole team under the guidance of Dr. Sahu has been used to work since 7:30 in the morning. And they are experts of their domain, and they are putting so much energy into it. During these last 10 days, we have really understood many things. And Dr. Sahu sir, your enthusiasm has been very inspiring, and as it has always been a two-way interaction with you. Sir, what I feel is that whatever you have taught us, and we would like to remain updated with wonderful research being done at IRI, and where we can also act as a link between that research with the farmers on the field. And so for example, Dr. Kushwaha was mentioning about generation of more data for region-specific SOPs, so where we could contribute in that also. And sir, like you told about the Every Sanji Science campaign, I felt like you and your team, under the guidance of all the people in IRI, you are also on a campaign for rapidly disseminating this remote sensing technologies. And we hope that we will remain guided by you for all, with IRI acting at the apex, and the Institute, Crop Sciences Institutes working as a link between that research and the farmers. Thank you, sir.
Yes. Good evening. I am Dr. Rauf, working as scientist in the Division of Agriculture Engineering. First and foremost, I must compliment and congratulate Sahu sir and his team for organizing this training. And the best thing about this training has been that the diverse group of students and the researchers that has been in this training, everyone was feeling that this training is particular to their discipline. Everyone was having the part of this practical city or the knowledge from this training. And one more thing that about this training is the lectures they have organized. It was like the hyperspectral having the lot of number of bands and with very fine resolution. It was like the training for us. It was we were having the fine resolution of knowledge as well as the skill. What will be in the future? I would like that we can add the number of days so that we can have additional practical sessions in this training. That will be better for all. Thank you.
respected dignitaries on the dais, all the senior faculty members, and my dear friends. First of all, I would like to thank the organizer for giving me an opportunity to participate in this program. It was very well organized and systematically executed program, and it's really a teamwork where each and everything was taken care of. And it started from the basics with the remote sensing, hyperspectral, UAV, and satellite image processing, UAV image processing. Like we have got all the aspects, even our basics, ML, big data analysis, and all the aspects that has to be covered as a part of this. There is nothing that is left. And we have got the knowledge of many of the things. And the thing is, when we do it practically, we will face many difficulties. And we came to know the pros and cons of these technologies. Also the policy level implementation, because that's also very important things. I'm from Kerala, so in my state, for the practical application, there are lots of difficulties in utilizing this technology as far as infrastructure is concerned, policy decisions, and all other things. So, it should be a team effort, and I feel like if we come across any difficulty, we have somebody to support us. So in that way, and I would like to thank the coordinator, Dr. Ravi Sahu, sir, and his co-coordinators, Dr. Rajkumar and Dr. Rajiv, sir, for organizing it in a well-structured manner. And all the team members of Agriculture Physics Department for the teamwork. Thank you very much.
Good evening all. Let me introduce myself. I am Dr. Sharjit MC. I am from Center for Water Resources Development and Management, CWRE, under the Government of Kerala. So at the outset, let me thank Dr. Ravi Sahu sir and his team for conducting this training and also giving me this opportunity. As everybody told, the training was well structured and really fantasticously executed training. So, and especially all the lectures were immense, from both the in-house presentations and also the outside lectures were really marvelous, and we have gained immense knowledge out of it. And I'm sure that this training has laid the stepping stone for most of us in conducting research or other application using the airborne hyperspectral remote sensing techniques. So that is one thing, and also I take this opportunity to highlight some of the one important drawback which I felt is because I belongs to the faculty group of this training, so we were not given any accommodation. So coming from Kerala, we found it difficult to find good accommodation around. But after 2-3 days, I could manage something. So, but that is something you have to look in your future programs. Then as far as our institute is concerned, we also have the spectroradiometer facility, and since 2015 the institute has that facility. And also I work with hyperspectral spectroradiometer data since 2010. So we are having that facility, and also we have a well-equipped state-of-the-art analytical facility for the soil analysis and also for the water quality analysis, and also radio pressure facilities are also available. So institute is in a position to cater all the needs. But the problem that we are facing is we neither belongs to the group of ICR institutes, we neither belongs to the group of CSIR institute, we neither falls in the category of MHR institutes. So because we are under the government of Kerala, so there's a separate council for this science, technology, and environment group. So we'll be most of the time we are neglected or we are not considered. So in your future missions, or if you have some programs, you kindly consider our name, CWRD. We are having that, and we are having a group of scientists of diverse domain, including hydrology, all kinds of things. So I just want to highlight that particular thing, and also we look forward to the potential collaborations in future to work together for anything. And we are open, especially our administration is really open to anything related to science and national building. So with this, I conclude. Thank you. Thank you very much for everything.
Good evening to all of you. I'm Sagar Karande from Mahatma Phule Krishi Vidyapit, Ramli, Maharashtra. Sir, I'm working on a serious disease which is occurring in Maharashtra on neem tree since last 2-3 years. So it was difficult to me to diagnose a disease on the trees which have more height. So and that time I interacted with my guide to work on remote sensing. I wanted to put one objective in my research, but due to lack of guidance, I couldn't. So I can now add that objective in my research whenever I go to my university. And I just wanted to thank you all of you for giving us this opportunity. And I wanted to quote just one thing that the science is ruled in past, science is ruling us, and science will rule in future too. So I think thank you for all of you. Thank you, sir.
Okay, anybody? Yeah. Introduce yourself.
Myself, Gautam Ranjani. Actually, I'm from Manipur, but right now I'm pursuing my PhD program from IGKB Raipur. Actually, I would like to thank Sir so much for arranging this program and selecting not only from this campus, but from many other campuses as well. And I would like to thank all the dignitaries for letting us meet face to face. And I would like to thank all the organizers also for arranging such a coordinated program. And sir, I would like to thank all those specialists who have come to taught us about what remote sensing is from the basic, and then from mission planning. We don't know what is mission planning before. We just know what is remote sensing, the differentiating of the color only. That is what we have known the basic. And then we have come to know about processing, and then what is auto mosaic rectification, everything. And later on, sir, what I would to suggest is if we can know more about what we have said about the remote pilot that we have got certification, if we can do more on that, as I would like to suggest that. Thank you so much.
So thank you all. So this is what the feedback was, but because of the time constraint, we can't easily take out.
And now, sir, we have compiled all the lectures and photographs, whatever they are, to provide them in a pen drive. And also we are going to put on our server. Those people who are online, they can always access, and YouTube link also to anytime to access on the NHCP website to see those lectures, revisit again and again. So I would request our chief guest remotely to inaugurate that manual, what we have. Can you do that? Yes, sir. वहाँ नहीं दिख रहा है, वहाँ नहीं दिख रहा है. हाँ. Yeah. It's not moving. No. Huh? So can you press it? Yeah, it's animation movie. Can you do that again? Do it. So we have prepared a background note with all basics, whatever, in a very simple language, and also all the lecture notes. And many may not be there. It's going to be available very soon on the server, also NHCP website. You can always download that. You can do. Yeah, pull me. You hang over. Yeah, sir, slowly. Okay. Yeah. Sir, we had many international speakers also. At the end, we have speakers from Purdue University, Professor Melba Crawford, who is a renowned scientist, work with the NASA, and also high throughput phenomics. She's a AI expert and Dean on Computer Science Department in Purdue University. And also we had Robert Carson and his team from US who could visit here from Europe, and they could have a live demonstrations with my Indian partner, Electrotech International, who are here. Mr. Anand is here. So they had a live demonstrations how the system is working, not only in the field conditions, also from the drone, and also lab conditions for the sorting and grading of the fruit and anything. So this is what all about the lectures. And I think it's over. Leave it. So thank you, sir. Thank you.
Thank you, sir, for your tireless efforts to make this program a success. Now, I would request Dr. C. Vishwanathan, Joint Director IERI and PI, Nahib CAST, for his valuable remarks and introduction for the guests.
Good evening to all of you. So once again, I welcome everyone for this training program. First of all, I thank Dr. R.C. Agarwal, the Deputy Director General, Agriculture Education, and also the National Director of the National Agriculture Higher Education Project of ICER for this valedictory function. In fact, this program is running under the NAHEP cost, and we are grateful that you could spare your valuable time and come here for this training program, sir. I welcome Dr. Anuradha Agarwal, our National Coordinator, NAHEP cost. She is always ready to approve any proposal which we send immediately and facilitate all the activities of IRI. I welcome Dr. Anupama, Joint Director Education and Dean IRI for this cost training program. Dr. Segal and Dr. Rabi Sahu and the course coordinators, Dr. Rajkumar, Dr. Rajiv and their team, Salini and the entire team member. So first of all, this is a wonderful training program that was organized on the hyperspectral remote sensing as well as the use of the drones in different applications. So the digital technology is taking the world by storm, and the future the DNA and digital technology, these are the two technologies they are going to rule the world. And in the agriculture 2047 vision also, these two technologies have been given adequate emphasis. So in this direction, we have initiated this program on the higher education program, the CAST program on genomic assisted crop improvement as well as management. So earlier we thought the genomics only mainly useful for the crop improvement, whereas now it is also useful for the crop management, which is, well, you are seeing this. So to facilitate the student under these areas, we established the facilities which are called as Discovery Center. One is for the genomics, and the second one is for the drone remote sensing and big data analytics. So I am sure these facilities are useful for the IRI students and also the students from and faculty from other places. The second aspect of the CAST project is on training the students. So some of our faculty members expressed their concern. So this was a higher education program. So main focus was on the students. So we have called only the student, and if some faculty voluntarily come on their own expenses, we have also accommodated them. And for faculty, already education division is running various training program. Hence, this program was mainly restricted to the student in terms of providing financial support. Otherwise, both faculty and students are always welcome to this training program. Sir, so far we have conducted 20 training program. This is the 21st training program. So already in these training programs range from 10 to 13 days. So almost about 1,034 students have participated so far in the earlier 20 training program, and with this training program the number crosses 1,100. In addition to that, we organized 2 international workshops and 6 workshops which range from 2 to 3 days. So in this we have almost about 1,314 trainees have participated. Besides that, we have also training our students and faculty at international laboratory. So far, 19 students have been trained abroad. The duration ranges from 1 month to 3 months, but some of the students which we sent during the COVID time, because of the COVID, their duration got extended. They stayed even up to 8 months. NAHP was kind enough to provide fellowship for the students, those who stayed beyond the training program. So this is in brief about the training. I am sure our DDG sir and national coordinator will appreciate the report presented by Dr. Sahu. So I need not repeat that again. So I welcome Dr. Anuradha Agarwal, madam. She is earlier our faculty member. Now she is our national coordinator at for the CAST project. Madam has specialized in plant genetic resources, except conservation and cryopreservation and agriculture education. She has obtained her PhD from Delhi University, Department of Botany, University of Delhi. Madam has won several awards and honor. 2 I want to just mention only 2. One is on the she has Vice Cast Fellow, and she has also won Punjab Rao Deshmukh Women Agriculture Scientist Award. Madam, we welcome you for your support and guidance in this program. Indeed, it is my pleasure to introduce the chief guest of the today's function, Dr. Rakesh Chandra Agarwal. Sir was born in Mathura, Uttar Pradesh in 1963, and he is our alumni. We can proudly say that he is one of our alumni of this institute. He did MSc and PhD from IARI, that is his alma mater. So we welcome you, sir, to your alma mater. So currently, sir is the Deputy Director General Agriculture Education and also National Director, National Agriculture Higher Education Project. In fact, after he took over as National Director of the NAHP program, he revitalized this program, and several activities he started, and now you can see in almost all the state agriculture universities which are of important. This program is running very successfully. Sir, this program was really very useful for the UG student in the IDP and PG student in the CAST project. Both student and faculty, really they got benefited immensely from this NAHP project. Sir has joined as a scientist in 1989 at ICAR, and he has served in various capacities. His research areas include biodiversity informatics, information management, intellectual property rights, farmers' rights, and agriculture education, and wherein he is currently contributing extensively for the agriculture education. And his contribution has been rightly recognized, and he has been awarded several awards. Some of them include Dr. B.R. Barwala Award in 2017, and Lifetime Achievement Award, the Society for Community Mobilization for Sustainable Development in 2020. And he has won the ICAR highest award, that is Rafi Ahmad Kidwai Award, for his achievement in the agriculture sciences, especially his research on the social sciences. He also served as Vice President of Indian Society for Plant Genetic Resources, and he has served in many international committees, and he was a member of the governing body of the International Treaty of Plant Genetic Resources for Food and Agriculture. So he has been elected as fellow in various societies, and most importantly, he is a fellow of the National Academy of Agriculture Sciences, India. So with this brief introduction, I welcome you, sir, once again to your own program, and I am sure your presence is a great motivation, not only for us, but also for the student. Thank you very much, sir. Thank you.
Thank you so much, sir. Now I would like to humbly request Dr. Anupama Singh, Dean and Joint Director Education, ICAR IRI, for her valuable remarks. Now.
Thank you so much. Very good afternoon to one and all. It's in fact a very, prized, I would say, opportunity for me to be, here and also to put up some of my thoughts that I had for the context of this training. Because it's very much like, as Dr. Sehgal said, that agricultural physics is unique in its own sense. Similarly, as without physics and chemistry are the drivers of everything in this universe. I think every one of us will agree. And I, being a out a chemist, so, my thoughts when I was given an opportunity to be here, my thoughts went on to, as what is actually needed to amalgamate is one that we are talking about the UAV technology, but what is actually needed to be applied is something which is chemistry based. So that is the ULV. That is what we say, those formulations, those products and all. And fortunately, or luckily we can say, my group and the Division of Agricultural Chemicals, and we are, in a mission mode working on the right now, these UAV compatible products for basically the crop protection, health and whatnot. So that idea came to my mind that, this is a time when the next step forward from here is when we have established so much in terms of excellence out of this, outstanding program that we had at IRI. Now this next step forward, as I have discussed already with Dr. Sahu also at another point, and myself and my colleague, Dr. Vishwanathan, we are already, discussing on that. Some of the students of the Division of Agricultural Chemicals of my lab, they are already working in PM fellowship scheme on that. So this is, that is the starting point of my just 1 minute or half a minute, thoughts here. So that is another step forward that I'm thinking on, that should now go forward. That what is to be applied, that is the product line, which is compatible to be applied after we have the smartness. And because smartness is today the key to everything. So, mechanical smartness now we have achieved. Now, in terms of what is to be applied, that smartness also has to be achieved through the development of those technologies. Because referring to that last session, I think, which was narrated just now by Dr. Sahu, that was on the policy. And when we talk about the policy now exists on this. But then what is to be applied? For that, India as on date, Indian industry as on date is also, fiddling with that. Because when we talk about the multinational companies, they are, doing fast track research on that. And as Bayer is also there, is very actively doing work on that. But Indian industry is still in its infancy. While moving on to, the field of the drone compatible products and the formulations and on. So herein is an opportunity now in the next session of phase of the research on campus about, how to now amalgamate and how to make best use of the smart system that has been established. and making use of the indigenous technologies that are developed to develop a complete smart technology package, which is indigenous and which is completely, complying to the requirements of the what we say as Make in India. So, this is what came to my mind. Thank you very much for giving me this opportunity. First of all, I have few points, which I just tried to write down while the previous speakers were making certain points, and, my few thoughts on that. One is that, Dr. Sahu, what I was thinking was that you showed here a fabulous resource material, which has been developed out of the training here. But, as Dr. Viswanathan was also saying, number of such trainings have now, they have happened, and lots of good, very excellent and outstanding resource material has got generated. So the first thing which I feel in the chair of the Dean of IRI, that now this should be made accessible, means there should be a structured effort after the successful completion of this program, that the total, all the components of IRI ecosystem should be exposed to that now. So that so far it was to the invited participants and all, but then now there should be a structured program on that as to how each and every division, each and every unit, all the outreach people, irrespective of their backgrounds at all, they are exposed to this excellent system which has been established. Because this is based on, a general feedback that I have been getting, that, a section of the faculty and the students have got advantage, means this has to be taken in a very, very positive mode, because based on some feedback, we move to the next. So how to make, other people feel that this is also theirs. And now this from here start, how will you make best use of it to start the new research problems, new research ideas of the capacity building and all. So that's all, from there we'll start. Now it's a beautiful groundwork that has been done now. So this is one thing. Another thing is, as Dr. Sehgal, you pointed out that, remote sensing as a separate discipline. So on that, we can have a brainstorming, and then based, at the interface of the research and the teaching, and accordingly, we can then propose a definitive proposal to the competent authority of IRI, and to make it really working. But sir, through this platform, Agarwal sir, I would really like to say this thing also, and I have also, I had also put up a proposal while being as the head of the agricultural chemicals division. Sir, physics and agricultural chemicals, in spite of their tremendous importance across the NARIS system in various disciplines, these are the two disciplines, sir, that must be made functional, or they must be implemented across as the disciplines in each and every state agricultural universities. Why I'm saying so? So I will just take, sir, a few seconds to make my point. For example, if referring to, just like physics has a point, so similarly, sir, like for example, if a particular laboratory has to be NABL accredited in some part of the country, and there some people have to be employed to take care of the analysis and the multi-residues and all the instrumentation techniques, then usually if you will do the survey, you will find that either they are entomologists or they are the plant science people, but they are not from the agricultural chemicals. So similarly, sir, it is the agricultural physics also. So, sir, these are two very, very important disciplines, which I believe, sir, under your leadership, now this is right time to make a new, era in the NARIS system. That will make, sir, two-way benefits. One is that, sir, cutting-edge researches in these two fields will make a way, sir, at national level. Second part is that, sir, this is going to, help create the employment opportunities for those who are trained, from the institutes like IRI and some of the very good universities. So, sir, well, this is a point which we can take later on, sir. So, there is so much to say, but thank you very much, Dr. Viswanathan, Dr. Sahu, and Dr. Sehgal for giving me this opportunity. And a lot to say, but yes, time is less. So thank you very much.
Thank you, ma'am, for highlighting the importance of UAVs in agriculture. Further, your inputs for the future. Now, I would like to request Dr. Anuradha Agarwal, National Coordinator, NAHEP, CAST, ICAR, for her valuable remarks. Ma'am.
Thank you very much. Respected dignitaries on the dais, off the dais, faculty and student trainees, and all the people who have joined us online. On behalf of the NAHEP and particularly the CAST group of projects, it is indeed a great pleasure to be here today and to see the excellent training that has been conducted by Dr. Sahu and his team under the leadership of Dr. Sehgal, and of course, Joint Directors, Research and Education. I could feel the palpable excitement from the feedback of the trainees. And that has been a very satisfying factor because under NAHEP, it is one of the major objectives is human capital building in the area of agriculture. And the fact that this training related to drones and the related technologies, the basics and the applied aspects, the theory and the industry interaction goes to show that the program was conceived very well. Dr. Sahu, congratulations for that. And he has outreached many people much beyond the capacity of the initial planning. Again, it shows his enthusiasm. And now you people have become the brand ambassadors for this exciting field. I wish I was like half my age so that I could study this subject all over again. So this particular field is like what biotechnology and molecular biology was like 4 decades ago. So you people are at the cutting edge of technology. You are the ambassadors who will take agriculture into a different plane altogether by applying these technologies, taking it to a wider audience, teaching about it, and applying it in the field. So as brand ambassadors, we would expect, because training is the beginning, in NAHEP projects, we are always talking about impacts, outputs, and finally the impacts on the society. So we expect you to have a real dent in how we do agriculture in the country. You will be the people who will make the U-turn where farmer families, children are leaving farming, agriculture value chains, and returning to this very exciting field, which can be now, I mean, the sky is the limit. You are using the sky to obtain the data. So it's going to be a very, very interesting field. From your feedback, I have noted that some of you have expressed difficulties in coming all the way from difficult areas. First of all, congratulations to all the people who have come from South and Northeast in this terrible Delhi cold weather. You have come on, some of you have come on your own expenses, and we deeply appreciate that. And we will in future try to rectify it to extend this courtesy of participation to a larger audience as far as possible. But I am sure this experience will now be a step in the right direction for your future endeavors. And you have spoken about more practical sessions. In fact, that is one of the questions I had in mind, Dr. Sahu. How did the online participants have the feel for the practical sessions? Maybe since yours was a lot of ICT based.
So we travel with this camera in the field.
Oh, great.
Doing mission planning and everything, and flying the drone, everything.
Okay.
So always the camera was with us.
Okay, that's great. So really, what we are talking about blended education in future, you're already practicing that. We will be using your experience in our international conference. We have an international conference scheduled in the last week of March, March 21st to 23rd on international, it's an international conference on blended learning ecosystem. So blended learning is all about hybrid learning and how we are going to use ICT tools to impart education in the future. Dr. Agarwal will give more details upon that. So it's very exciting to note that you have already started practicing it, and we will definitely be sharing this experience in our conference. So in fact, on behalf of NAHGB, I would like to have feedback, written feedback from all the participants about the pros and cons for our documentation. It helps in improving our subsequent training programs. And on my behalf and on behalf of all the NAHIP team, I extend congratulations to you, all the best, and have a safe journey home. Happy Republic Day and Jai Hind.
Thank you so much, ma'am, for your motivation. I now request to play the video to brief about the program.
It was two minutes. Hello, Binu. टाइम लगेगा तो बात भी करेंगे। Please continue. Let him. He's bringing the lab which is there. Sir, we can continue. He's bringing from the lab the recording. So we can continue at the end. Oh, okay. So before sir address, I would like to tell that since we have 73 participants, we have distributed certificate already. Just now we have distributed. I would like to take your kind permission for that. You know, we have a post-fact approval always. So since it will take a lot of time to distribute physically, so I would request all my participants, take out your certificate, stand up and show that, so that then I would request sir to come over here and address all the participants. Yes, just. And sir, we are distributing online certificate online through the online system. Once they register, then automatically they will receive the certificate. Thank you. Thank you. Now I would request sir, please address.
Thank you very much, Dr. Sahu. And thanks to Dr. Vishwanathan, Dr. Anupama, Dr. Sehgal, my colleague, Dr. Anuradha. So it's really a pleasure to be part of this valedictory program for a very important training program on this drones. And that too, especially being conducted under NAHIP, National Agriculture and Higher Education Project, which is a buzzword now. Yeah. This is a buzzword now, NAHEP. You see the social media, you see any university, everywhere you will find posters of NAHEP. And people have stopped saying students, especially. I went to Srinagar and these students were saying that we are not Quest Kashmir students, we are NAHEP IDP student. So that is the kind of reflection by these students, because a lot of funding is being done. And especially you must have realized after attending this training program that how important this project is doing. to impart training, to send these students abroad, to do every kind of thing, to have caste like under which you have attended this training program. So we have this 16 Center of Advanced Science and Technology centers. Then for UG programs also, you must have not heard that anywhere the undergraduate students are being sent abroad at a cost of 20-25 lakh rupees by the government, by not taking even a single rupee from the students or from their parents. So that is the kind of initiative ICAR has taken, and that's really a very wonderful program. And especially this program, let me just come to the feedback which has been given first by the students. The students like accommodation, like the practical experience, yes, that is all a limitation. And for practical exposure or for accommodation or any other constraint, that always will remain. So it is in the trainings, what you really achieve, that is more important. So you have to, or I can say a good teacher is the one who will just provide, who will force you to think something. So I think that you must have achieved. You are thinking in that direction. You can explore more possibilities. You cannot become master even if they conduct this training for 1 year or 2 years or 3 years. Okay? Still you have to practice, you have to read on your own, you have to create your interest, or I can say that you have to change, you have to develop your attitude. I think you will all agree. We have to develop the attitude for learning towards all these things. And as you know, it's a famous quote that it is more important, the attitude and not the aptitude takes you to the altitude. Right? So attitude is more important. So I think that attitude you must have achieved already through this training program. And you should go happily and just devote your time to learn more and more, to interact. So that network has already been developed among yourself, with the faculty, with the other speakers who have come here. And especially they told that these speakers were there even from many other countries. So that's really a rare opportunity which you can get. And learning is a never-ending process. Till death, we keep on learning. Never we can say that we have learned even 0.000001% of what exists on this earth. So let us keep learning, and this is part of that learning only. Only a ocean and drop a drop in ocean, I think, is only what we have learned in this training program. It was for 7 days, 6 days, 10 days training program. So that is one thing. The second thing is the drone is really the next generation technology, and we have to shift to the technology. We cannot keep on giving the excuses that no, we are the poor nation, we cannot afford these technologies, we have to have our all traditional methods. No, we have to change, because we have to feed more and more people with less and less resources, and that is possible only with the technology. Whatever technology, it's seed production, it's a new kind of seeds, it's a different kind of mechanical things, remote sensing, whatever is there, but we have to take use of. And this is one of those technologies, drone technology. Like in very less time, in 1 hectare, you can just spray in maybe 5 minutes, 6 minutes, and with the less effect on your own health. Otherwise, you have to take the entire pesticide, insecticide on your back and then spray, and then you also have the health hazards, many things. So it's a total good solution, I can say. And especially if you see this year's Nobel Prize also. So that again puts a lot of emphasis in physics. In physics, the Nobel Prize, it is for the quantum entanglement, right? Which gives more emphasis for the quantum information science. And in future, you will see that more and more powerful computers will be coming with less and less energy consumption and less space, and more powerful in computing with that. And then these drones will also sync and will have very powerful tools for AI, for I can say machine learning, for every kind of thing you will have. So the world is really changing. Everything is moving towards the green, and this is also a movement towards that. So in that, once those computers comes, or once the new technology using all these AI-based solutions will come, then our life is also going to change. And we have to adjust in that new life. I just always quote an example. We have to change our mindset. Like I can quote around 15 years back, our seniors, now we are seniors. Our seniors, they were very hesitant in using the credit cards. Okay. Always they used to go to the bank and take the check. Because that time just it was introduced, and they had a lot of apprehensions on that. Once I use the credit card, maybe my whole bank balance will be debited, or somebody can take the money, or they never went to the ATM machine, always draw the cash from there. But now people have changed their mindset. No, it is all secured, because we have changed the law also. The cyber law came, the other technologies came, now mobile came, you get the triple security, you will get OTP, this, that, everything. So they are all evolving. So even today, or you see Delhi Metro, it is running without driver. Okay? But there are many persons, if you tell them that this train in which you are sitting is not having any driver, so they come out and then they say, no, I will not sit in this train. So your mindset has to be changed. And you also think in future, if you are sitting in a car, it's running very fast, and you see that no, there's no driver, you are just sitting in the back. So first you have to change your mindset. So for drones also, we have to really, rather I can say in the future, which is going to be totally technology based, a lot of things have to be changed. I think many of you must have used, there is a very cheap robot, which comes just for 20,000 rupees and which will clean your whole house. Okay, you just feed the time, and then it maps your whole house, where is the door, and how, where is the other items. So it will, and you just feed the time, 4 o'clock, 5 o'clock, and it starts. And whenever the charge is finished, it knows where is the place for coming back and getting it charged. So you never know, and it will do the whole thing. But that thing is coming true for every kind of thing. So for that, I think this is very good preparedness towards movement of the technological revolution. And for that, our institute, IERI, has done a lot of good work. They are, I can say in India, at least the pioneers. They started working in this when people were not even knowing, like the computers. We were using the computers in 1983 when we joined MSc in IERI, and in whole ICR, I can say, and rather whole NARS, National Agriculture, that includes all universities, every agriculture department, there was only one computer, and that was in ISRA. But now you see everybody is keeping the 1,000 times more powerful computer in their own pockets, whatever computer used to be that time. Okay. So, you know, in economics, I think some of you may be from the economic sides, there is a law of diminishing returns. But in IT field, it is a law of accelerating returns. So you pay less and less for more and more power. So that time, the computer was having, I think the floppies, they were having, you will not believe, many of you will not believe, 356 kilobytes was the maximum size. And that is just one letter, if you write, it consumes 356 kilobytes. Having programs on that, having everything on that, having your application on that was really a tough task. And it was costing 300 rupees at that time when we were getting the salary of 1,500 rupees. So 1/3 of our salary was just one floppy. Now you see, we are getting 3 lakh rupees salary. And the cost of even pen drive is just nothing. People just freely distribute it. So it's a law of accelerating returns. The Moore's law also works. So in times to come, the technology will be so much that everybody will be able to afford, even our farmers, small farmers, marginal farmers, large farmers. Nobody can say, even today you see everybody is having these smartphones. It's not very expensive thing. Everybody can afford the calls. Everybody can afford the data. Everybody can afford the high bandwidth. So until unless we change our mindset that yes, we have to use the technologies, we have to convince the farmers, we have to put more efforts to work more in the research in that area. And I think keeping that thing in view, such trainings are required on a very massive level. About 10 days back, I was in Tamil Nadu Agriculture University. Anybody from TNAU here? No. I was in TNAU, and when I inaugurated one program there, and during that day, there was a massive drive to recruit 600 agriculture graduates by the Garund Aerospace Private Limited. 600 numbers, and about 1,200 students, they participated, and they could select only 100. They could find, as per their eligibility, only 100. They have to recruit more students, 500 more students. And I have contacted other universities also for that. So that kind of really a massive drive is required. That how in each district we will have one drone expert who will coordinate, who will have this custom hiring centers, how we can reach to each and every farmer. So that kind of movement is really required. And you see what kind of drones we have. Every kind of drone, even for surveillance, for remote sensing, for spraying, and for all kind of sensors, every kind of thing they had. So until unless, and that is the reason why in the revised course curriculum also, we have included this AI and machine learning and other kind of IoT based solutions as one of the courses, so that students, irrespective of what discipline you are studying, it is part of your learning. Like AI, can you say that my discipline is such that I don't have any AI application? No. In times to come, everything will be having the application of AI. Even today, can you, if you are a PhD, right? And if you don't have the computer knowledge, can you say you are educated? Can you depend on somebody else that, okay, this is my password, this is this thing, please do my online transaction because I am illiterate. Okay. Drop my money from my computer, from this account. You cannot. You have to learn that much at least so that your money is safe. You cannot depend. Can you ask somebody that you please do my railway reservation, or I need training for the railway reservation first, for 2 months training I have to go, and then I will know, yes, how to do this railway reservation? No. So automatically you have to learn because it is required for your survival. So similarly, irrespective of your discipline in future, it will be an essential thing to know basics of AI, so that at least in whatever area you are doing the research, you cannot say that this AI, no, it's something different, I have no interest. At least to interact with those persons who will work for you, so that you are on the same wavelength. So that much has to be there. And now I think you become the ambassadors for IERI. Instead of coming again and again for getting the training, you can train others and give the message, whatever is there, and do more work in this area. And whatever support from ICAR is required, we are always ready for that. And knowing that there were so many applicants, more than 600 applicants were there, and they have selected only few. So that indicates that we have to have more and more such training programs. Under NAHIP, we have supported many universities, but especially 2 universities, MPKV Rahuri and Parvani. So these 2 universities, they are doing very good work in the IoT-based solutions. IERI is, of course, one of them, but it's not the major CAST center for this drone-based technology. It is for the genomics. It is only a part of that they are doing. So still doing such a good work. Really, Dr. Sahu and Dr. Sagal, we are thankful to you for taking this to its very greater heights and bringing so many students. And we are, I spoke to the Vice Chancellor of MPKB Rahuri. They also have started 1-year certificate course, and they have got this license also for the pilot training. I asked them that there is so much demand by these students, agriculture graduates, and as per this national education policy, we have to provide all these students every kind of facility to learn anything, whatever they want to learn. And that is the whole concept of this NEP. So if somebody is interested in learning this about the drones or IoT based solutions, so can you develop some online courses for this? And they have agreed. And very soon they will release that online modules, and through MOOCs or through some other kind of platforms, we will really provide such kind of training programs so that we become really ready. Our students become future ready, and we can rule the whole world in the technological field if we go on the same pace. And we can say that yes, our each and every student is having the minimum knowledge about these technologies, whatever are coming for the future or exist in this world. And I can again say that nobody can predict the future. Nobody could predict that there will be a situation like a lockdown. Nobody could even visualize that there can be a lockdown like when everything is standstill. But we were all ready for meeting the challenges. So we have to be now ready for meeting any future pandemic, any future problem which comes. And that is only once we make our students ready with all that. We always say India is the youngest country. Why we say we are youngest country? Because our average age is 28 years. US, the average age is 36 years. Germany, the average age is, I think, 45 years. Japan, it is 42 years. So we are the youngest. The average age is, and China's case, you must have heard just 3 days back, their population is shrinking now. We have still 1.2% growth rate, but it is coming in minus now. So we have to take advantage of this population dividend, and that is only once this young generation is properly trained, is ready to meet any challenge, then really in times to come, we can become the world leader. We can become really the driving force for any kind of problem in the world, like it happened this time. We were the pioneers in developing the vaccines against this COVID, which was very unusual. Nobody could thought in the world that India can develop some vaccine. And the person who developed this vaccine, Krishnella, Covaxin, he's agriculture graduate. He's a student from University of Agricultural Sciences, Bangalore. And I think in Akola also he was the student. He studied 2-3 agriculture universities. So that's really the vision we should have. And for that, let me finish by saying that there is another remote sensing. You must have heard there is a program called Brighter Minds. Any participant who has heard Brighter Minds program of this meditation? So that is also nothing but a kind of remote sensing. What they do is they take these students. We have signed a MOU with them, this Headfulness Education Trust. So what they do is they train these students aged between 7 years to 15 years. Not beyond 15 years, because after 15 years, you have all fixed ideas and you cannot change your neurons and other things. And after getting the training of only 8 classes, those students are so much trained that they can read a piece of paper by closing their eyes, just by smell. Okay. So it is also a remote sensing. If you are playing cards, through smell, I can know that what kind of cards you have got. Okay. Because it's a remote sensing. So what is that remote? That smell is the remote. Here also the remote is what your signals are going, your some kind of medium is always there. So, and even by touch. Okay. So they do the photocopies. Something. So if I want to read this paper, so I saw one student and Dr. Anuradha was there. No, you were not there, but the 41 vice chancellors were there with me. I called all vice chancellors in that center, and that young boy, what is this thing, and then he was knowing what is written in this paper. It looks like a magic. It's not a magic. So you have to train your mind in such a way that you know even the single signals which is coming through different things, because our eyes are not reading anything. It is the mind which is reading. Eyes are only observing that something is written. Then it goes to the mind, and the signals will go through your smell to the mind and through the touch. So let us be prepared up to that level. Let us try to do, let us try to focus whatever is being taught. And I think that was another example of this remote sensing, that how remotely they are sensing, they are reading. And you can see that student was called in that KBC, Kaun Banega Crorepati program. And Amitabh Bachchan, he interviewed that young girl, and she was reading fluently by closing the eyes. So that is the future. Really, we have to understand the science behind that. And being all a science student, we have to really see the science behind everything, but how it works, not the magic. It's not a magic that something is happening automatically. So thank you once again very much for giving me time, Dr. Sahu, Dr. Sehgal, and our officers from IRI, Dr. Vishwanathan, Dr. Anupama, Director IRI, everybody for organizing this training. And I wish all the best to you. And I again commit that anything required from ICR, we will look into this agriculture physics and this remote sensing or whatever agriculture chemicals, that how it can be made, how we can popularize in all the universities. I cannot make it compulsory, but how we can really popularize in all the universities that they must come out with this subject. It's a basic subject, and basic subjects really we should never omit. We have to take care of all these things. And for accommodation, I can again say that we will try that how more and more hostels accommodations can be built into this. Already one more hostel we are going to inaugurate. And this time also we are trying to provide some funds to IRA for having more facilities. So thank you once again, and wish you all the best.
Thank you, sir, for your valuable remarks and giving your perspective towards the workshop. We will try to keep up with your expectations. A small glimpse of the workshop is prepared so that you will carry its memory in terms of knowledge to your respective organizations. So I would request to play the video.
Last part.
So thank you, Tarun, for the beautiful video. So to begin with the felicitation ceremony, I would request Dr. Vinay K. Sehgal and Dr. Rabi and Sahu to acknowledge the guests with a plant and the memento.
Sir, it is a small token of love from our side for your support, guidance, and taking time out to guide us and give your suggestions for us what we have to do and move forward. Thank you, sir.
Ma'am, you have been always supportive, very proactive. Whenever we asked anything, you have been generous to support us. Thank you very much. This is a kind of a token of appreciation, a biopurifier for you. I would request again Professor Binay to give my mentor, my PI of NIHP, who has been all throughout monitoring remotely, Dr. Vishwanathan. Thank you.
Actually, a big round of applause. Such is a big C like IRI. He continues to be dedicated towards CAST and its activities. And he's so busy, he emailed at 2 o'clock in the morning to remind us to come to the program. So appreciate your very personal attachment to all the activities that you take.
And sir and ma'am, this program could not be possible without Dr. Binay Sehgal. He has been throughout with us from the day one till now, monitoring morning and evening what is going on. You can see the kind of So, before formal vote of thanks, if I don't say something, I have my left hand and right hand. They have been my course coordinator, two coordinators, young scientists, Dr. Rajkumar Dhakar and also Dr. Rajiv. I must place a token of appreciation, both of them, throughout working, making the program hold successful. I think everyone knows how they have worked. So I would request our chief guest to give them Dr. Rajiv and Dr. Rajkumar. I must thank to my honorable director in his absence. He has been supportive always and throughout. Being in Maharashtra right now, still he monitors, he always keeps on updating on WhatsApp. Ravi, is it everything going on? Thank him on all the behalf for his kind and generous support, not only to me, to my division and everyone, and also to my whole team of Acres of Physics family who has supported me, because of whom this program was successful. Now I would request Rajkumar to give a formal vote of thanks.
Yeah, but before that, actually, we should thank our course coordinator, Dr. Ravi and Sahu.
Very soon, going to the US.
I'm going to balance here.
Yeah. So everybody wants training.
Dignitaries on the dais, faculty, participants, online and offline both. A very good evening to all of you. It is my great pleasure to extend a formal vote of thanks to all those who have contributed to the grand success of this training and this workshop. I, on behalf of the organizing committee, convey my deep regards and hearty thanks to our chief guest, Dr. R.C. Agrawal sir, Deputy Director General Agricultural Education, ICAR, National Director, NIAF. I thank you, sir, for accepting our invitation out of your busy schedule. Sir, we are truly grateful with your presence, and we are motivated to continue working towards our goal by your inspiring thoughts. We express our sincere thanks to our beloved director, Dr. A.K. Singh. Due to some urgency, he could not join us. Nevertheless, he is our guiding force for this program. My sincere thanks to Dr. Anuradha Agrawal, National Coordinator, NIAF Caste ICR, for all kind of support provided to this program. Thank you very much, ma'am. Thank you very much to Dr. C. Viswanathan, Joint Director Research, IARI and PI of NIAF Caste, for all of your help, advice, support and guidance rendered throughout the training program in this workshop, sir. Thank you very much, sir. We are highly grateful with the presence of Dr. Anupama Singh, ma'am. I think she has left due to some work. Dean and Joint Director Education, ICR, IRI. I want to also thank ma'am for highlighting the importance of agriculture, physics and chemical for popularizing in the agriculture universities, so that our whatever the knowledge is can be generated, or solutions can be generated through the agriculture physics, can be popularized in the other universities. I would like to thank our beloved head of the division, Dr. Vinay Kumar Sehgal, for his overall supervision, guidance and support, sir. Thank you very much, sir. Our sincere thanks to all the chairpersons and co-chairpersons of the sessions in this workshop. Chairpersons like Dr. S.N. Jha, Dr. S.K. Chaudhary, Professor Indramani, and co-chairpersons Dr. Viswanathan, Dr. Anil Rai, and Dr. V.K. Sehgal. My sincere thanks also to Dr. K.M. Manjia, sir, Nodal Officer, NIAF Caste, for his constant support in organizing this event. We are immensely thankful to Dr. R.N. Sahu, Course Director. You know how much efforts he has put in this conducting this program. So he's the key person in the inception, formulation, conducting and making the program a grand success. Thank you very much, sir. Apart from Sahu, sir, Rajiv Ranjan, who is the coordinator of this program, deserves a very great appreciations, along with whole team of Dr. Salini, Dr. Abhishek, Rahul, Manish, Om, Tarun, Dr. Ajit, Pratim, Vishal, and other project staff. So they are behind the curtain, but they did really work hard. So they deserve the real appreciation. I also thankful to our faculty for their gracious presence. Our special thanks to our participants, both online and offline. Offline participants who come across the country to attend this training and workshop physically. And we are extremely grateful to the distinguished speakers who shared their knowledge, expertise, and insight during the training as well as the workshop. We are thankful to our industry partners such as Headwall, Electrotech, General Electronics, IoTech World, Dronextech, and Daksha. So thank you so much for demonstration and exhibitions in this workshop. We also thanks to Dr. Amrit Kumar, Head AKM for uninterrupted internet connection, Olu for floral decoration, Dr. R.R. Varman for providing Zoom platform and live YouTube streaming, Head Environmental Science for providing this accommodation, this NRL auditorium, Mr. D.K. Yadav, AA Plant Physiology for administrative arrangements. So at the end, I thank to all the persons who directly and indirectly contributed in this program to make a great grand success. If I forgot any name, please forgive me. So I thank you one and all. Thanks to NHP cast for providing the funding. I invite you all outside this auditorium for
photograph. You can have here because outside it's a
yeah.
So we wanted to take on the drone, but it's totally dark. We can't do. So if you can do it here itself, then go for the.
So I invite you all for a group photograph, and then after for the high tea outside this auditorium.
I think some people can sit here.
पहले तो साइड में भी आएगा एकदम सामने जाएगा